Hey everyone, welcome to this video on AWS and Azure full course. We will begin this full course with understanding what exactly is AWS and how AWS services work. Followed by that, we will be looking into a bunch of AWS services like EC2, Lambda, S3, IAM, CloudFormation, ECS, Route 53, Elastic Beanstalk, VPC, SageMaker, CloudFront, Auto Scaling, and Redshift. After this, we will be doing a quick comparison of the popular cloud providers, which are the AWS and Azure. After the comparison, we will begin with Microsoft Azure. Then, we will look into Azure and its concepts in detail. Then our expert will give you a quick training on Azure Services. Then we will see what Azure Machine Learning is and also what Azure Active Directory is. Next, we will see what is Azure Directory. And followed by that, we will wind up the session with Azure Virtual Machine and Azure Virtual Network. By the end of this video, I can assure you that all your AWS and Azure career related queries would have been answered. For this training with me, we have our experienced AWS and Azure experts. Together, we will take you through the various topics of AWS and Azure. So let's get started with the exciting video on AWS and Azure full course. Before we begin, let me tell you guys that we have daily updates on multiple technologies. If you are a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn.
Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity, depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lifecycle, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated. Popular services within this domain include Amazon S3, EBS, S3 Glacier, and Elastic File Storage. Rob can also store the user data in a database with AWS services, which he can then optimize and manage. Popular services in this domain include Amazon RDS, DynamoDB, and Redshift. If Rob's businesses took off, and he wanted to separate his cloud infrastructure or scale up his work requests, and much more. He would be able to do so with the networking services provided by AWS. Some of the popular networking services include Amazon VPC, Amazon Route 53, and Elastic Load Balancing. Other domains that AWS provides services in are analytics, blockchain, containers, machine learning, Internet of Things, and so on. And there you go. That's AWS for you in a nutshell. Now, before we're done, let's have a look at a quiz. Which of these services are incorrectly matched? 1, 2, 3, 4. We'll be pinning the question in the comment section. Comment below with your answer and stand a chance to win an Amazon voucher. Several companies around the world have found great success with AWS. Companies like Netflix, Twitch, LinkedIn, Facebook, and BBC have taken advantage of the services offered by AWS to improve their business efficiency. And thanks to their widespread usage, AWS professionals are in high demand. They're highly paid and earn up to more than $127,000 per annum. Once you're AWS certified, you could be one of them too.
Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers. But prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital cost. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries. Using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service, Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL or American Online uses AWS, and using AWS, they have been able to close data centers and decommission about 14,000 in-house and co-located servers and move mission-critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy-to-use service for deploying and scaling web applications and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning to load balancing to auto scaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System or EFS provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files, so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic Load Balancing, it's also a network and content delivery service. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zone and also across availability zones. AWS Auto Scaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS Auto Scaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Auto scaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage, and S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment, and CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well, and it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing. And now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? All right, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. All right, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL. Let me help you understand about AWS EC2, a compute service in the cloud, through this video. Somewhere far in the country, a scientist has a lab far in the woods, and at one day he stumbled on a calculation that he had trouble solving. And he was very certain that his computer can handle it. And he asked his computer to do the math or the calculation for him. And the computer thought about it for a while, then took a couple of hours in trying to process the data. And eventually, at one point, it gave up and died due to low memory. And this old scientist is now clueless about how he was going to finish the task and complete his invention and let the whole world know about it. And that's when he was introduced to this new friend AWS, as you see on the screen. AWS was very handy in replacing his old machines, and it was able to give him the service that he wanted at that moment. AWS has been around for a while helping people with their computer needs, and now this new scientist friend in need is welcomed by the new and trendy IT technology AWS, and sure enough, his new AWS friend welcomed and walked him through the new way of computing. And this new happy-faced AWS friend talked to this scientist about AWS EC2 in specific, and walked him through about all the new innovations in IT and in cloud that he had been missing all these days. So his new friend AWS started the conversation about explaining how there is no need for any hardware units, no managing hardware or provisioning in AWS. And secondly, it explained increasing and decreasing the capacity as per the demand is just a click away. And the best part here is that there is no upfront commitment, and we only pay for what we have used, just like we pay electricity and water bills. And all this comes with complete control from our side. In other words, the whole key for this infrastructure is with us. And as if this was not enough, all this comes with enterprise-grade security that's beyond imagination in on-premises. And if this still does not excite you, then this definitely would. You can work from anywhere in the world. Now this really made the scientist to get excited, especially when he thought about working from home. Working from home, there is nothing like it, isn't it? Now this person, this scientist, is not tied up to a particular environment. He can work from home, work on the fly, work from anywhere. Still, the data and everything else in his IT environment is secure and safe. Now let's move to the next level of discussion. Let's talk about what is EC2 and some of the use cases of EC2. And this use case we're going to talk about, or this architecture we're going to talk about, it notifies a group of users about a new letter. And the components or resources this architecture would need be first EC2 instance, then SNS, a simple notification service, and coupling EC2 and S3 service together. That's all it would require to get an architecture that notifies a group of users about a new newsletter. And now I think it would be a good time to talk about what EC2 is. AWS offers plenty of services offered under different domains like compute, storage, database, migration, network, management tools, media services, security, business productivity, application integration, machine learning, game development, and a lot more coming up, out of which EC2 falls under the compute capacity. So what is EC2? EC2 is a web service which aims to make life easier for developers for providing secure and resizable compute capacity in the cloud. With EC2, it is very easy to scale up or scale down our infrastructure based on the demand. And not only that, this EC2 service can be integrated well with almost all the services in Amazon. And out of all this, the best part could be we only pay for what we use. Alright, let's talk about this use case. A use case here is that a successful business owner has a bunch of users and a successful product that's running, and now he has developed few more products that he thinks will be very successful, that he thinks his customers are going to like. Now how can he advertise his product to his new and prospective customers? Or the solution for this question can be addressed by AWS. In AWS, we can use services like Simple Notification Service, SNS, and EC2 for compute and S3 for storage. We can, in a way, integrate them all and achieve this business use case. And that sort of got this business owner very cheered up, and now he wants to use the service and he wants to get benefited from the service. He wants to advertise or he wants to notify his users every time the company creates a newsletter. Alright, so let's talk about what it would take to get this environment up and running, or what it would take to connect the environment and put the applications on top of it. Firstly, we would require an AWS account, and then for compute capacity, we would require an EC2 instance. And here's how we go about doing it. The first thing is to create an AMI, which is Amazon Mission Image. That's really the software's and the application packages we would need to run our application. And the second is to choose the hardware. In here it's the instance type. Depending on the workload, we would be choosing the hardware, and depending on the intents of the workload, we will be choosing the size of the hardware. And finally, we would configure the instances. How many instances do I want? Which subnet do I want them in? And what's going to be the stop or terminate behavior of the instance, and do I want to update any patches when the instance starts running? All those pieces of information go in here when we configure the instance. And then the first three steps is really about the OS volume and the basic hardware. Now it's time to add additional storage to the EC2 instance. That would be step 4. Here we add additional storage to the EC2 instance. And then tags, we use tags, or we would configure tags to easily identify an EC2 instance at a later point. We give it some meaningful names so we can identify, like which team it belongs to, which billing department it belongs to, what's the purpose behind launching this instance, stuff like that. In an environment where we run 700 to 800 or even more instances, identifying an instance and trying to understand who owns the resource, for what purpose we created, it could be an full-time work. So tagging comes to our rescue at that time. After tagging, as step 6, we would configure the firewall, which is also called security group, for the EC2 instance. And this is where we would allow or deny connection from external world to this particular EC2 instance. Well, it works both ways, from outside and from inside out. This firewall blocks the connection based on port number and IP address. And finally, as step 7, we review all the configurations that you have done, and we make sure that the configurations is what we wanted, and finally click on submit. That's going to launch an EC2 instance. Alright, this was just an overview of how to create an EC2 instance. Now let's talk about each and every step in detail. So to begin with, let's talk about how to create an AMI. Well, the AMI is just a template that's used to create a new instance or a new computer or a new VM or a new machine based on the user requirement. The things that go into an AMI are the software, the operating system, the additional applications that get installed in it, stuff like that. The AMI will also contain software information, information about operating system, information about access permission, information about volumes. They all compact in the AMI. Again, the AMI is of two types. One is predefined AMIs, or called Amazon provided AMIs. The other one would be custom AMIs, the AMIs that we create. And if you're looking at a particular AMI that you don't want to create but still want to get it from Amazon, there is a place or a portal called AMI Marketplace. There we get like thousands of AMIs in there available for us to shop and use them on a pay-as-you-go business model, and use them as pay-as-you-go billing. So there you can search AMI that you're looking for. Most probably you'll be able to get it there. Now let's talk about choosing the instance type. The instance type is basically the hardware specification that's required for a machine that we're trying to build. And the instance types is categorized into 5 main families. They are, to begin with, it's compute optimized. Now compute optimized gives us lots of compute power or lots of processing power. So if my application is going to require a lot of processing power, I should be picking compute optimized instance. And the second one is memory optimized. Now this is very good for applications that require in-memory caching. There are some applications that performs well with cache or through cache, or the application would create a lot of data that it wants to keep in cache for rereading or for processing, for lengthy processing, stuff like that. For those type of application, this memory optimized instance that comes with in-memory cache is a very good use case. And the third one is the instance that comes with GPU, otherwise called GPU optimized. GPU stands for graphical process unit, and this is very good for application that deals with gaming. This is very good for application that's going to require large graphical requirements. And storage optimized is the fourth option. Just like the name says, this is a very good use case for storage servers. And the fifth family type is general purpose. Just like the name says, it's for general purpose. If you're not particular about the family, then you generally would end up picking the general purpose, because here the services are sort of equally balanced. You'll find a balance between the virtual CPU and the memory and the storage and the network performance. It's sort of balanced. All the components, all the features that needs to go in a computer are sort of balanced in general purpose. Now these instance types are fixed and they cannot be altered because it's hardware based. We buy hardware. We do not have much control on the hardware that's being used. Well, we have options, but we do not have control on the hardware. And these instance types are divided into 5 main families. They are compute optimized, memory optimized, GPU enabled, storage optimized, and general purpose. Then as third thing, we have to configure the instance. Now here is where I have a lot of options about purchasing. What type of purchasing do I want to do? Do I want to go for a spot instance? Do I want to go for a reserved instance? Do I want to go for an on-demand instance? These are different billing options available, and that's available under configure instance. Not only that, here's where I'm going to put the EC2 instance. Do I want an public IP address assigned to it? Do I want an IAM role attached to it? IAM role is authentication. What kind of authentication am I going to provide? And the shutdown behavior. The shutdown behaviors include, do I want to stop the instance when the user shuts down the machine from the desktop, or do I want to simply terminate the instance when the user shuts down the instance from the desktop? So those things go in here, just like the name says, configure instance. A lot of instance configuration options comes in here. That's the third step. And not only that, under the advanced details or advanced tab under configure instance, I can bootstrap the instance with some scripts. Now bootstrap is nothing but the scripts that you want to be run in the instance before it actually comes online. Let's say you're provisioning the instance for somebody else. Instead of you launching the instance and then logging in and running some commands and then handing it over to the other person, you can create bootstrap shell scripts and paste it in a console option available under configure instance, and Amazon is going to take those commands, run it on the instance before it hands over to the user that initially requested for that instance. Now it could be a different user or just you. It sort of automates software installation procedures in the instance that we will be launching. And not only that, there are multiple payment options available under configure instance. The user can pick an instance under normal price, and that instance would apply normal rates applied to it. And there are also options like reserved instance, where the user can pay for an instance upfront before a year or before months, for a span of year or a span of months, and that way they can pay less per hour for using that instance. Not only that, you can also go for spot instance, like bidding for those instances. Whoever bids more, they get the instance for that particular time. Well, these instances are a lot cheaper than on-demand instances. And through bidding and buying, you can keep the instance as long as your bid price doesn't exceed the price that Amazon is proposing. And as the fourth step, we will have to add storage to the instance that we are about to launch. And here we have a bunch of storage options. I can go for ephemeral storage, which is free, or I can go for an external elastic block storage, also called EBS, which is paid and it's a permanent storage, or else I can integrate my EC2 instance with S3 for its storage needs. And the best part about storage is free subscription users, they get to use 30 gigabit of SSD storage or magnetic storage for the whole year. In this page where we are ready to add storage, we will have to mention or provide the size in gigabit and the volume type. Is it going to be an provisioned volume? Is it going to be an general purpose volume? Is it going to be a magnetic volume? Stuff like that. They are volume types. And we also need to give inputs about where the disk will be mounted and whether this volume needs to be encrypted or not. So all these options or all these inputs are received from us under the adding storage section. And then the fifth option would be adding tags. Like we discussed some time back, tags are very helpful to identify a machine in an environment where we have 700 or 1000 VMs running. And security groups are the actual firewall that sits in front of EC2 instance, and it protects that EC2 instance from unintended inbound and outbound traffic. Now here is where I can fine tune the access to my EC2 instance based on port numbers and based on IP address from which it can be accessed. And finally, we get to review the whole changes or the whole configurations that we have made to find out whether they are intact with the requirement, and then click on submit. That's going to launch an EC2 instance. But hold on, we're not done yet. When we're about to launch, or before the Amazon console actually launches the EC2 instance, it's going to give us an option to create a key pair. Remember, I said it's key pair. Key pair is two things. One is public and private. The private key is downloaded by the user and is kept with the user, and the public key is used by Amazon to confirm the identity of the user. So just go ahead and download the private key and keep it for yourself. And this private key gets downloaded as an .pem file. It's a format of the file, and it gets downloaded as .pem file. And our next step is to access the EC2 instance. And because the instance that we have launched in this example, let's assume it's a Linux instance, and that's going to require a tool called PuTTY to be able to access it. And this PuTTY tool is really needed when we are trying to access an Linux instance from Windows instance. Most of the time, Windows instance will have PuTTY installed in them, but in some rare cases, they do not come with PuTTY. In those cases, we can go ahead and download PuTTY and PuTTY generator, and we can start using it to access the Linux instance. Now you might ask, well, I understand PuTTY, what's PuTTY generator? Now the file that we have downloaded is in .pem format, but unfortunately PuTTY does not accept .pem format as input. It has to be converted into a different format called PPK. And PuTTY Gen is a tool that helps us to convert the .pem file into PPK file. So the quick way to do it is download generator, open it up, click on conversion, and insert the .pem key that we have downloaded and save the private key. And this, when we save the private key, it gets saved as a .ppk type private key. And when that's done, the next very step is to open PuTTY and try to log in. And the way to log in is to open PuTTY, put that IP address here, and then click on auth. This is where we would input the file that we have created. So click on auth and then click on browse and find the .ppk file that we have converted and stored, browse it and upload it, and then click on open. Now that's going to open up a login screen for us. And the AMIs comes with a default username. Depending on the AMI that we have picked, the username might differ. In our case, we have picked an AMI for which the username is EC2-user, and this is the default, by the way. Let's put the username EC2-user and hit enter, and that's going to open up the Linux instance using CLI. There are a few other things that we can do with the terminal that we'll explain it a little later. Alright, so we have successfully launched an EC2 instance, and give yourself a pat on your back. Launching an instance was just one part of the solution. So let's actually talk about how we can notify our customers. SNS, or Simple Notification Service, is a service or a product in Amazon that helps us to notify customers through email. So navigate to SNS in your account and create a topic. And we're going to use this topic for public notification. So let's make it public and then add subscribers to it. Now these subscribers are the people who you want to be notified about the newsletter. So we already have the email database in there. Add them to the subscribers list, and then they will start getting new newsletters as and when we post them to the topic. And as next step, create a bucket in S3 where you can store content, and in that bucket create an event that triggers a notification to Simple Notification Service. So this is how it will be set up. A notification will be sent to our subscribers anytime we put something in our S3 bucket. So S3 bucket is going to create an event for the notification, and the notification is going to make sure that it's delivered to your end customer because they're already subscribed to the topic as subscribers. And finally, let's connect the S3 with EC2, so the bucket and the AWS instance are in sync. So we put some content in the S3 bucket. Our email system notifies our customers, and the customers can go online to a website that's hosted in EC2, and because S3 and EC2 are in sync, the items that we put in S3 will also show up in EC2. See how this is all connected and it's working together. And once this is all connected, our subscribers will regularly be informed anytime we put new content in the S3 bucket, and the same content will be made available in EC2 instance through the website. Let me help you understand about Lambda. One day at office in a growing company, there was discussion going on between two IT personnel. It was about the new role that his colleague Jessica has taken. Benjamin, the guy standing here, wants to know about it. And Jessica's job is new, different, and dynamic and interesting too. She scale and manage servers and operating systems and apply security patches onto them and monitor all of these at the same time to ensure the best quality for application is given to the users. And Benjamin was awestruck with the amount of work Jessica is doing and with the time it would take to complete all of them. But Jessica, being a very dynamic person, very suitable for the job, said it was easy for her to handle all of it and even more. But that easiness on the job did not last longer. As the environment grew more and more, it being a startup company, Jessica was getting drained and was not really happy about all her job as she used to be. Jessica's manual way of scaling and environment did not last long, and she was also finding out that she missed to scale down some of the resources and it's costing her a lot. She needs to pay for the service that she was not at all using. She sort of felt that she was at the end of the road and there was no way out from this manual task. She was very desperate. And that's when Benjamin suggested something, and that brought back the peace and joy Jessica initially had. Benjamin suggested about a service called Lambda that can ease the work that Jessica is doing at the moment. And Lambda, as happy as it looks like, it's a solution that solves the manual, repetitive work and lot more. And Lambda introduced itself as the problem solver and started to explain the following things, the very same thing that we're going to learn about in this series. So in this section, we're going to learn about the features of AWS Lambda, and we're going to talk about what Lambda is, and then we're going to talk about where Lambda is being used in the IT or in the cloud environment as we speak, and then we're going to talk about how Lambda works and some use cases of Lambda, and we're going to be particularly discussing about the use case about automatically backing up the data that's put in the cloud storage. Let's talk about Lambda in detail. Lambda automatically runs our code without requiring us to provision or manage servers. Just write the code and upload it to Lambda, and Lambda will take care of it. That means that we don't require any server to run or to manage, and all you need to do is write the code and upload it to Lambda, and Lambda will take care of it. Which also means that we can stop worrying about provisioning and managing servers. The only thing Lambda expects from you is a code that's working. AWS Lambda also automatically scales our application by running code in response to each trigger. Our code runs in parallel and processes each triggers individually, scaling precisely with the size of the workload. Scaling here is done automatically based on the size of the workload. Lambda can scale the application running the code in response to each and every trigger that it receives. Billing in Lambda is metered on the seconds. We only pay for the amount of time that our code is running, which means that we're not charged for any of the servers. The only payment required is for the amount of time the code is computed. With AWS Lambda, we are charged for every 100 milliseconds. We are actually charged for 100 milliseconds our code executes and the number of times our code is triggered, and we don't pay anything when the code is not running. Let's talk about what is AWS Lambda. Now, Lambda is one of the services that falls under the compute section or the compute domain of services that AWS provides. Along with EC2, EBS, Elastic Load Balancer, Lambda is also a service that comes under the bigger umbrella of compute services in AWS. And Lambda allows us to execute code for any type of application. With AWS Lambda, we can run code for virtually any type of application or backend services.
all we need to do is supply our code in one of the languages that AWS Lambda supports. As we speak, the languages that are supported by AWS Lambda are Node.js, Java, C#, Go, and Python. And Lambda can be used to run code in response to certain events from other services. And based on the event, it can run functions, and those functions can be of Node.js, Java, C#, etc. Now let's talk about where is Lambda used. There are a huge number of use cases for Lambda, and there are many ways AWS Lambda is used specifically in the business world. Let's talk about some of them. One use case is AWS Lambda is used to process images when it is uploaded in an S3 bucket. Let's say the object gets uploaded in an S3 bucket in a format that we don't expect it to be, which means the file needs to be formatted. So it gets uploaded in a raw format, and AWS Lambda is triggered anytime a new object is added to the bucket, and the images are processed and converted into thumbnails based on the devices. The other end device that would be reading the data, it could be an PC, it could be an Apple machine, it could be an Android phone, it could be an Apple phone, it could be a tablet, whatnot. So based on the devices, different formats, Lambda can get triggered and convert the video or convert the picture into the different format that it requires. Another use case for Lambda is to analyze the social media data. Let's say we're collecting the hashtag trending data, and the data is received and it's added into the Kinesis stream to feed into the Amazon environment, and Lambda action get triggered and it receives the data, and then the data is stored into the database, which can be used by businesses for later analysis. And some of the companies that have gotten tremendous benefit using Lambda are Thomson Reuters, Benchlinks, Nordstorm, Coca-Cola, Robot are some of the companies to name at the moment that have received tremendous amount of benefit by using Lambda. Let's look at how Lambda works. In other words, let's look at how the complicated function behind the scenes work in a simple and in a seamless way. So here clients send data. Now clients send data to Lambda, and clients could be anyone who's sending request to AWS Lambda. It could be an application or other Amazon web services that's sending data to the Lambda. And Lambda receives the request, and depending on the size of the data or depending on the amount or volume of the data, it runs on the defined number of containers. If it is a single request or if it is less request, it runs on a single container. So the requests are given to the container to handle, and the container which contains the code the user has provided to satisfy the query would run. And if you're sort of new to containers, then let me pause here for a while and explain to you what container is. Now, container image is a lightweight, standalone, executable package of a piece of software that includes everything needs to run it, like the codes, the runtimes, the system tools, the system libraries, and any other settings needed. And it is at the moment available both on Linux and Windows based application, and containerized software will always run the same regardless of the environment it's running on. And containers isolate software from its surrounding. For example, there could be difference between a development and staging environment, so that's sort of isolated, and this helps in reducing the conflict between the teams running different software on the same infrastructure. Alright, now that we know containers needed to understand Lambda, so if there are few requests, it sends to a single container, but as and when the request grows, it actually creates multiple containers, shares the multiple requests to the different containers there. And depending on the volume, depending on the size, depending on the number of sessions, the more number of containers are provisioned so to handle those requests. And when the requests reduce, the number of containers reduce as well, and that helps in saving costs. We're not running any resources and paying for it when we're not using them. And in fact, we're not at all paying for the resources. We're only charged for the amount of time a function is running inside these containers. Now consider a situation where you have to set up a temporary storage and as a system to back up the data as soon as the data is uploaded, which is a near real-time backup. Now, a near real-time manual backups are nearly impossible, and they're not that efficient too. a near real-time manual backups. That's what the business demands, but that's not near real-time backup, that too a manual one. That's not at all efficient. Even if we come up with a solution of manually backing up close to near real time, that's not going to be efficient, looking at the amount of data that will be put in and looking at the random times the data will be put into the source bucket. And there is no way we can do a manual backup and keep it as real as possible. But if that's still your requirement, we can use AWS Lambda and set things up so AWS Lambda manually handles the backup. In other words, for an impossible or a difficult situation like that, AWS Lambda comes for the rescue. And this is what we do. Create a two S3 bucket. One would be the source bucket where the data will be uploaded, and the other one is a destination bucket where the data will be backed up from the source bucket. And for these buckets to talk to themselves, it's going to require an IAM role. And then for the automatic copy, it's going to require an Lambda function to copy the files from the source bucket to the destination bucket. And what triggers the Lambda function? The Lambda function is triggered every time there's a change in the metadata for the bucket, and this data is then uploaded into the destination bucket. And after setting all this up, we can literally test it by putting a data in the source bucket that's going to automatically replicate, or that's going to automatically copy the data from the source bucket to the destination bucket. All right, let's see how we can replicate data between two buckets. Well, we have a feature to cross-region replicate in S3. That's a feature that comes along with S3. What if you want to replicate between two different buckets in two different accounts? In those cases, we can use Lambda to replicate the data between the buckets. So you put one data, or you put data in the source bucket, and that data gets replicated to the destination bucket. And let's see how that's done. The procedure here would be to have two buckets to begin with, and then create an IAM role that lets you access to pull data from the source bucket and put data on the destination bucket, and then create Lambda files or Lambda event or triggers to actually look for event in the source bucket, and anytime a new data gets added, Lambda gets triggered, copies the data from the source bucket and moves the data to the destination bucket, and it uses the IAM role and policy for the needed permissions. And in just a couple of clicks, we have set up a temporary backup system that can run seamlessly without any manual intervention, and that can be as near real time as possible. Alright, that's the concept, and let's see how it is done real time through this lab. So to begin with, we need two buckets. So I have here a source bucket and a destination bucket, and the source bucket as of now do not have any data in it, so as the destination bucket. Alright, so that's one down. The second would be to create an IAM role. Alright, so let me create an IAM role, and the role is going to have this policy in it. A policy that's allowing get object on the source bucket, and a policy that's allowing put object on the destination bucket. And here I'm going to use, or I'm going to paste my source and destination buckets ARN. All right, go to services, go to S3, source bucket. All right, click on the source bucket and copy the bucket ARN. So that would be the source bucket ARN. All right, on the destination bucket, copy the destination bucket ARN, and this is going to be my destination bucket ARN. So with this, I'm going to create a policy. All right, go to IAM and create a policy. Now I have already created a policy with the same information. All right, destination bucket ARN, and a policy is available with the name S3 bucket copy Lambda. Attach the policy to the role. Right, go to roles, create a role. Lambda is the service that's going to use it. In here, attach the policy that we have created. Right, give it a name, and then create a role. Now I have a role created as well. Right, copy Lambda, and that's having the policy that we have created sometime back. Now create a Lambda function. Right, so go to Lambda, create a function give it a name like S3 bucket copy. All right, choose the role that we want to use. All right, that's the role that we want to use. Copy 1, 2, create a function. All right, and in here we're going to use Node.js code. Right, I have a sample code. This can be used as template. In here, replace the source bucket with the name of the source bucket and the destination bucket with the name of the destination bucket. This is a Node.js code that gets run when an event gets triggered. Now, what's an event? Anytime there is a new object placed in the S3 bucket, it creates an event, and the event triggers Lambda, and Lambda checks the source S3 bucket, picks the data, puts it in the destination bucket. All right, paste it here. Paste it here and click on save. All right, now before you click on save, just ensure that you have the appropriate roles defined. That's all you got to do. Click on save. All right, now I already have created a Lambda function, all right, which is the same thing, same code, and the role is attached to it. Now it's running, it's active. Now let's put this to test. Go to S3, pick the source bucket, put some data in it, all right, and in theory those data should be present in the destination bucket as well. There you go. It's all done by Lambda. I'm going to be touring you with different S3 features and technical details in this section. So what are we going to learn? We're going to learn about what is cloud storage in general, and then the types of storage available in general in the cloud, and how things were before anybody adopted using S3. That's something we're going to learn. And then we're going to immediately dive into what is S3, and then the benefits of using S3 over other storage. And then we're going to do a couple of labs or console walkthroughs about what is object and how to add an object, what is bucket, how to create a bucket, stuff like that. And then we're going to talk about how Amazon S3 generally works. Now, it comes with a lot of features, it comes with a lot of promise. How does this all work? How does Amazon able to keep up with the promise? We're going to talk about that. And then we will talk about some features, add-on features that comes along with Amazon S3. So what is cloud storage in general? Cloud storage is a service that provides web services where we can store our data. And not only that, the data can be easily accessed and the data can be easily backed up, everything over the internet. In short, if you could store your data, if you could access the data, if you could back up your data, everything you do through the internet, then that's a good definition for cloud storage. And additional definitions are, in cloud storage we only pay for what we use. No commitment, no pre-provisioning, is pay as you go type subscription. And the best part is we pay on a monthly basis. We don't rent a hardware for the year, or we don't give commitment for the whole year. It's pay as you go and pay on a monthly basis. And these cloud storages are very reliable, meaning once you put the data in it, it's never going to get lost. And these cloud storages are scalable. Assuming I have a requirement to store 100 times of what my actual data size is, and I want it now, it's available in the cloud. And these storages are secure as well, because we're talking about data virginity. They need to be secure, and Amazon provides tools and technologies through which we can secure our data, and these are generally not found in the on-premises storage system. So let's talk about the different types of storage in general. So S3 is cloud storage in AWS, and then we have Elastic Block Store. Now, Elastic Block Store is actually the SSD hard drives that gets attached to our EC2 instance. It's like the C drive, it's like the D drive, it's like the E drive that gets attached to our instances. Now EFS is Elastic File System. The underlying technology is kind of the same, but it differs from EBS in a way that EBS can be accessed only by the system that's attached to it, meaning the E volumes and the D volumes we spoke about. They can be accessed only if there is an instance connected to it. But these EFS are actually shared file systems, Elastic File System. Alright, they are shared systems. They can be accessed by multiple systems. They can be accessed from inside the Amazon environment. It can be accessed from on-premises equipment as well. Glacier is actually the archiving solution in the cloud. If you want to dump a data and try to keep them in the low cost as possible, then Glacier is the product we should be using. And then we have Storage Gateway. If I want to safely move my data from my local environment to the cloud environment and also want to keep a copy of the data locally so users locally can access them, and cloud users or internet users can access the data from the cloud, if that's your requirement, then Storage Gateway is the one we would be choosing. And then we have Snowball. Snowball is really an data import and export system, but it is actually an hardware that gets shipped to our premises where we can copy a data into it and then ship it back to Amazon, and Amazon would copy the data into whatever destination we give them in our account. And if the data is really huge, then I can call for a snowmobile, which is actually a data center on a truck, where Amazon would send me a truck loaded with a data center, as you see, that has compute capacity, lots and lots of storage capacity, and electricity, AC, and a lot more. So they get come parked near our data center, and cables run into our data center. We can copy data into it, send it back to Amazon, and they would copy it to our account in whatever storage that we advise them. So if the data is really huge, then I would be calling Snowmobile. Snowmobile is not available in all the regions. Alright, let's take this example, how things were before S3 was introduced. Two professionals are having a conversation, and one of them is finding it very difficult to sort of manage all the data in the organization. Well, if the data is small, it can be easily managed, but as company grow, and we are living in an era where data is everything. We want data to back up every idea. We want data to back up every proof of concept that we provide. So data is everything. So this era, it's all about collecting data, analyzing them, and saving, not losing logs, saving them, analyzing, stuff like that. So coming back to our discussion, here one person finds it very difficult to store and manage all the data that they have. So some of the data that this person is having problem storing is data that application use to running, and then data that get sent to the customers, and data that the websites require, the data that are because of the email backups, and a lot more other storages that an enterprise can have. And this person is having problem backing up all those data. And even if we think of increasing the local storage capacity, that's going to cost a fortune. And few things that make it sometimes impossible to increase the storage capacity in-house is we will have to go and pay heavy to buy hardware and software to run these storages, and we need to hire a team of experts for maintaining them, the hardware and the software. And anytime if there is a dynamic increase in the storage capacity, the on-premises or in-house hardwares won't be able to scale. And data security is very costly when it comes to building our own storage environment in-house and adding data security on top of it. So the other guy in the conversation was sort of quietly listening everything the manager was saying, and then he slowly introduced him to S3, because he knew that all the problem that this manager was worried about can be solved to S3. In other words, all the scalability, all the data security, all the not being able to provision hardware and software components are all available with S3. So that actually brings us to the discussion about what S3 is. S3 is Simple Storage Service. It actually provides an object storage service. Let me talk to you about object and block storage. Object storage is where you can store things and retrieve. All right, you can't install anything in it, and this object storage can be accessed directly from the internet, whereas block storage is something that needs to be attached to an instance, and we can't directly access it, but we can install software in it. So that's a high level difference between object storage and block storage. And S3 is an object storage. What does that mean? We can store data from the internet, we can retrieve from the internet, but we can't install anything in S3. All right, so S3 is an object-based storage, and it's really built for storing and recovering or retrieving any amount of data or information from anywhere in the internet. Few other things you need to know about S3 is that this S3 is accessible through the web interface. The storage, one type of accessing or one way of accessing S3 is by dragging, dropping content into it, and another way of retrieving data from S3 is go to a browser, click on download. That's going to let you download any content, and the data can be 5 terabytes in size. Now we're talking about one file. You can have hundreds or thousands of files like that. One file can be as big as 5 terabytes in size. And S3 is basically designed for developers where they can push logs into S3 or retrieve logs anytime they want instead of storing locally in the server. They can use S3 as code repositories, where they can save the code and have the applications read the code from there, and a lot more. If they want to safely share the code with another person with a lot of encryption and security added on top of it, that's possible as well. So there are a few things about S3, and on top of all this, S3 provides 11.9 durability and 4.9 availability. Meaning durability is, if I store the data, will it get lost? Amazon is like, no, it's not going to get lost. You're going to have the data because we provide 11.9 durability for the data. And availability is, if you want the data now, will you be able to show it? Amazon is like, yes, we will be able to show it. We have 99.99% availability, and when you request the data, we will be able to show the data to you. Alright, so let's talk about the benefits of S3. S3 is durable. As we saw, it provides 11.9 durability. S3 is low cost. Out of all the storage options in Amazon, S3 is the cheapest, and S3 is very scalable. Like we were saying, there's no required to pre-provision a storage capacity. If you need more, go ahead and use more. If you need even more, go ahead and use even more. And once you're done, some data needs to be removed, just remove the data. So that particular month you will be paying less. So it's very scalable in nature, and it's very available as well. S3 isn't regional service. It's not based on one availability zone. So one availability zone going down within Amazon, the whole availability going down, it's not going to affect your ability to access S3 storage. And S3 is secure. A lot of security features like bucket policy, a lot of security features like encryption, and then MFA authentication are possible with S3 that actually adds a very good security layer on top of the data that we have stored in S3. And not only that, this S3 is very flexible in terms of cost, flexible in terms of where I want to store the data. In terms of cost, there are a lot of pricing tiers within S3. S3 itself is a cheap service. Now within that, we have a lot of pricing tiers depending on the durability. So I can always choose to put data on a different storage tier or storage option in S3. We're going to talk about it as you stick along. And in terms of flexibility in region, I can always choose any of the region available in the console or in the S3 console to put my data to. There is no restrictions on where I can or cannot put the data in the cloud, as long as there are regions available for me to move the data to. And data transferring with S3 is very simple. All I have to do is browse to the bucket, upload the data, and the data gets uploaded. And we can also upload data using CLI. Commands are very similar to Linux. Commands are very similar to what we would use in the run command prompt in Windows, and what we would use in the run command prompt in the PowerShell. All right, let's talk about a basic building block of S3, which is bucket and objects. Now what's a bucket? What's an object? Object is the actual data, and bucket is the folder where the objects get stored. Let me give you a new definition for object. So object is the actual data plus some information that reference the data, like is it a JPEG file, the name of the file, and at what time it was added to. So they're called metadata. Alright, so object is actually data plus metadata, and bucket is actually a container that receives the data and safely stores in it. And when we add a data in a bucket, Amazon S3 creates an unique version ID and allocates it to the object so we can easily identify it at a later point. Let me show you a quick lab on S3. Alright, I'm in the S3 console. If you're wondering how I reached here, go to Services under Storage, and S3 is right here. And let's create a bucket called Simplilearn. Now the bucket names will have to be unique. So I really doubt if Simplilearn will be available. Let's check it anyway. All right, it doesn't seem to be available. So let me pick another name, or let's call it simplylearn.samuel.com, and I'm going to put this in Mumbai, or I can choose Oregon. Let me choose Oregon. Yes, let me choose Oregon. And let me create a bucket. Sure enough, a bucket got created. Let me upload an object into the bucket. And you know, these objects can be as big as 5 terabytes. We talked about it, right? All right, let me upload an object. All right, so that's my object. So you get the relation, right? Here's my bucket. Right, here's my bucket, and within that is my object. Now object is the actual file plus what type of file it is, and then the size of the file, the date in which it got added, and the storage class it is in at the moment. So if I have to access it, I can simply access it through the internet. So let's talk about how does this S3 bucket work anyway. Alright, so how does it work? A user creates a bucket. They will specify the region in which the bucket should be deployed. We had an option. We could have chosen to deploy in all the regions Amazon provides S3 service. You know, be it North Virginia, be it Mumbai, be it Tokyo, be it Sydney, be it Oregon. And we chose Oregon to be the destination region where we want to create a bucket and save our data there. And when we upload data into the bucket, we can specify 3 types of storage classes. In our case, we picked the default, which was S3 standard. As we saw on the object data, it was on S3 standard. So that's the basic thing. Later, once the object gets added, we can always add bucket policies. You know, policies define who access it and who should not access it. What can they access? Are we going to allow users only to read or to read write as well? stuff like that. So that's bucket policy. We're defining the life cycle or the lifespan of the data in the S3 bucket. Now over the time, do you want the data to automatically move to a different storage tier? And at any point, do you want to sort of expire the data, get the data flushed out of your account automatically? Those things can be configured in lifecycle policies. And version control is creating multiple versions. If you're going to use S3 for a code repository, creating multiple versions. Let's say if you want to roll back to whatever you had before a month, how are we going to do it if you kept updating the file and never took a version of it? So version control helps us to keep different versions, and it helps us to roll back to the older version anytime there is a need. So let's talk about the different storage classes in S3. The different storage classes in S3 begins with S3 standard. Now this is the default, and it's very suitable for use cases where you need less or low latency. For example, if you want to access the data of a student's attendance, you would retrieve them very quickly as much as possible. So that's a good use case to store data in S3. Let's understand the different storage classes in Amazon S3. Now let's take a school, for example, and the different data present in a school, and the features of those data, the validity of the data. Alright, so let's take this example, and there are different storage options in S3. Let's take S3 standard, for example, and what would be the actual candidate data that can be stored in S3 standard. Let's talk about that. So S3 standard in general is suitable for use cases where the latency should be very low, and in here the good example or the good candidate file that can be stored in S3 is data that needs to be frequently accessed and that needs to be retrieved quickly. Something like students' attendance report or students' attendance sheet, which we access daily, and then it needs to be retrieved immediately as and when we need it. The other type of storage tier in S3 is infrequent access or infrequent data access. Just like the name says, the use case for that is less frequently accessed data. I mean, the candidate data that should go in infrequent access data is a student's academic record, which we don't need to access on a daily basis. But if there is a requirement, we might want to go and look at it, and that's going to be quick. So it's not a data that we would access on a daily basis, but it's a data that needs to show up on your screen real quick. And the third option is Amazon Glacier. Now, Glacier is really an archival solution in the cloud. So for archives, high performance is not a requirement. So let's talk about some candidate data that can go into archives. Something like student's admission fee, and it's not critical also. Now, anytime if you want to look at the data, you can always wait to retrieve the data. So in other words, put it in the archive, and retrieving from the archival takes time. So students' old record are a good candidate to be put in the archives. The other options are one zone IA storage class, where the data is infrequently accessed and the data is stored in a single availability zone. For example, by default, Amazon stores data in multiple availability zones, and there is a charge for that. Now, it's not an option, but the charge includes storing data in multiple availability zones. But if your data requirement is you want to keep the charges low even further, you can choose a one zone IA storage class where it stores data in one availability zone. And the candidate data that can go in one zone infrequent access is student's report card. And the other option with Amazon S3 is standard reduced redundancy storage. It is suitable for cases where the data is not critical and the data can be reproduced quickly. For example, take a copy of the library book, take a copy of the PDF library book, for example. Now, we would have a source PDF and we would make copies of it, and then we make it available for the readers to read. The other option in S3 is reduced redundancy storage. Here the use case is data that's not critical and data can be reproduced quickly. For example, books in the library are not that critical and we always have a copy of the book we're talking about PDF. So if the customer facing or the student facing book gets deleted, I can always copy the same PDF, put it in the destination folder and make it available for the users to read. That would be a very good use case for reduced redundancy storage. All right, let's summarize everything that we learned about different storage options in S3. So S3 standard, it's for frequently accessed data. It's the default storage. If you don't mention anything, the data gets stored in S3 standard. It can be used for cloud applications, content distribution, gaming applications, big data analytic, dynamic websites. They are a very good use case for S3 standard frequently accessed data. The other one, on the contrary, is S3 standard infrequently accessed data. Just like the name says, the use case is this is good for data that will be less frequently accessed, and then the use case are it's good for backups, it's good for disaster recovery, and it's good for lifelong storage of data. Glacier, on the other hand, is very suitable for archiving data which is infrequently accessed, and the vault lock feature is the security feature of the Glacier that also provides a long-term data storage in the cloud. This is the lowest storage tier within S3. The other options are one zone infrequent access storage class. Just like the name says, it's infrequently accessed and it is stored in just one availability zone. And use cases are any data that doesn't require any high level of security can be stored here in one zone. The fifth storage tier is reduced redundancy storage. This is good for data that's frequently accessed. It's good for data that is non-critical and that can be reproduced if it gets lost. And reduced redundancy storage, or RRS, is an highly available solution designed for sharing or storing data that can be reproduced quickly. All right, let's compare and contrast a couple of other features that are available in S3. For example, durability, availability, SSL support, burst byte latency, and lifecycle management. So in standard, the durability is 11.9 durability. It's the same for standard IA, one zone IA, Glacier, except for reduced redundancy, the durability is 11.9. And availability of all the storage classes is all the same, except for one zone IA, where the availability zone is 99.5%. All of these products support SSL connection, and the first byte latency of these products are most of them provide access with millisecond latency, except for Glacier. It provides a retrieval time of couple of minutes to a maximum of hours, and all of them can be used for a lifecycle management, moving data from one storage tier to another storage tier. That's possible with all of these storage options. All right, now that we've understood the different types of storage options available in S3, let's talk about some of the features that are available in S3. Lifecycle management. Now, lifecycle management is a service that helps us to define a set of rules that can be applied to an object or to the bucket itself. Lifecycle is actually moving the data from one storage tier to another storage tier and finally expiring it and completing the life cycle of the object. With lifecycle management, we can manage and store our objects in a very cost-effective way. It has two features basically: transition actions and expiration actions. Let's talk about transition actions. With transition action, we can choose to move the objects or move the data from one storage class to another storage class. With lifecycle management, we can configure S3 to move our data from one storage class to another storage class at a defined time interval or at a defined schedule. Let's talk about transition actions in more detail. Let's say we have our data in S3 at the moment and we haven't used the data for quite some time, and that's how it's going to be for the rest of the time. So that data is a very good candidate to move to the infrequent access because S3 standard is a bit costlier and S3 infrequent access is a bit cheaper than S3 standard. So the kind of usage sort of fits very well for moving that data into infrequent access. So using lifecycle transition or lifecycle management, I can move the data to S3 infrequent access after 30 days. And let's say that the data stayed in infrequent access for 30 more days, and then now I realize that nobody is looking into the data. So I can find an appropriate storage tier for that particular data again, and I can move it to that particular storage tier, which is Glacier. So in this case, after 30 days or in a total of 60 days from the time the data got created, the data can be moved to Glacier. And what does this really help us with? The lifecycle management helps us to automatically migrate our data from one storage cost to another storage cost, and by that it really helps us to save the storage cost. Lifecycle management can also help us with object expiration, meaning deleting the object or flushing it out after a certain amount of time. Let's say that our compliance requirement requires that we keep the data for 7 years, and we have like thousands and thousands of data like that. It would be humanly impossible to check all those or keep track of all the dates and when they need to be deleted, stuff like that. But with lifecycle management, it is very much possible. I can simply create a data and set up lifecycle management for the data to expire after 7 years, and exactly after 7 years the data is going to expire, meaning it's going to be deleted automatically from the account. Alright, let me show you a lab on lifecycle management and let me explain to you how it's actually done. So I'm into the bucket that we have created, and here's our data into the bucket. Assume we have thousands and thousands of data in the bucket, and that requires to be put in a different storage tier over time, and that requires to be expired after 7 years, let's say. So the way I would create a lifecycle management is go to management from inside the bucket and click on lifecycle, and then add a lifecycle rule. Just give it a name like expire. So all the objects that's present in this bucket, meaning the current version of it, set a transition for it. So the transition is, at the moment they are in S3. So here I would like to put them in infrequent access after 30 days. And then after it's been in infrequent access for 30 days, I would like to move it to Glacier. Alright, plus 30 days. So how do you read it? So for the first 30 days, it's going to be in Glacier. So how do we actually read it? So after I put the data in S3, the data is going to get moved to standard IA, and then it's going to stay in standard IA, and after 60 days from the data creation, it's going to get moved to Glacier. So on the 31st day, it's going to move to standard IA. On the 61st day, it's going to move to Glacier. Let's say if I want to sort of delete the data, if I want the data to get deleted automatically after 7 years, being in a Glacier, how do I go about doing it? Let me open up a quick calculator. 365 into 7, that's 2,555 days. Right after that, the data is going to get deleted. Pretty much, I have created a life cycle. So on the 31st day, it's going to get moved to infrequent access, and on the 61st day, Glacier, and after 7 years is over, any data that I put in the bucket, it's going to get deleted. Alright, let's talk about bucket policies. Bucket policies are some permission files that we can attach to a bucket that allows or denies access to the bucket based on what's mentioned in the policy. So bucket policy is really an IAM policy where you can allow and deny permission to an S3 resource. With bucket policy, we can also define security rules that apply to more than one file in a bucket. Now, in this case, we can create an user, or let's say there's already a user called Simplilearn. We can allow or deny that user connection to the S3 bucket or connecting to the S3 bucket using bucket policy. And bucket policies are written in JSON script. And let's see how that's done. Alright, there are tools available for us to help us create bucket policies. What you're looking at is a tool available online that helps us to create a bucket policy. So let's use this tool to create a bucket policy. I'm going to create a deny statement. I'm going to deny all actions to the S3 bucket. and what is the ARN to which we want to attach. The ARN of the resource is actually the name of the bucket, but it really expects us to give that key in a different format. So the ARN is available right here, copy bucket ARN. So this is actually going to deny everybody. Now we wanted to deny a user, just one user. Now look at that. Now we have a policy that has been created that's denying access to the bucket, and it's denying a user called Simplilearn. Pretty much done. So I can use the policy and go over to bucket policies. So once I save it, only the user called Simplilearn won't have access to the bucket, and the rest of them will have access to it. So once I save it, it gets added, and only the user Simplilearn will not have access to the bucket because we're denying them purposefully. The other features of S3 include data protection. We can protect our data in S3 with now one of which is bucket policy. I can also use encryptions to protect my data. I can also use IAM policy to protect my data. So Amazon S3 provides a durable storage. Not only that, it also gives us a protected and scalable infrastructure needed for any of our object storage requirements. So here the data is protected by two means. One is data encryption and the other one is data versioning. Data encryption is encrypting the data so others won't get access, or even if they get access to the file, they won't be able to access the data without the encryption key. And versioning is making multiple copies of the data. So let's talk about them in detail. What's data encryption? Now, data encryption refers to protecting the data while it is being transmitted and protecting the data while it is at rest. Now, data encryption can happen in two ways. One is client encryption, encryption at rest, and server-side encryption, encryption that's in motion. Client-side encryption refers to when client sends the data, they encrypt the data and send it across to Amazon. And server-side encryption is when the data is being transferred, they get encrypted and stay encrypted throughout the transfer. Versioning is another security feature. It helps us so our unintentional edits are not actually corrupting the data. For example, let's say you edited the data and now you realize that the data is incorrect and you want to roll back. Now, how do you roll back? Without versioning, it's not possible. In other words, only with versioning, it's possible. So versioning, it can be utilized to preserve, recovery, and restore any early versions of every object that we stored in our Amazon S3 bucket. Unintentional erases or overwrites of the object can be easily regained if we have versioning enabled. And it's possible only if we have one file with the same key name, and anytime we update the file, it keeps the file name but creates a different version ID. Take this bucket and data for example. Photo.pmg is a file that was initially stored. It attached a version ID to it, and then we edited it. Let's say we added some watermark, we added some graphic to it, and that's now the new version of it. When we store it with the same file name. It accepts the same file name but creates a new version ID and attaches it. Anytime we want rollback, we can always go to the console, look at the old versions, pick the version ID, and roll back to the old version ID. Alright, let's take this example. Now, I'm in a bucket that we've been using for a while, and let me upload an object. Now, before we actually upload an object, this bucket needs to be versioning enabled. So let me version enable this bucket. From this point onwards, this bucket is going to accept versioning. So let me upload an object, photo.jpg. Let me upload it. All right, it successfully got uploaded. Good enough. It's uploaded. Now, let me upload another object with the same file name. Now look at that. It was uploaded at 7:35 a.m. Let me upload another object with the same file name that I have it stored right here. That got uploaded but with the same name. Alright, so that's the other photo. Now what if I want to switch back? The way I would switch back is simply switch back to the older version. Look at that. This is the latest version and this is the old version that I have. I can simply switch back to the old version that was created at such and such time, and I can open it. That's going to open the old file. So in short, it creates different version of the data that I create as long as it's with the same name, and at any point I can go and roll back to the original data. This is a very good use case if you want to use S3 for storing our codes. Let's talk about other feature like cross-region replication. Now, cross-region replication is a very cool feature if you want to automatically keep a copy of the data in a totally different region for data durability, for any additional data durability, or if you want to serve data to your customers who live in another country or who are accessing your data from another country. If you want to serve the data with low latency, cross-region replication is a very cool feature that you can use and get benefited from. And let's see how that's done. So before we actually do a lab on cross-region replication, let's put together a proper definition for it. Cross-region replication is a feature that provides automatic copying of every object uploaded to our bucket or your bucket, source bucket, and it automatically copies the data to the destination bucket, which is in a different AWS region. As you see here in the picture, I put data only in region 1. It's going to copy the data to region 2. And for us to use cross-region replication, versioning must be turned on. So it creates versions and copies the versions as well. If tomorrow the original region goes down, let's say the other region will be active and it has the complete data that was present in the original region. Or at any point, if we want to simply cut the region replication and use the other bucket as a standalone bucket, it can be used as well, because it already has all the data that was present in the master or all the data that was present in the original replication bucket. Let's see how that's done. So there are two things needed. One is versioning, and another one is role. When we transfer data from one bucket to another bucket, we need proper permissions to do so, and these roles, they give us proper permissions to transfer data from one bucket to another bucket. Let's see how that's done. Right, so here's my bucket, a bucket in US Oregon. Let's create another bucket in Mumbai. Call it .mumbai.com and put it in Mumbai, or create that bucket in Mumbai. There you go. We have one in Oregon, we have one in Mumbai. We're planning to replicate or create replication between these two, right? Create replication between these two buckets. So go to the first bucket, go to management and start a replication. Add a rule. So all content in this bucket is going to get replicated. This is my source bucket. It's quite simple. Select the destination bucket. Now my destination bucket is going to be simplilearn.samuel.mumbai.com. Alright, it says, well, you have versioning enabled in your source bucket, but not on your destination bucket. Do you want to enable it now? Without which we won't be able to proceed further. So let's go ahead and enable versioning through the console that shows up. And then, like I said, it's going to require permission to put data onto the other bucket. Now I can create different roles. These are different roles that are used for different other services. I can also choose to create a role that specifically gives permission only to move the data from one bucket to another bucket. Pretty much it's done. So if I go over to my source bucket and if I add some data to it, let's say index.html, assuming I'm adding some files to it, in theory they should move to the other region automatically. There you go. I'm in the Mumbai region and the datas, they got moved to the other region automatically. Let's talk about the other feature called transfer acceleration. Now it's a very handy and a helpful tool or a service to use if we are transferring data which is very long distance from us, meaning from the client to the S3 bucket. Let's say from my local machine, which is in India, if I transfer the data over to Oregon, let's say, it's a long distance. If it is going to go through the internet, it's going to go through high latency connections, and my transfer might get delayed. If it is an 1 gigabit file, it's okay. But if we're talking about anything that's 5 terabyte size. If you're talking about anything that's of 5 terabyte in size, then it's not going to be a pleasant experience. So in those cases, I can use Transfer Accelerator, which in a secure way, but in a fast way, or a fastest way, transfers my data from the laptop or from client to the S3 bucket. And it makes use of a service called CloudFront to transfer or to enable the data acceleration. So the way it would do it is, instead of copying the data directly to the location, instead of copying the data directly to the destination bucket, it copies the data locally into a CloudFront location, which is available very local to whatever place we are in, and from there it copies the data directly to an S3 bucket, not going through the internet. It helps eliminate a lot of latency that could get added when transferring the data. So let's see how that's done. Right here, I'm in the S3 bucket, and under properties I can find Transfer Accelerator, and if I enable Transfer Accelerator, so I'm in another bucket. Let me go to properties and let me go to Transfer Accelerator and enable Transfer Accelerator. So now if I put data into this bucket, they're going to get copied to the local CloudFront location, and from there they're going to get copied to the S3 bucket from the CloudFront. Now if I need to compare how the speed is going to be compared to directly putting the data to the internet and using CloudFront, there is a tool available that actually runs for a while and then comes with a report that tells me how much will be the improved speed if I use Transfer Accelerator, and it shows for all the regions available in Amazon. So from the source to the destination, if you want to put what's the normal and what's the accelerated speed when you transfer the data, those results we will get in the screen. So at the moment this tool is going through its testing, like uploading some file through the internet and uploading some file using CloudFront, and it has come up with the calculation that if I'm uploading file to San Francisco compared to uploading through the internet and through CloudFront, it's 13 times faster. So similar way, it's going to calculate for all the regions available and it's going to give me a result. Let me help you understand series called IAM as service in AWS for security. Here in this section, we're going to talk about what is security in AWS, and then we're going to slowly or gradually move on to the other topics like types of security available in AWS. Out of all the services, why IAM is the most preferred one, and then we're going to talk about what is IAM in general, how it works, the building blocks or components in IAM, and the features, the attractive features that it provides that makes IAM stand out from the rest of the services available. We're going to talk about that, and then we're going to end today's session with a demo about how IAM gets well interacted with other services in Amazon and help create a secure environment in the cloud. Let's talk about AWS security. Now, cloud security is the highest priority in AWS. And when we host our environment in the cloud, we can be rest assured that we are hosting our environment in a data center or in a network architecture that's really built to meet the requirement of the most security sensitive organization. And this high level of security is available to us on a pay-as-you-go type, meaning there is really no upfront cost that we need to pay. And the cost for using the service is a lot cheaper than what it is in an on-premises environment. So AWS Cloud provides a secure virtual platform where we can deploy our application. Now, compared to the on-premises, with AWS, the security level is very high and the cost involved in using or attaching that type of security to our application is very low compared to on-premises. There's really no upfront cost, and the cost is very lower. Whatever cost that we pay is very lower than what it would be in on-premises, and all this contributes to the secure environment we can get through IAM in AWS Cloud. There are really many types of security services available in AWS. To name a few, or to name the familiar ones, IAM stands first, followed by Key Management System, KMS, and then we have Cognito, that's another service, and Web Access Firewall, WAF, is another security service in AWS. Now let's start our discussion by talking about IAM, and that's what this whole series is about. Now IAM, or Identity and Access Management, it really enables us to manage access to AWS services and AWS resources in a very secure manner. With IAM, we can create groups. We can actually allow those users or groups to access some service, or we can sort of deny them to access the service, whichever we want. That's all possible through Identity and Access Management. And this feature comes with no additional charge. Now let's talk about how things were before AWS. Before AWS, or before IAM in general, it was not that safe in a corporate to share the password over the phone or through the email. That was the practice that was existed at that time. Now we all can remember the days when we need to switch to a different account, or we had just one admin password commonly stored in a location, or one person would reset it and maintain it, and anytime we need to log in, we call the person, ask for the admin password over the phone, and then we try logging in. Now that was not secure at all back then. Somebody could walk by and sort of eavesdrop, get the password. Now they walk away with the password with them. So they're all possible when we share the password over the phone and through the internet or email. Now with AWS, a lot of options are available that I'm not sharing password over the unsecure medium. Now Slack is a third-party product available with AWS. It's not an AWS product, but Slack is a third-party application that's hosted on AWS, and it's really a communication tool that helps people to share documents. So now we're not sharing the password over the phone, rather through the applications, and no eavesdrop person can really catch the password and try it in their system to access our environment. That's not possible. So you see the difference now. Back then, sharing password was only through phone and email, and you would write it on a paper and you give it to somebody. But now technology is providing provisions enough for us to share the password in a secure way. We're still talking about IAM. IAM is an web service for securely controlling access to the AWS resource. Now it really helps us to authenticate or sort of limit access to a certain set of users accessing the AWS account, or certain set of users accessing a certain set of resources in AWS account. Now you see this picture, we have an IAM administrator who's trying to allocate permissions to different group of people. So we have group 1 on the top and group 2 in the middle and group 3 towards the end. The administrator using IAM, or IAM empowers the administrator, allow access to certain group to certain resources. That's what IAM is all about. Now let's talk about the building blocks, or let's talk about the elements that make and complete IAM. So the elements are categorized into 6 different elements. We have the principal in IAM, the authentication, the request, the actual request coming in, the authorization, allowing, denying access, actions, what are the scope of actions can be taken, and on what resource. Is it EC2? Is it RDS? Is it S3 bucket? So what resource these actions are applied to. So they are the basic elements of an IAM workflow. Let's talk about principal, for example. An action on AWS resource can only be performed by a principal. An individual user, they can be a principal. A role in AWS IAM, it can be a principal as well. In other words, a principal is an entity that can take an action on an AWS resource. A principal can be an user, a principal can be a role, a principal can be an application that's trying to access the AWS environment. Secondly, authentication. Now, authentication is a process of confirming the identity of the principal trying to access the AWS environment. Now, how do we get authenticated, or how does a user get authenticated? By providing credentials or the required keys to validate that this is what he or she is as per what's in the record. So all principal must be authenticated, and we get authenticated using the username and password to log into the console. If it is CLI, or we get authenticated using the access key and the secret access key. The other component that makes up IAM is request. When a principal tries to use the AWS Management Console, what the principal is doing or what the user is doing is sending a request to the AWS environment, and the request will have the principal actually wants to perform. Is it an put request, or is it a get request, or is it a delete request, stuff like that. And it's also going to carry information about on which resource the action needs to be done. Is it on EC2 1? Is it on S3 bucket Simplilearn.com? Stuff like that. So it has a specific action that it wants to perform and the resource on which it wants to perform, and also some information about from where the request is originating from. Is it within an AWS environment, or is it with another cloud service provider, or is it with on-premises, stuff like that. So these information will be present in the request. Authorization. Now this IAM uses information from the request context to check for matching policies, and it takes a decision whether to allow or to deny the request. Now here it has a logic. By default, all the resources are denied, and IAM authorizes your request only if every part of the request is allowed by a matching policy. So there is an evaluation logic that says by default all requests are denied, and if there is an explicit allow, then it overrides the default deny. And if we are explicitly denying a service, then all the allow statements gets overridden, and all the other statements gets overwritten, and this explicit deny stands. By default, only the AWS account root user has access to all the resources in that account. So if you're not signed in as a root user, then we must be specifically granted permission through a policy. In other words, we need to be authorized through the policy. Now let's talk about action. Now after authenticating and authorizing the request, AWS approves the action that we are about to take. Now using action, we can view the content, we can create a content or create a bucket or create an EC2 instance. I can edit content, or even I can delete a resource. That's all based on the action that I'm allowed to do. Now that was about actions. Now where is the action performed? The action is performed on the resources. A set of actions can be performed on a resource, and anything that's not mentioned in the action or anything that's not tagged with the action and the resource, they don't get to complete. For example, let's say if you attempt to delete an IAM role and you also request to access the EC2 instance for that role, then the request gets denied. Now let's talk about some of the other components of IAM. So the other components of IAM are the basic building block is an user, and then many users together, they form a group, and then policies are the engines that allows or denies a connection. Based on policy, one gets to access or gets no access to a resource. And then roles are another component. Roles are temporary credentials, I would say, that can get assumed to an instance as and when needed. Right, let's talk about this component called user in an IAM. With IAM, we can securely manage access to AWS services, and we can create an IAM user anytime there is a new employee joining our corporate. So it's a one-to-one mapping. One user or one employee gets a username directly attached to them. And a username or a user is an account-specific thing. It's very local to that AWS account that we are using. So in detail, an IAM user is an entity that we create in an AWS environment to represent a person or a service that interacts with AWS environment. And this user is going to have some credentials attached to them. And by default, they do not have a password, and they do not have any access key or secret access key attached to them. In fact, literally no credentials of any kind. Now we must create a user, and we must create the type of credential that gets attached to the user. Do they want to access CLI? So based on that, we would be adding credentials to them. A user by default is not authorized to perform any action in AWS. And the advantage of having one-to-one user is that we can assign permissions individually to that user. For example, we might want to assign administrative permissions to few users who can administer our AWS environment, and users are entity within an AWS account. Users don't have to pay separately. They start using the servers, and that get bills under the account they are attached to. So separate users doesn't mean that separate payment for those users. They are just users in our account, and the whole account gets to pay for the resources that they provision. Again, the IAM user does not always represent a person. An IAM user is really just an identity with associated credential and permissions attached to it. It could be an actual person who is a user, and it could be an application also who is a user. Next, we'll talk about groups. Talking about groups or understanding group is very easy. A collection of user forms an IAM group, and we can use IAM group to specify permission for multiple users, so that any permission that's applied to the group is also applied to the users who are added to that group. Now, there are a few things you might want to know about group. A group can have many users, and a user, they can belong to many groups, but groups can't be nested, meaning group can only have users. A group cannot have a group inside a group. That's not possible. And there's nothing called a default group that sort of automatically includes all users in the AWS account. If you want to have a group, then we will have to create a group. Now let's take this diagram for example. Now this is a diagram of a small company. Now the company owner creates an admin group for users to create and manage other users as the company expands every day. And the admin group creates a developer group and a test group. Each of these groups consists of users who are people, users who are applications that interact with AWS environment. So the different types of users we have are Jim is a user, Brad is a user, and Dev App 1 is a user, and so on. So each users have an individual set of security credential. Like I said, it's 1-to-1, and the 10 users that we see on screen are shared between, or they belong to multiple groups in the account. And managing group is quite easy. We set permission to the group, and that permission gets applied to all the users automatically in the group. And after we applied the policy, if I add another user to the group, the new user will automatically inherit all the policies, all the permissions that's already mentioned in that group. So administrative burden is sort of taken away. Administrative burden about user privilege or user permission management is sort of taken out with IAM. Alright, the next thing we would want to discuss is policy. A policy sets permission and controls the access to AWS resource. And the policies, these permissions and controls, are stored in JSON format. A policy is a very clear document. It defines who has access to a resource and what are all the actions they can perform. So in other words, policy is an entity in AWS that when a policy gets attached to an identity or a resource, it really defines the permission, what they can and cannot do. And AWS, it evaluates these policies when a principal, such as a user, makes an request. And the permission statement in the policy, it really defines whether the user is allowed to access a service or is he denied to access a service. Alright, let's take this example. Now we have a task. The task is to give Paul, who is a developer, access to Amazon S3 environment. And what you're looking at is a snippet of what a policy would look like. So these are some questions we will have to answer, or these are some questions the policy tries to answer. And once it found an answer, then it becomes a complete policy. So who wants access to the service? It's Paul who wants access to the service. And what action do Paul want? Now Paul wants to download, or Paul wants to upload objects in S3. In JSON language, it's otherwise called Paul wants to get information, Paul wants to put information. Otherwise, Paul wants to get object, Paul wants to put object in S3. And which resource does he want? Now in this case, every bucket, the star symbol represents all buckets in S3. So which resource? It's all bucket in S3. So we can start reading already from the data present here. So who wants access? Paul wants access. What action does he want? He wants to get, he wants to put. And what's the resource that he's trying to access, or you want to give him access? It's all the bucket in AWS. And when does he want? These are additional statement that goes in a policy. So since when does he want that access? He wants access till March 2nd, 2019. So all this who, all this action, all this resource, till the time all this gets allowed. So this is the statement that really defines. Now, does this all refer to an allow statement, or does this all refer to a deny statement? If we had deny here, it's the direct opposite of what we discussed, but we have allow. That means Paul is allowed to get and put access in an S3 bucket, and all the buckets in S3 till March 2nd, 2019, he's allowed to access the resources. So if we put all the information that we have gathered, or all the answers that we have so far, if we put together in a JSON format, this is how it's going to look like. So the effect is allow or deny. Here it's allowing, and the principal is any. Now who can access it? It's any. And action, it's any bucket in S3. Any action in S3, put get request, and the resource is any bucket in S3. So that's how a basic policy would look like, or that's how a basic policy is formed, by answering those basic questions. So let's talk about the types of policies. So we have two broad categories, managed policy and inline policy. The managed policy, it's the default policy that we attach to multiple entries, be it users, be it groups, and be it roles in our AWS account. On the other hand, inline policy are the policies that we create and manage them, and these policies are embedded directly into a single user, group, or a role. So if I need to brief it a little bit more, then managed policies are standalone identity-based policies that we can attach to multiple users, groups, and roles in our AWS account. We can use two types of managed policies. In other words, managed policies, they themselves have two categories. One is AWS managed policies, which is created and managed by AWS. And the other one is customer managed policies. Just like the name says, it's managed by the customer. Now we can create and edit an IAM policy in Visual Editor, or simply create a JSON policy document directly and upload it in the console and start using them. So that's managed policy. On the other hand, inline policies are policies that we create and manage, and that are embedded directly into a single user, group, or role. Let's talk about this next component called role. Now this role is very similar to everything that we discussed so far. It's a set of permission that defines what actions are allowed and denied by an entity in an AWS console. The role is very similar to an user. I said very similar. I didn't say it's the same as the user, but I said it's very similar to the user. And the difference is that user is hard-coded. User permissions are hard-coded, but the role permissions are accessed by any entity, be it a user or be it an AWS service, and moreover, the role permissions are temporary. On the other hand, user permissions are permanent and the role permissions are temporary. So in detail, a role is very similar to a user in that it's an AWS entity with permission policies that determines what the identity can and cannot do in AWS. Now, instead of it being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Roles generally do not have a long-term credential, password or access keys associated with it. It does not have long-term credentials. It only has temporary credentials created dynamically and provided to the user as and when the user assumes a role and wants to access any service. Roles can be assumed by users, roles can be assumed by applications, roles can be assumed by services that normally don't have access to AWS resources. For example, you might want to grant a user in your AWS account access to your resource that they do not normally have, or grant users in one AWS account access to resource in another AWS account. Now this is something that we don't have by default, and this is something we may not need all the time. Or you might want to allow a mobile app to use AWS resource, but you do not want to save the key or save the credential or save the passwords in the mobile app. Or sometimes you might want to give access to resources who already have identities defined outside of AWS, like a user who's already an Google or Facebook authenticator. If you want to give them some service, or if you want to let them to access some of the resources in your account, we can use roles for that purpose. Or you also might want to grant access to your account to a third party, a consultant or an auditor, so they can for some time get some temporary access to audit our AWS resources. Remember, they're not permanent users, just temporary users. They want some temporary access to our environment till the audit is over. So for those cases, roles are a very good use case. So let's take this example. Let's see where role sits, and let's see how roles give permission to other services. So here is a scenario where an EC2 instance wants access to an S3 bucket. By default, though both of them were created by the same username or the same admin, they do not have access by default. So by default, they don't have access. And I also do not want to give permanent access, one-on-one hard-coded permanent access. Instead, I would like to create and share access. So that's possible through roles. So coming back to the discussion, the scenario here is that an EC2 instance wants to access data in an S3 bucket. So the first thing is to create a role or a permission. We saw how that's done, right? Using policies. Roles use policies. Policy is the actual working engine for any permission related actions, right? So create a role with an appropriate policy that gives access to S3's bucket, and then launch an EC2 instance with the role attached to it. We said roles are assumed by any entity, right? It could be a user, it could be an application, it could be a service, it could be another resource in AWS account. So here it's another resource in AWS account, right? So we create a role and we attach it to an EC2 instance. So now the EC2 instance can assume the role. Now the same role can be attached to another EC2 instance. The same role can be attached to another user. The same role can be attached to another database service. We get the idea, right? Roles can be assumed by anyone. So when the EC2 instance wants to communicate with S3, it contacts the role, and then the role gives this EC2 instance some temporary username and password that expires after 1 hour, let's say. So it's a temporary username and password. Now with that temporary username and password, the EC2 instance can access the S3 bucket and access the file with the credential that it already has. And that credential is a temporary one. And the credential will expire after 1 hour or how much ever time the admin sets it to be. And then the next time when an EC2 instance wants to contact S3, it will have to contact the role, and the role will propose a new access key and secret access key. In other words, a new credential. With that new credential, the second time the EC2 instance will be able to contact the S3 bucket and get the information. So the password is not a permanent or a one-time or a hard-coded password. It keeps rotating. It's a token. It's a secure token that an EC2 instance or any application that uses the role gets to access the resources on the other end. Well, let's talk about the features of IAM. The main feature of IAM is that I can create separate username and password for individual users or resources, and I can delegate access. Now, those days where we had just one username and password for admin and we need to call the other person to get the username and password over the phone, if it gets compromised, the whole account gets compromised, stuff like that, those issues are gone. I can create separate username and password for all 1000 users in my account. No more username and password sharing. I can manage access to all those 1000 accounts in a very simple and an easy way. So IAM provides shared access for all the 1000 users in my account. It provides shared access to the AWS environment, and the permissions that can be given through IAM are very granular. Now we saw how restrictions can be put on GET requests. We can allow a user to download information and not update an information. So that's possible through the IAM policies that we looked at some time back. And with the use of roles, we're authenticating an EC2 instance instead of the application running on top of it. So if there are like 10 or 20 applications running on top of an EC2 instance, instead of creating a separate username and password for all those 20 instances, I can create a role and assign that role to the EC2 instance, and all the applications running on the EC2 instance get a secure access to the other resources, use the role credential that's provided to that EC2 instance. Now, besides username and password, IAM also supports multi-factor authentication, where we provide our credential, the username and password, plus an OTP from our phone or an randomly generated number that gets displayed in our phone before Amazon console or before Amazon CLI would authenticate and lets us access some of the servers in the account. So it's called multi-factor authentication. It's username and password plus something else from what you have. IAM also provides identity federation. If a user is already authenticated with a corporate AD or Facebook or Google, IAM can be made to trust that authentication method and then allow access based on that authentication. Now, without federation, what would happen is the users will have to remember two passwords, one for on-premises and one for cloud. Anytime they work on on-premises, they'll have to use one set of password, and anytime they switch to the cloud, which is going to be very frequent in every day. So anytime they switch to the cloud, they will have to again type in the cloud username and password. Now, with identity federation, we can sort of federate, or we can connect both the authentication systems, both on-premises and IAM. So users can just use one username and password for both on-premises and cloud environments. And all that we saw so far, it's free to use. There is no additional charge for IAM security. There is no additional charge for creating additional users, groups, or policies. It's a free service, comes along with any account. IAM is an PCI DSS compliant product. IAM comes with password policy where we can reset the password remotely or rotate the passwords remotely. And we can set rules like how a user should pick and password. It should not be the one that was used in the past, any of the past 3 times, stuff like that. So you get the idea, right? How the features of IAM help us to build and secure authentication and authorization system in or for our AWS account. All right, it's time to do a quick lab. Let's put all the knowledge that we have earned so far together and apply it and try a lab and solve the problem. So here's a problem statement. We need to create an S3 bucket for a company where users can read or write the data only if they are multi-factor authenticated. So there could be like 20 users in an account, but a user is allowed to read or write a data in an S3 bucket only if the user is multi-factor authenticated. This is a very good use case if we have sensitive data in an S3 bucket and you only want privileged or MFA authenticated users to do changes to those buckets. And for those privileged users, you would enable multi-factor authentication. So let's see how that's done. Before that, let me talk to you a bit more about multi-factor authentication. Now, multi-factor authentication is that additional level of security process. It's provided by AWS. Here, the user's identity is confirmed only after the user proposes or the user passes 2 levels of verification. Now, one being the username and password and another being an OTP that gets generated. In this case, it's the mobile phone. It could also be an RSA token key that generates the one-time password. That's possible as well. But in this case, it's the mobile phone. Now, that's going to be very similar to how we log in to our Gmail account sometimes. When we log into a Gmail account and if you have the proper setting enabled, it's going to send an one-time password to the mobile phone, and only after we put that information, it's going to let us log in. Let's see how all this is done in an AWS account. So the first thing is to log in to the AWS account, create a user, and attach the user to the virtual MFA device. Now we're going to use Google Authenticator here, and we're going to attach the user to Google Authenticator and make the user use the Google Authenticator one-time password every time he logs in to the account. Now this is in addition to the username and password that he or she already has, right? So the first thing is to log into the account, connect or sync the virtual appliance with the AWS username and password. Now when we sync, there will be an one-time password that gets shown in the phone. Type in the password in the AWS console, and then the phone and the username comes to sync. And from that point onwards, the user, anytime they log in, they will have to propose their username and password, which is the first step of security. And then once they typed in the username and password, type in the MFA code that gets generated on the phone. That would be the second step of security, or the last step of security. Once that is done, the account is going to let them log in and access the AWS resources. Alright, so in order to test IAM, MFA, S3 together, this is what we're going to do. So we're going to create a bucket, and we're going to have 2 users, and we're going to allow or deny access to the S3 bucket to those 2 users based on whether they are MFA authenticated or not. And on purpose, we're going to assign MFA to one user and no MFA to the other user. Like you might have guessed by now, the user with MFA will have access to the bucket, and the user with no MFA attached will not have access to the bucket. Both of them are going to have full S3 services, but MFA, like I said, is one layer above the other permissions. MFA stands at all time. So irrespective of whether the underlying policy says but they have full access to the S3 bucket, they're not going to, because MFA stands on top of it. Let's see how that's done. To begin with, firstly, we need a bucket. So let's create a bucket. So I'm in my AWS console. So let me go to S3. And in here, create a bucket. Call that bucket as Simplilearn MFA bucket. And let me put it in North Virginia and create. Alright, so that's done. Now I'm going to put a separate folder in here. I'm going to create another folder in here, and the name of the folder is tax documents. Now this is where I'm planning to keep my tax files, and I only want my privileged users to be able to upload and download information from the tax document. So on the bucket side, it's partially done, or on the S3 side, it's partially done. So let's go back to IAM, and here we're going to create two users, one a junior employee and another one an senior employee. The senior employee is the one who's going to have MFA access and more access to the S3 bucket, and the junior employee is the one who's not going to have access to that particular bucket. So let's get started. Let's create an user under IAM. Click on users, and let's create a user. Call this user junior right. So he's a junior user, and for the password, set a password. The user does not need to create a new password at sign in, because it's a test environment, and the user who creates the username and the user are the same person. So let's keep it simple. Username, password, management console access, and this user is going to have full S3 bucket access. All right, this is really the policy. We should be familiar with this JSON document by now. It says effect is allowed, and what action? Any action in S3, and what resource? Anybody who's attached to it. Review and create a user. So this user is having S3 full access. Now let's create another user, call them as senior employee. All right, attach a policy to the user. You know, from the surface level, both of them have the same permissions. Both of them have S3 full access. All right, so both of them have S3 full access, as we see. There's one thing different we're going to do to this senior employee. Now we're going to attach MFA to this employee. So the way we would do it is under the summary section of that particular user, click on security credential, and see here is a place we can attach an MFA to this user. So let's attach MFA to this user. For MFA, I can use both virtual MFA or hardware MFA. This being a lab environment, we're going to use virtual MFA. Now, that is an application. There are a lot of applications available, but there is one application that I'm using at the moment called Google Authenticator. So once we have installed the application, and once it is running, so I can go to virtual MFA device, and once it is running, I can scan the code using the Google Authenticator in my mobile phone. Once you turn on the application, and once you do scan the barcode that is showing right here, now that's going to give us codes that we can use. and we will have to put in those codes here twice. We'll have to wait for some time and it would generate a second set of key that we can put. So my first set of key is 402351. Right, I'll have to wait for some time and then it would throw me a second set of key. It's like validating twice right here. So let me put in my second set of key. So this user is now MFA authenticated user. So anytime this user logs in, it's going to ask for MFA. Anytime this user proposes something, it's going to attach the MFA key along with it. Alright, so we're done with the IAM. What have we done with IAM? We have created two users. Both of them have S3 full access, but one of them have MFA access and the other one does not have MFA access. And based on whether the user is having MFA or not, we're identifying privileged users by this MFA. Alright, so based on whether the user has MFA or not, we're going to allow deny access in the S3 bucket. So we already have a bucket, we already have a folder, and this is a very privileged folder path. Here I would like to restrict access based on whether the user is having MFA or not. So let me create a bucket policy here. Now here's a policy that I have written. The policy says that, under tax document folder, give access only if the user is MFA authenticated, right? If the user is not MFA authenticated, simply deny the access to that user. So as you might guess right now, the user 1 will not have access, or the junior employee will not have access because it's a privileged, and junior employee might tend to delete them unknowingly, and only privileged users get access to the tax document because it's confidential, because it's privileged, because if it gets deleted we won't be able to get it back for those reasons, right? So apply the bucket policy. Now try logging in as the different users and see how the permissions are applied on both the users. All right, so let's make a note of the IAM URL. And then the two usernames and password. Let's log in. So let me log in as the privileged user. Sure enough, I'm being asked for an MFA code. Let me put my MFA code. So let's directly navigate to the S3 bucket. Right, here's my privileged path. Let me try uploading some content. Claim forms. Sure enough, I'm able to upload content into it. Will I be able to delete? Yes, I'm able to delete as well. Now let's see what's the situation for the other user. So let's log in as the other user. Navigate to the S3 bucket. If you noticed, when logging in, it did not ask for an MFA code because the user is not set up for MFA. So navigate to the folder which we want to test. Now try adding some files. As you see, it's failing to add content to this bucket. It shows error because the bucket policy is requiring MFA and this user is not MFA, and we did that in IAM or under IAM. But still, as you see, they will be able to view the content in the bucket. They can do all that. We have specifically restricted access to upload and download content from the bucket, and that's exactly this user is now denied with. In this section, we're going to learn about why we need a solution called CloudFormation, or why we need a product called CloudFormation. And we're going to talk in detail about what is CloudFormation, and then how CloudFormation works and the concepts involved in CloudFormation, like templates and stacks. There are some concepts involved in CloudFormation. We're going to talk about that. And how do we maintain access control over CloudFormation? We're going to talk about that as well in this video. And then we're going to go through a demo or a lab where we create an LAMP stack environment from a template through CloudFormation. And then we're going to talk about some use cases, one of which include being able to create an redeployable template using CloudFormation. That's a very good use case. We're going to talk about that in this video. So let's talk about why CloudFormation. So when the number of products and services grow more, and managing them and maintaining them becomes an tedious work, and CloudFormation, it sort of eases that environment. Now, CloudFormation is really an infrastructure as a code, and it sort of solves all the problem that we discussed some time back. And with CloudFormation, we can actually create a perfect clone of the server configuration at any point in time. And we can also manage the configuration changes With CloudFormation, we can manage the configuration changes across the environment. And not only that, we can easily embed in the ad hoc changes to our existing environment. So one might ask, why use CloudFormation? Let's look at the current problem that we have. Creating and managing multiple AWS resources in the portal is a big task, especially when you need to replace some services. It becomes a bigger task. Now, CloudFormation eases that work. Let me explain it in detail. Now, at the moment, without the CloudFormation, or environments that don't use CloudFormation have this problem. That is, a lot of time is being spent on building the infrastructure, and less focus and less time at the moment is being given on developing that application that runs on that environment. That's because majority of the time is consumed by building the environment. And if we need to redeploy the same environment again and again, the same happens in a cycle. Again, in a new environment, we start from the scratch, build the environment, and then put application on top of it. Now, that can be avoided using CloudFormation. Now, without CloudFormation, it still is a problem, because the resource or the bandwidth that is needed for the application development is not provided, because that's taken by developing the infrastructure. And to solve that problem, we can use CloudFormation. Now, that leads to a discussion about what is CloudFormation. So let's try understanding what CloudFormation is. CloudFormation is a service that provides users a simple way to create and manage collection of AWS resources by provisioning and updating them in a very orderly and in a predictable way. If I need to expand explanation of CloudFormation, CloudFormation is a service that really helps us to model and set up our Amazon Web Services or resources, so we can spend less time on managing the resources and show more focus on the application that runs on top of it. We can simply create a template for an EC2 instance or for an RDS instance and upload it in the CloudFormation portal, and CloudFormation will provision and configure those resources based on the template that we define. We really don't have to sort out the complexities in dependency between those applications. Once the template is vetted and validated, CloudFormation takes the responsibility of handling the dependencies between the application in an orderly and a predictable way. It creates those services and makes it available for us once the template is fully run. So in short, the CloudFormation, it allows us to create and model our infrastructure and applications without we having to perform the manual action. For example, the well-known company called Expedia is able to easily manage and run its entire front and back-end resources they run on AWS in CloudFront. What does that mean? They are spending less time on managing the infrastructure and more time on the core business and the application that runs on top of it. And we're still talking about what CloudFormation is. With CloudFormation, it enables us to manage our complete infrastructure or AWS resource in a text file. Now, we're going to see that in a moment. It's either a JSON or an YAML file, and that file is called as the template to begin with. The resources the template provision is called the stack. All right, so the abstract of the code is called the template, and the resource that it provisions is called the stack. And this stack can be, it's going to run resources, obviously, and those resources can be updated as well. It's not like once you create a stack, it's done. If you need a change, you need to go create another resource. That's not needed. This stack is an updatable stack. Let's say if I'm including 2 more servers, if I'm sort of extending my environment, it's branching out to another application. Now I'm including another functionality in my environment. All those can be embedded in the update and can be updated. So like I said, the stack is an updatable one. Now let's talk about what the template can do, or some features and functionality of the template. Now, using a template, we can almost include all the application and resources that a user might require. Let's say, after the EC2 instance is provisioned, running an application on top of it, and you want to templatize that and include that in the template, that's possible as well. And these templates are portable ones, meaning I can use the template in one region and I can use the same template in another region, and that's going to build a very similar environment in another region. I can also share that with the customer, and when they run it, it's going to run an environment from the portable template in their account, in their environment. Of course, all the security is taken care. I'm just saying that if we need to build a resource, if we need to build an architecture, if we need to build an environment which looks very similar to the other environment, that is possible. And these templates are usable by the use of some sections in the template, like the parameter section, the mapping section, the condition section within the template is what makes the templates reusable. And we will talk about parameters, mapping, and conditions down the line. We're still talking about AWS, how AWS CloudFormation works, and we're going to talk about how a template becomes an infrastructure. Right? So to begin with, one requires a template, and the template would be in JSON or YAML format. So one would develop a template based on the requirement, based on number of EC2 instances, based on whether they want a load balancer, based on whether they want a Windows server, based on whether they want an database server in that environment, and then based on the applications that will be running on top of it that can be templatized in the code itself. So one creates a code, and then the code is saved locally, or they can be put in an S3 bucket from which the CloudFormation will call the template and provision the resource. Right. So we use CloudFormation to create a stack or create the resource defined in the template. And CloudFormation analyzes the template first, validates the template, and then it identifies the dependencies between them, and then it starts provisioning the resource one after the other. For example, if you need 5 servers in a new VPC, obviously it's going to create the VPC first and servers second, and stack. All right, let's understand the 2 major components in CloudFormation. By now you might have guessed it. The 2 major components are the template and the stack. Together they aid or they complement CloudFormation, and that's how the resources are provisioned, that's how the resources are managed, and that eases the job of the administrator who's managing the environment. So let's talk about template first. A template in CloudFormation is an text file or a formatted text file in JSON or YAML language, and that the code or the template or the text file that actually describes how your infrastructure looks like or will look like once provisioned. And for us to create the template, or for us to modify an existing template, we can use a tool available called CloudFormation Designer from the console, or any text editing tool that's available. But I would recommend the CloudFormation Designer though, that has rich graphics in it. And these templates are built off, or they consist of 9 main objects. The first of which is the format version, and this really identifies the capabilities of the template based on the version number. And then the second object in a template would be description, and this helps us to include any arbitrary comments about the template. For what reason are we building this template? What's the purpose of it? Stuff like that. And then we have the object called metadata in a template, and that includes details about the template, details of the resources in the template. And then we have the optional parameters section. This really helps us to customize our template. Now, parameters enable us to input custom values to our template each time we create or update and stack. And the mapping object, it helps us to match a key to a corresponding set of named values. For example, if you want to set a value based on region, then we get to create a mapping that uses region name as the key and then the value that we want to specify for each specific regions. And then we have conditions object. This is again an optional object. With this, we can include statements that define when a resource is created or when a property is defined. For example, we can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create additional resources. And then the object called transform. It's an optional object as well, and this transform section specifies one or more transforms that we can use in our CloudFormation template. For example, AWS CloudFormation transforms helps simplify template authoring by condensing the expression of the AWS infrastructure as a code or the CloudFormation template, and it enables reuse of template components. For example, we can condense multiple line resources, declaring it into a single line in our template. Now we will talk about all these examples in the upcoming slides. And then we have the required section called resource that declares the AWS resource that you want to include in the stack. For example, if you want to include an EC2 instance, if you want to include an S3 bucket, we would be using the resource object in our stack. And then we have object called output. This output object, it's an optional object in the template, and it helps us to sort of declare the outputs that we can import into other stacks, or we can actually show it on the CloudFormation console. For example, if you want the output of the name of the S3 bucket that got created in response to a CloudFormation template, now we can have that outputted into an output section in the CloudFormation console itself. So it's sort of easy for us to identify the resources that the template provisioned. So with all of those objects put together, this is how a full-blown CloudFormation template with all the objects included is going to look like. Now this includes optional and mandatory objects. Let's talk about those objects in detail in the upcoming section. Alright, let's now discuss each and every object of this template structure. And let's begin our discussion with the format version. The format version, it really defines the capabilities of the template. The latest version, format version as of now, is the one that was updated on 2010. Now the value of the template format version, it has to be an string, and if we really don't specify the format version, CloudFormation automatically assumes the latest version. Talking about descriptions are really any comments that help ourselves that we want to embed in the template itself. That can be a description, and this description in a template, it has to be an string. The length of the string can be between 0 to 124 bytes in length. The metadata are really used in the template to provide any additional information using the JSON and YAML objects. And metadata holds some implementation details of a specific resource. And parameters are really a way to customize the template. Each time we create or update our stack, these parameters are the ones that helps us to give some custom value to the template during runtime. In the example shown below, the parameter named instance type parameter, it lets us to specify the EC2 instance type for the stacks to use when creating or updating the stack. By default, as we see, it's picking T2 micro, and this is the value that will get picked if we don't provision another value to it. And mapping really enables us to map a key to a corresponding named value that we specify in a conditional parameter. And also we can retrieve the map or retrieve the values in the map using the function findInMapInStrict function. Let's take this example. Let's say based on a region, if you want to set values in a template, we can create a mapping that uses a key and holds the value that you want to specify for each region. And the object conditions can be used when we want to reuse the templates by creating resources in a totally different context. For example, in a template, during stack creation, all the conditions that we mention in the template are evaluated, and any resources that are associated and that come up to be true are created, and any condition that fails or invalid are kind of ignored automatically, and the check moves forward to the next condition. And conditional is an optional object, and it includes statements that define when a resource is created or when a property is actually defined. For example, you can you can compare whether a value is equal to another value, and based on the result of that condition, we can conditionally create resources. If you have multiple conditions, then they are generally separated with commas. Sometimes conditions are very helpful when we want to create templates and we want to reuse those templates which was created for one environment to another environment. For example, if you want to use a template that was created in a test environment in a dev environment, conditions would be helpful. For example, in a production environment, we might want to include instances with certain capabilities, and in a test environment, we might want to include instances with some reduced capability in them for saving money. And condition helps us to create resources based on the environment it will be used in. We can also use intrinsic functions to define conditions like equals. We can also use OR conditions. We can use NOT functions, intrinsic functions in a condition. And when put together, the syntax is going to look like the one that you see on the screen. Now, the optional object called transform, it specifies one or more transforms that the CloudFormation uses to process our template. Now, these transform sections are built on a simple declarative language of AWS CloudFormation with a powerful macro system that helps us to reuse the templates or the template components. And they really help us to condense or simplify our codes by enabling reuse of the template components. For example, condense a multiple line resource declaration into a single line in our template. The resource section, it really declares the AWS resource that you want to include in the stack, such as EC2 instance, such as S3 bucket. And some of the resource fields are the logical ID, the resource type, and the properties. Let's talk about them in brief. The logical ID is unique within the template, and the logical ID name, it actually references the resource in other parts of the template. In this case, it's my bucket. For example, if we want to map an elastic block store volume, or if we want to map an name of the bucket in another place in the template, then we would use the logical ID. And again, in this case, it is my bucket. A logical name has the physical ID with which we actually assign the resource. For example, in this case, my S3 bucket was named as my bucket to begin with. And the resource type in the template, it identifies that the type of the resource is an S3 bucket. And the properties are the additional optional information that we can specify to our resource. For example, if it is an EC2 instance, let's say we would like to know which AMI it used, then property section really defines the AMI that was used, or AMI as the property of the instance. So this section describes the output value that needs to be imported to other stacks, or the output value that needs to be shown in the console for the user to easily navigate to the resource that are being created. For example, for a S3 bucket name, we can declare an output, and once the bucket is created, we can actually declare the output and import the name of the bucket in a different place in the console, so it's easy to view instead of the user getting confused and going to S3 and searching for the bucket name. This can be made available in the CloudFormation console itself. And the output fields, it can include some of these followings, like the logical ID. It's actually the identifier of the current output, and it's very unique within the template. And it can also include a description. Description is really a string type that describes the output value, and it can also include value, and value is the property that was returned by the AWS CloudFormation describe stacks command. All right, let's talk about the template resource attribute. In this section, we're going to talk about attributes that you can add to a resource to control additional behavior and relationships. So let's talk. There are many resource attributes available, out of which we have if we need to name them, we have a creation policy, and then we have deletion policy. It depends on metadata attribute, update policy attribute. Let's talk about each of them separately. When we associate the create policy attribute with the resource, it actually delays the resource configuration actions before proceeding with the stack creation. I mean, the attribute stack creation is delayed till the time the CloudFormation receives some number of success signals back. I mean, this is a very good use case when we do auto scaling. And this creation policy can be used only with a limited number of services like auto scaling and EC2 instances. Some of the use cases would be if you want to install a software application on an EC2 instance, you might want the applications to be running before it proceeds further. So in this case, we would use the creation policy attribute to the instance and then send the success signal after the applications are installed and configured. Then CloudFormation goes to the next step. Here in the syntax that we're looking at, the auto scaling creation policy and the minimum successful instance percentage, it's actually a number of signals that it will have to reply back before it can move forward. Using deletion policy, it preserves backing up of resources when the stack is getting deleted, and by default, if you don't have a delete policy, the data gets deleted just like that. But if we use an deletion policy, we would be able to preserve the data by taking a snapshot of it or just letting the resource and moving on with deleting the other resources in the stack. And we specify the delete policy attribute for each resource specifically that we want to control. And if there are no deletion policy mentioned for a particular resource, the CloudFormation simply deletes the resources as that's its default behavior. And if you want to keep the resource when the stack is deleted, we mention retain in the delete policy, and that simply retains the resource from getting deleted. So in this example, we're actually retaining an DynamoDB table. Rest of the resources in the stack will get deleted. And using the depends on attribute, we actually create an order in which the resource gets deleted. For example, if I map one resource to another resource and say that this resource depends on the other resource gets created first, then followed by this instance or this resource. So with the depends on attribute, we can specify that the creation of specific resource is actually followed by another. When we add the depends on attribute to a resource, the resource is created only after the creation of the resource specified by the depends on attribute. Let's take this example. In this example, we're saying that the resource X depends on Y. We've said that X depends on Y. So in this case, when CloudFormation is executing, it's going to deploy Y first because it has some resources that depends on it. So it's going to create Y first, and then it's going to create the resource called X. On the same context, let's say in the template, we say that an EC2 is going to depend on S3, and when the CloudFormation is executing, it's going to create an S3 bucket first, and then the EC2 instance. That's probably because the codes needed for the EC2 instance are stored in the S3 bucket. And what we're looking at is the syntax of how the depends on template resource attribute will look like. This is how it actually will look like when we put it in the CloudFormation. The instance depends on the bucket.
The other template resource attribute is metadata. Metadatas are the one that really helps us to associate our resources with the structured data. And by including this attribute in our template, or by including this attribute to a resource, we can specify the data in JSON or in YAML language. For example, in this section of the template, we're creating a VPC, and the metadata explains, or metadata defines, that the VPC is part of the region US East 1. And the update policy template resource attribute in CloudFormation, we can manage and replace the updates of the instance in an auto scaling group. For example, you're looking at this sample where it says that the update policy, will it replace the instance in an auto scaling group or not? So depending on what the value is for the will replace section, whether it's true or false, depending on that, the update policy will replace the instance or will replace the auto scaling group itself when it's doing a rolling deployment. Now that we've discussed about templates, let's talk about AWS stacks as well. Now we know that AWS stacks are the actual resources that gets generated or that gets created because we ran a template, right? So stack is a collection of AWS resource that we can manage in a single unit. In other words, we can create a stack, update a stack, or delete a stack, and that would actually create, update, delete the collection of resources within the stack. And all the resources in the stack are really defined by the CloudFormation template. And a stack, for instance, can include all the resources required to run a web application, such as a web server, a database server, and some networking rules that come along with it. All that gets embedded in a stack. And let's say if we want to delete all the resources that were created by template that is in a separate stack, we can simply delete the stack, and that would sort of delete all the resources that is in the stack. So it sort of helps us to manage all the resources in a single unit or as a single unit. So to summarize, stack is a collection of AWS resource, and it can be managed as a single unit. And the CloudFormation's template defines a stack in which the resource can be created, deleted, or updated in a very predictable way. And a stack can have all the resources like web server, database server, VPC, the network and the security configurations in a VPC, all that is required to run a web or a database application. Now, stack could be nested as well. With CloudFormation, we can actually nest a stack with another stack, and that's going to create a hierarchy of the stacks. For example, there's a very good picture that explains how the stacks are nested in a hierarchical way. Let's say stack P is the root stack, and that could be a parent stack for the stack called R and the stack called Q. And the same way, the stack called R is a parent stack for the stack S, and the stack S is the parent stack for T and Q. You get that, right? So stacks can always be nested. It's possible. CloudFormation allows us to create a Microsoft Windows stack based on Amazon EC2 Windows AMIs, and provide us with the ability to install software and use remote desktop to access our stack and update the configuration of our stack. And these stacks can be run on Windows Server instances. There are a number of pre-configured templates available, and it's directly available to use from the AWS website itself. To name a few, we have templates available for SharePoint running on an Windows Server 2008 R2. We also have templates that create a single server installation of Active Directory running on a Windows Server. And in fact, we have templates available for Elastic Beanstalk and some sample applications that runs from a Windows Server 2008 R2. Let's talk about stack sets. Stack sets actually has taken the stack level implementation to the next level. Using the AWS CloudFormation template, we can define a stack set that lets us to create stack in AWS account across the globe by using just a single template. And after we create the stack, or after the stack set is defined, creating, updating, or deleting the stack in the target account and the regions can also be specified by us. So the stack set, it really extends the functionality of the stacks by allowing us to create, update, and delete stack across multiple accounts, regions in just a single operation. And using an administrator account, we can define and manage an AWS CloudFormation template and use the template as the basis for provisioning stacks into some selected target accounts across a specified region. Let's talk about CloudFormation access control. With IAM, I can specify the list of users or list of privileged users who would have access to the CloudFormation template, who can create, update, and delete stacks. So that's how IAM helps me with having or putting a layer of control over the CloudFormation service. And we can also use service roles. Service roles are the one that allows AWS CloudFormation to make a call to a resource in a stack on the user's behalf. And I can also have stack policies, and these stack policies are applied to the users who already have access to the CloudFormation service. And these policies are the ones that help the users who attempt to update the stack. All right, let's do a quick lab on creating an LAMP stack on an EC2 instance with a local MySQL database for storage. Now, we can do the other way as well. I can pick an EC2 instance and install the servers one top of the other. That can be done as well, but that's going to take a lot of time. Now, we're talking about automating it. We're talking about, provisioning an infrastructure using a code, and CloudFormation helps us to do that. So this is what we're going to do. We're going to create, or we have a CloudFormation template already, and we're going to use that template to provision a web instance, and that is going to have Look at that. That's going to have MySQL installed in it. That's going to have PHP. That's going to have HTTPD service installed in it and running. And it's also going to have a PHP website running from it. So that's going to receive information from the website, and that's going to store that information in the database that's very local to it. This is the template that defines that environment. All right, this is a very simple provisioning. So let's provision this environment. Let's create a stack. We're going to give a stack name and a database password. Right, and which region is it? This is in California, is it? All right. Now let me do one thing. Let me switch to the Mumbai region, or let me switch to North Virginia region. North Virginia, and from here, actually, let me switch to Mumbai region. Right, just to be sure, it's the same template that we're provisioning. Right, that's the same template that we are provisioning. Right, let's give this name. So it can be great. This could be Simplilearn Lamb stack, and what could be the DB password and DB root password, and what could be the DB user. I'm going to keep the rest as defaults, and I'm going to launch. Alright, so there's an issue with the password. Password should only have alpha numeric characters. Get that. So let's go back and create a new password. Right, it also needs to have 8 characters. So what can be our password? Look at that. The template is actually creating the resources. And here in the screen, we can see the template that we used to deploy the environment. If you remember, we discussed about instant types in parameters, right? The default instance type is T2 small, but these are also allowed to run. Right, parameter section is the one that was used to receive information from us, like the DB name, the DB password, the DB root password, DB user instance type, key name, and the SSH locations. All right, now this resource section is showing us the resource that it actually created. Right, looks like it's rolling back. Why would that be? Give me a moment. All right, this is one live example. Anytime it could not provision, or if there is an interruption that it could not proceed, it would simply roll back and delete all the resources that it had provisioned, and that's what it did. Now let me fix this. Alright, as a fix, I have switched the region because I had some issue with the VPC. That's going to take time for me to analyze and fix it. So here we're going to understand about CloudFormation. So I thought I'll run the CloudFormation from another VPC that I know is working fine. That's in North Virginia. Alright, let's provision a LAMP server which is running out of Linux, which has Apache installed in it, which has PHP and MySQL already installed in it. So one server going to act as web and DB server. All right, so I'm going to create a stack, and from here I'm going to pick a sample stack. If we look at it in the designer, it's going to provision one LAMP server and a security group attached to it. There you go. Right, so let's go ahead and create a stack. Right, parameters are used to receive input from us. What could be the DB password and the DB user, and let's select the key name. Right, I'm going to keep the rest as defaults, and I'm going to create a stack. Alright, so our stack that we ran from the template, at the moment it's getting created, it's in progress. From here I can watch the events as to what is getting created at the moment. Like I said, a lot of these would have already sorted out their dependencies, which one needs to get created first, which one needs to get created second. All that is sorted out by CloudFormation itself. And parameters are the values that we have inputted, and resource tab is a section where we can find what resources are being provisioned at the moment. So to begin with, it created a security group. At the moment it's creating an instance, and output, it's empty as of now. We're going to come back and see it. Now output is where we can get outputs of a finished job. Let's say here I wanted an URL of the server that got created. So instead of me going to a couple of other places within the console and find the output of the URL or the output of the resource that was created, I can simply get it from here. Well, this needs to be defined in the templates first. Once we define it in the template, it's going to be made available like here. Right, so I can open it up, and so there you go. So it already has a database locally installed, and it's connected to it. If I launch an application on top of it, that will get connected to the database, which is very local, and my single server with web and database in it is ready for production. Now, while we're talking about a LAMP server, a single LAMP server, let's talk about creating an environment like this, which has Elastic Load Balancer, a VPC, a server running in an auto scaling group, and putting some restrictions that nobody will be able to access the EC2 instance directly, but they should be able to access the EC2 instance or the data only through the Elastic Load Balancer. This is a bit complicated than the environment that we've already created. Let's see how this is done. All right, in this lab, we're going to create Elastic Load Balanced Auto Scaling group, which is going to create a load balancer and an auto scaling group, and that auto scaling group receives traffic only from the load balancer. So here's the template, and here's the architecture that we're going to provision. Let me call it right, and the key pair it's going to use is Simplilearn key pair. Now this is where the problem was. Now we were selecting few subnets. So now if I provision it, now this is going to take its short time to provision the resources. So through parameters, we can see the values that we have inputted, and the events look good. No rollback, no deletes, and the resource section shows the resource that it is creating. So previously it created a target group, now it's creating the application load balancer itself. All right, so it created a load balancer, and then it created a security group. It created a launch configuration. At the moment it's creating a web server group. And the events look good with all green and yellow. Green ones are completed, yellow ones are in progress. We don't have any red delete or rollback errors, so it looks good. All right, it took a while, and the resources have been created. Some of them show that they are in progress, but the status of the stack is complete. All resources have been created, and we do have an output to access the URL. There you go. And remember, there was another feature of the CloudFormation that was it should restrict access, direct access to EC2 instance. Let's see if that has been done. If I try to access using the load balancer, it lets me access. But if I try to access it using the EC2 instance IP or the DNS name, my connection won't go through because it's blocked through the security group. But direct access through the load balancer is allowed, and that's what we wanted to achieve through that template.
Here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general. And then it uses a service called Docker, so we're going to understand what Docker is. And there are competitive services available for ECS. ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. Each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying, you can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users, the end user could be in the internet, the end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment here. Most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is.
So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from
Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through management console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right, so no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's an highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously, or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes. Right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there. Right. This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers, because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already. And it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running, and any additional software do we need? So those question gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR, and there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, elastic network interface card, separate elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance. And it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. It's a container agent. When we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remain and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is, first we need to have an AWS account, and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just one running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers, and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it a backup job? Is it a web application? Is it a data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure your cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, And let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create a cluster. This is our Fargate. And this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me, and it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it, and because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it, and I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location, so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now, right? So I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit, and the task CPU is 0.25 virtual CPU. Name of the service: is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer, and port 80 that receives information on port 80 HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done, and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository.
This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here, because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right now this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now, using IP is not all that advisable, because these containers can die and then a new container gets created, and when a new container gets created, it gets a new IP, right? So hard-coding IP is hard-coding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS, and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal. In this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53, and finally we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services, such as a variety of IT services or infrastructure services, such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot, meaning you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years. Right, and then you will gradually be, utilizing it from, 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server
that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say, the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without the users, without you interacting, without the user who bought it interact with it. You don't have to scale up. When you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access, or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource.
and this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. Right? In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing, that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency based routing. Just like the name says, we use latency based routing if we have resources in multiple AWS regions, and if we want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of odd resources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy, it will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you have launched, new version or new application that you have launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with a soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability. Otherwise customers will end up in a broken page, and
the number of customers who will be using the website will come down. So it's very critical. Now these sites, these companies are very critical, they're being highly available, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources so their resources are properly used with all the weighted routing. The resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, right? We'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12. So let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out, and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal, and I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me, right? Click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names, right? All that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting, right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly, right? It's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket. static website hosting enable S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straightforward.
Let me help you understand AWS Elastic Beanstalk. So what's in it for you? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer. And if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about a scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now, there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now, what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. If you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now generally there are 2 types of environment tier. One is the web and the other one is the worker node, and that's something which we'll be discussing later as well. Now let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons, that's it, nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now what happens in that case is when you launch an environment, in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto scaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC, you don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitored, provided capacity provisioning, load balancing, auto scaling, and hence monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are two types of environments that you have to select. You can select one is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you two different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the client should be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the clients. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now in the web server environment, let's say if we select a web server environment, and it says that if the application receives client request, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now obviously we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client facing environment. Now if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and it may you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now here in the diagram you can see that there are two web server environments and they are created in the auto scaling group. That means there is some kind of scaling options that are defined as well, and these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the auto scaling group. So that's something which we have discussed already. Now, this auto scaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now what does auto scaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the auto scaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the auto scaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the auto scaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group, auto scaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now, understanding the worker environment, what happens is that the client, the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS, which is a simple queue service. And the queue service sends it to the worker environment. And then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with the worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now what we have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a New Application. Put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed, that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now, the usability of a worker environment can be anything. Now, we'll do a demo for creating a web server environment. So just click on select, and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description, it's a demo app that we are creating, and then you have to define a platform as well. Now these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now, either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on configure more options. So let's click on configure more options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy our applications over it. If you wanted to modify, just click on a modify button, and here you can modify your instances with respect to the storage as well. Now, apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now, if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated, and that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the Elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it's a sample application. Health status is okay. Now the other thing is that if you do not want to use the web console, the management console, to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface, and then you have the command references, CLI command references, that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is okay. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it, and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups or HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's in the, so we have this bundle logs in the zip file. All right, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
In this lesson, you'll learn all about virtual private clouds and understand their concept. You'll know the difference between public, private, and elastic IP addresses. You'll learn about what a public and private subnet is. And you'll understand what an internet gateway is and how it's used. You'll learn what route tables are and when they are used. You'll understand what a NAT gateway is. We'll take a look at security groups and their importance. And we'll take a look at network ACLs and how they're used in Amazon VPC. We'll also review the Amazon VPC best practices and also the costs associated with running a VPC in the Amazon cloud. Welcome to the Amazon Virtual Private Cloud and Subnet section. In this section, we're going to have an overview of what Amazon VPC is and how you use it. And we're also going to have a demonstration of how to create your own custom virtual private cloud. We're going to look at IP addresses and the use of elastic IP addresses in AWS. And finally, we'll take a look at subnets, and there'll be a demonstration about how to create your own subnets in an Amazon VPC. And here are some of the terms that are used in VPCs. There's subnets, route tables, elastic IP addresses, internet gateways, NAT gateways, network ACLs, and security groups. And in the next sections, we're going to take a look at each of these and build our own custom VPC that we'll use throughout this course. Amazon defines a VPC as a virtual private cloud that enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using the scalable infrastructure of AWS. A VPC is your own virtual network in the Amazon cloud, which is used as the network layer for your EC2 resources. And this is a diagram of the default VPC. Now there's a lot going on here, so don't worry about that. What we're going to do is break down each of the individual items in this default VPC over the coming lesson. But what you need to know is that a VPC is a critical part of the exam, and you need to know all the concepts and how it differs from your own networks. Throughout this lesson, we're going to create our own VPC from scratch, which you'll need to replicate at the end of this so you can do well in the exam. Each VPC that you create is logically isolated from other virtual networks in the AWS cloud. It's fully customizable. You can select the IP address range, create subnets, configure route tables, set up network gateways, define security settings using security groups, and network access control lists. So each Amazon account comes with a default VPC that's pre-configured for you to start using straight away, so you can launch your EC2 instances without having to think about anything we mentioned in the opening section. A VPC can span multiple availability zones in a region. And here's a very basic diagram of a VPC. It isn't this simple in reality. And as we saw in the first section, here's the default Amazon VPC, which looks kind of complicated. But what we need to know at this stage is that the CIDR block for the default VPC is always a 16 subnet mask. So in this example, it's 172.31.0.0/16. What that means is this VPC will provide up to 65,536 private IP addresses. So in the coming sections, we'll take a look at all of these different items that you can see on this default VPC. But why wouldn't you just use the default VPC? Well, the default VPC is great for launching new instances when you're testing AWS. But creating a custom VPC allows you to make things more secure, and you can customize your virtual network as you can define your own IP address range. You can create your own subnets that are both private and public, and you can tighten down your security settings. By default, instances that you launch into a VPC can't communicate with your own network. So you can connect your VPCs to your existing data center using something called hardware VPN access, so that you can effectively extend your data center into the cloud and create a hybrid environment. Now to do this, you need a virtual private gateway, and this is the VPN concentrator on the Amazon side of the VPN connection. Then on your side, in your data center, you need a customer gateway, which is either a physical device or a software application that sits on your side of the VPN connection. So when you create a VPN connection, a VPN tunnel comes up when traffic is generated from your side of the connection. VPC peering is an important concept to understand. A peering connection can be made between your own VPCs or with a VPC in another AWS account, as long as it's in the same region. So what that means is, if you have instances in VPC A, they wouldn't be able to communicate with instances in VPC B or C unless you set up a peering connection. Peering is a one-to-one relationship. A VPC can have multiple peering connections to other VPCs, but, and this is important, transitive peering is not supported. In other words, VPC A can connect to B and C in this diagram, but C wouldn't be able to communicate with B unless they were directly peered. Also, VPCs with overlapping CIDRs cannot be peered. So in this diagram you can see they all have different IP ranges, which is fine, but if they had the same IP ranges, they wouldn't be able to be peered. And finally for this section, if you delete the default VPC, you have to contact AWS support to get it back again. So be careful with it and only delete it if you have good reason to do so and know what you're doing. This is a demonstration of how to create a custom VPC. So here we are, back at the Amazon Web Services Management Console. And this time we're going to go down to the bottom left where the networking section is. I'm going to click on VPC. And the VPC dashboard will load up. Now there's a couple of ways you can create a custom VPC. There's something called the VPC wizard, which will build VPCs on your behalf from a selection of different configurations. For example, a VPC with a single public subnet, or a VPC with public and private subnets. Now this is great because you click a button, type in a few details, and it does the work for you. However, you're not going to learn much or pass the exam if this is how you do it. So we'll cancel that and we'll go to your VPCs and we'll click on Create a VPC. And we're presented with the Create a VPC window. So let's give our VPC a name. I'm going to call it Simplilearn_VPC. And this is the kind of naming convention I'll be using throughout this course. Next we need to give it the CIDR block, or the classless interdomain routing block. So we're going to give it a very simple one, 10.0.0.0, and then we need to give it the subnet mask. So you're not allowed to go larger than 15. So if I try to put 15 in, it says no, not going to happen. For a reference, subnet mask of 15 would give you around 131,000 IP addresses, and subnet 16 will give you 65,536, which is probably more than enough for what we're going to do. Next you get to choose the tenancy. There's two options, default and dedicated. If you select dedicated, then your EC2 instances will reside on hardware that's dedicated to you. So your performance is going to be great, but your cost is going to be significantly higher. So I'm going to stick with default, and we just click on yes, create. It'll take a couple of seconds, and then in our VPC dashboard we can see our Simplilearn VPC has been created. Now if we go down to the bottom here to see the information about our new VPC, we can see it has a route table associated with it, which is our default route table. So there it is, and we can see that it's only allowing local traffic at the moment. We go back to the VPC again, we can see it's been given a default network ACL, and we'll click on that and have a look. And you can see this is very similar to what we looked at in the lesson. So it's allowing all traffic from all sources, inbound and outbound. Now if we go to the subnet section and just widen the VPC area here, you can see there's no subnets associated with the VPC we just created. So that means we won't be able to launch any instances into our VPC. And to prove it, I'll just show you. We'll go to the EC2 section. So this is a glimpse into your future. This is what we'll be looking at in the next lesson. And we'll just quickly try and launch an instance. We'll select any instance, it doesn't matter. Any size, not important. So here, the network section, if I try and select Simplilearn VPC, it's saying no subnets found, this is not going to work. So we basically need to create some subnets in our VPC, and that is what we're going to look at in the next lesson. Now, private IP addresses are IP addresses that are not reachable over the internet, and they're used for communication between instances in the same network. When you launch a new instance, it's given a private IP address, and an internal DNS hostname that resolves to the private IP address of the instance. But if you want to connect to this from the internet, it's not going to work. So then you'd need a public IP address, which is reachable from the internet. You can use public IP addresses for communication between your instances and the internet. Each instance that receives a public IP address is also given an external DNS hostname. Public IP addresses are associated with your instances from the Amazon pool of public IP addresses. When you stop or terminate your instance, the public IP address is released and a new one is associated when the instance starts. So if you want your instance to retain its public IP address, you need to use something called an elastic IP address. An elastic IP address is a static or persistent public IP address that's allocated to your account and can be associated to and from your instances as required. An elastic IP address remains in your account until you choose to release it. There is a charge associated with an elastic IP address if it's in your account but not actually allocated to an instance. This is a demonstration of how to create an elastic IP address. So we're back at the Amazon Web Services Management Console. We're going to head back down to the networking VPC section and we'll get to the VPC dashboard. On the left hand side we'll click on Elastic IPs. Now you'll see a list of any elastic IPs that you have associated in your account, and remember, any elastic IP address that you're using that isn't allocated to something you'll be charged for. So I have one available and that is allocated to an instance currently. So we want to allocate a new address, and it reminds you that there's a charge if you're not using it. I'm saying yes, allocate, and it takes a couple of seconds, and there's our new elastic IP address. Now we'll be using this IP address to associate with the NAT gateway when we build that. AWS defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select. You can use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. The net mask for the default subnet in your VPC is always 20, which provides up to 4,096 addresses per subnet, and a few of them are reserved for AWS use. A VPC can span multiple availability zones, but a subnet is always mapped to a single availability zone. This is important to know. So here's our basic diagram, which we're now going to start adding to. So we can see the virtual private cloud, and you can see the availability zones, and now inside each availability zone we've created a subnet. Now you won't be able to launch any instances unless there are subnets in your VPC. So it's good to spread them across availability zones for redundancy and failover purposes. There's two different types of subnet, public and private. You use a public subnet for resources that must be connected to the internet, for example web servers. A public subnet is made public because the main route table sends the subnet's traffic that is destined for the internet to the internet gateway, and we'll touch on internet gateways next. Private subnets are for resources that don't need an internet connection or that you want to protect from the internet, for example database instances. So in this demonstration we're going to create some subnets, a public and a private subnet, and we're going to put them in our custom VPC in different availability zones. So we'll head to networking and VPC, wait for the VPC dashboard to load up. We'll click on subnets. We'll go to create subnet. And I'm going to give the subnet a name. So it's good to give them meaningful names. So I'm going to call this first one for the public subnet 10.0.1.0, and I'm going to put this one in the US East 1B availability zone, and I'm going to call it Simplilearn public. So it's quite a long name, I understand, but at least it makes it clear for what's going on in this example. So we need to choose a VPC. So we obviously want to put it in our Simplilearn VPC. And I said I wanted to put it in US East 1B. I'm using the North Virginia region, by the way. So we click on that. Then we need to give it the CIDR block. Now, as I mentioned earlier, when I typed in the name, that's the range I want to use. And then we need to give it the subnet mask. And we're going to go with 24, which should give us 251 addresses in this range, which obviously is going to be more than enough. If I try and put a different value in that's unacceptable to Amazon, it's going to say, it's going to give me an error and tell me not to do that. Let's go back to 24 and click. I'm going to cut and paste this, by the way, just because I need to type something very similar for the next one. Click create. And it takes a few seconds. Okay, so there's our new subnet. And if I just widen this, you can see, so that's the IP range, that's the availability zone, it's for Simplilearn, and it's public. So now we want to create the private. So we put the name in. I'm going to give the private the IP address block of that. I'm going to put this one in US East 1C, and it's going to be the private subnet. Obviously I want it to be in the same VPC. Availability zone of US East 1C, and we're going to give it 10.0.2.0/24, and we'll click yes, create. And again, it takes a few seconds. Okay, so let me sort by name. So there we are, we can see now we've got our private subnet and our public subnet. In fact, let me just type in Simplilearn, there we are. So now you can see them both there. And you can see they're both in the same VPC, Simplilearn VPC. Now if we go down to the bottom, you can see the route table associated with these VPCs. And you can see that they can communicate with each other internally, but there's no internet access. So that's what we need to do next. In the next lesson, you're going to learn about internet gateways and how we can make these subnets have internet access. Welcome to the networking section. In this section, we're going to take a look at internet gateways, route tables, and NAT devices. And we'll have a demonstration on how to create each of these AWS VPC items. So to allow your VPC the ability to connect to the internet, you need to attach an internet gateway. And you can only attach one internet gateway per VPC. So attaching an internet gateway is the first stage in permitting internet access to instances in your VPC. Now here's our diagram again, and now we've added the internet gateway, which is providing the connection to the internet to your VPC. But before you can configure internet correctly, there's a couple more steps. For an EC2 instance to be internet connected, you have to adhere to the following rules. Firstly, you have to attach an internet gateway to your VPC, which we just discussed. Then you need to ensure that your instances have public IP addresses or elastic IP addresses, so they're able to connect to the internet. Then you need to ensure that your subnet's route table points to the internet gateway, and you need to ensure that your network access control and security group rules allow relevant traffic to flow to and from your instance. So you need to allow the rules to let in the traffic you want, for example HTTP traffic. After the demonstration for this section, we're going to look at how route tables, access control lists, and security groups are used. In this demonstration, we're going to create an internet gateway and attach it to our custom VPC. So let's go to Networking VPC, bring up the VPC dashboard, and on the left-hand side, we click on Internet Gateways. So here's a couple of Internet Gateways I have already, but I need to create a new one. So create Internet Gateway. I'll give it a name, which is going to be Simplilearn Internet Gateway, IGW. And I'm going to click Create. So this is an Internet Gateway which will connect a VPC to the Internet, because at the moment our custom VPC has no Internet access. So there, it's created. Simplilearn IGW. But its state is detached because it's not attached to anything. So let me try and attach it to a VPC. And it gives me an option of all the VPCs that have no Internet Gateway attached to them currently. So I only have one, which is Simplilearn VPC. Yes, attach. Now you can see our VPC has Internet attached, and you can see that down here. So let's click on that, and it will take us to our VPC. But before any instances in our VPC can access the Internet, we need to ensure that our subnet route table points to the Internet Gateway. And we don't want to change the main route table, we want to create a custom route table. And that's what you're going to learn about next. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only be associated with one route table. However, multiple subnets can be associated with the same route table. Every VPC has a default route table, and it's good practice to leave this in its original state and create a new route table to customize the network traffic routes associated with your VPC. So here's our example, and we've added two route tables, the main route table and the custom route table. The new route table, or the custom route table, will tell the Internet Gateway to direct Internet traffic to the public subnet. But the private subnet is still associated to the default route table, the main route table, which does not allow Internet traffic to it. All traffic inside the private subnet is just remaining local. In this demonstration, we're going to create a custom route table, associate it with our Internet Gateway, and associate our public subnet with it. So let's go to Networking and VPC. The dashboard will load, and we're going to go to Route Tables. Now our VPC only has its main route table at the moment, the default one it was given at the time it was created. So we want to create a new route table, and we want to give it a name. So we're going to call it Simplilearn. I'm going to call it Route Table, RTB for short. And then we get to pick which VPC we want to put it in. So obviously we want to use Simplilearn VPC. So we click Create. It will take a couple of seconds, and here you are. Here's our new route table. So what we need to do now is change its route so that it points to the Internet Gateway. So if we go down here to Routes, at a minute you can see it's just like our main route table. It just has local access. So we want to click on Edit, and we want to add another route. So the destination is the Internet, which is all the zeros, and our target, and we click on this, it gives us the option of our Internet Gateway, which we want to do. So now we have Internet access to this subnet, to this route table. And we click on Save. Save was successful. So now we can see that as well as local access, we have Internet access. Now at the moment, if we click on Subnet Associations, you do not have any subnet associations. So basically, both our subnets, the public and private subnets, are associated with the main route table, which doesn't have Internet access. So we want to change this. So we'll click on Edit, and we want our public subnet to be associated with this route table. So click on Save. So it's just saving that. So now we can see that our public subnet is associated with this route table, and this route table is associated with the internet gateway. So now anything we launch into the public subnet will have internet access. But what if we wanted our instances in the private subnet to have internet access? Well, there's a way of doing that with a NAT device, and that's what we're going to look at in the next lecture. You can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating connections with the instances in the private subnet. So we talked earlier about public and private subnets to protect your assets from being directly connected to the internet. For example, your web server would sit in the public subnet, and your database in the private subnet, which has no internet connectivity. However, your private subnet database instance might still need internet access or the ability to connect to other AWS resources. If so, you can use a network address translation device or a NAT device to do this. A NAT device forwards traffic from your private subnet to the internet or other AWS services, and then sends the response back to the instances. When traffic goes to the internet, the source IP address of your instance is replaced with the NAT device address, and when the internet traffic comes back again, the NAT device translates the address to your instance's private IP address. So here's our diagram, which is getting ever more complicated, and if you look in the public subnet, you can see we've now added a NAT device, and you have to put NAT devices in the public subnet so that they get internet connectivity. AWS provides two kinds of NAT devices, a NAT gateway and a NAT instance. AWS recommends a NAT gateway as it's a managed service that provides better availability and bandwidth than NAT instances. Each NAT gateway is created in a specific availability zone and is implemented with redundancy in that zone. A NAT instance is launched from a NAT AMI, an Amazon Machine Image, and runs as an instance in your VPC. So it's something else you have to look after, whereas a NAT gateway, being a fully managed service, means once it's installed, you can pretty much forget about it. A NAT gateway must be launched into a public subnet because it needs internet connectivity. It also needs an elastic IP address, which you can select at the time of launch. Once created, you need to update the route table associated with your private subnet to point internet-bound traffic to the NAT gateway. This way, the instances in your private subnets can communicate with the internet. So if you remember back to the diagram when we had the custom route table, which was pointed to the internet gateway, now we're pointing our main route table to the NAT gateway, so that the private subnet also gets internet access, but in a more secure manner. Welcome to the Create a NAT Gateway demonstration, where we're going to create a NAT gateway so that the instances in our private subnet can get internet access. So we'll start by going to Networking and VPC. And the first thing we're going to do is take a look at our subnets, and you'll see why shortly. So here are our Simplilearn subnets. So this is the private subnet that we want to give internet access. But if you remember from the section, NAT gateways need to be placed in public subnets. So I'm just going to copy the name of this subnet ID for the public subnet, and you'll see why in a moment. So then we go to NAT gateways on the left hand side, and we want to create a new NAT gateway. So we have to put a subnet in there. So we want to choose our public subnet. Now, as you can see, it truncates a lot of the subnet names on this option, so it's a bit confusing. So we know that we want to put it in our Simplilearn VPC in the public subnet, but you can see it's truncated. So it's actually this one at the bottom, but what I'm going to do is just paste in the subnet ID, which I copied earlier, so there's no confusion. Then we need to give it an elastic IP address. Now, if you remember from the earlier demonstration, we created one, so let's select that. But if you hadn't allocated one, you could click on the Create New EIP button. So we'll do that. Okay, so it's telling me my NAT gateway has been created. And in order to use your NAT gateway, ensure that you edit your route table to include a route with a target of and then our NAT gateway ID. So it's given us the option to click on our edit route tables, so we'll go straight there. Now here's our route tables. Now here's the custom route table that we created earlier, and this is the default, the main route table, which was created when we created our VPC. So we should probably give this a name so that we know what it is. So let me just call this Simplilearn RTB main. So now we know that's our main route table. So if you take a look at the main route table and the subnet associations, you can see that our private subnet is associated with this table. So what we need to do is put a route in here that points to the NAT gateway. So if we click on routes and edit, and we want to add another route, and we want to say that all traffic can either go to the internet gateway, which we don't want to do. We want to point it to our NAT instance, which is this NAT ID here. And we click save. So now any instances launched in our private subnet will be able to get internet access via our NAT gateway. Welcome to the Using Security Groups and Network ACL section. In this section, we're going to take a look at security groups and network ACLs, and we're going to have a demonstration on how you create both of these items in the Amazon Web Services console. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. Basically, a security group controls the inbound and outbound traffic for one or more EC2 instances. Security groups can be found on both the EC2 and VPC dashboards in the AWS Web Management Console. We're going to cover them here in this section, and you'll see them crop up again in the EC2 lesson. And here is our diagram, and you can see we've now added security groups to it. And you can see that EC2 instances are sitting inside the security groups, and the security groups will control what traffic flows in and out. So let's take a look at some examples, and we'll start with a security group for a web server. Now obviously a web server needs HTTP and HTTPS traffic as a minimum to be able to access it. So here is an example of the security group table, and you can see we're allowing HTTP and HTTPS, the ports that are associated with those two, and the sources, and we're allowing it from the internet. We're basically allowing all traffic to those ports. And that means any other traffic that comes in on different ports would be unable to reach the security group and the instances inside it. Let's take a look at an example for a database server security group. Now imagine you have a SQL Server database, then you would need to open up the SQL Server port so that people can access it, which is port 1433 by default. So we've added that to the table and we've allowed the source to come from the internet. Now because it's a Windows machine, you might want RDP access so you can log on and do some administration. So we've also added RDP access to the security group. Now you could leave it open to the internet, but that would mean anyone could try and hack their way into your box. So in this example, we've added a source IP address of 10.0.0.0.0. So only IP ranges from that address can RDP to the instance. Now there's a few rules associated with security groups. By default, security groups allow all outbound traffic. So if you want to tighten that down, you can do so in a similar way to you can define the inbound traffic. Security group rules are always permissive. You can't create rules that deny access, so you're allowing access rather than denying it. Security groups are stateful, so if you send a request from your instance, the response traffic for that request is allowed to flow in regardless of the inbound security group rules. And you can modify the rules of a security group at any time, and the rules are applied immediately. Welcome to the Create Security Group demonstration, where we're going to create two security groups one to host DB servers and one to host web servers. Now, if you remember from the best practices section, it said it was always a good idea to tier your applications into security groups, and that's exactly what we're going to do. So if we go to networking and VPC to bring up the VPC dashboard, on the left hand side under security we click on security groups. Now you can also get to security groups from the EC2 dashboard as well. So here's a list of my existing security groups, but we want to create a new security group, and we're going to call it Simplilearn Web Server SG security group, and we'll give the group name as the same, and our description is going to be Simplilearn Web Servers security groups. Okay, and then we need to select our VPC. Now it defaults to the default VPC, but obviously we want to put it in our Simplilearn VPC. So we click yes, create. Takes a couple of seconds, and there it is. There's our new security group. Now if we go down to the rules, the inbound rules, you can see there are none. So by default a new security group has no inbound rules. But what about outbound rules? If you remember from the lesson, a new security group by default allows all traffic to be outbound, and there you are, all traffic has destination of everywhere, so all traffic is allowed. But we want to add some rules, so let's click on inbound rules, click on edit. Now this is going to be a web server, so if we click on the drop down we need to give it HTTP, so you can either choose custom TCP rule and type in your own port ranges, or you can just use the ones they have for you. So HTTP, this pre-populates the port range, and then here you can add the source. Now if I click on it, it's giving me the option of saying allow access from different security groups. So you could create a security group and say I only accept traffic from a different security group, which is a nice way of securing things down. You could also put in here just your IP address so that only you could do HTTP requests to the instance. But because it's a web server, we want people to be able to see our website, otherwise it's not going to be much use. So we're going to say all traffic, so all source traffic can access our instance on port HTTP 80. I want to add another rule because we also want to do HTTPS, which is hiding from me. There we are. And again we want to do the same. And also because this is going to be a Linux instance, we want to be able to connect to the Linux instance to do some work and configuration. So we need to give it SSH access. And again, it would be good practice to tie it down to your specific IP or an IP range, but we're just going to do all for now. And then we click on save, and there we are, there we have our ranges. So now we want to create our security group for our DB servers. So let's click create security group, and then we'll go through it and give it a similar name, Simplilearn DB servers SG. And the description is going to be Simplilearn DB servers security group. And our VPC is obviously going to be Simplilearn VPC. So let's click yes, create, we'll wait a few seconds. And here's our new security group. As you can see, it has no inbound rules by default, and outbound rules allow all traffic. So this is going to be a SQL Server database server. And so we need to allow SQL Server traffic into the instance. So we need to give it Microsoft SQL port access. Now the default port for Microsoft SQL Server is 1433. Now in reality I'd probably change the port the SQL Server was running on to make it more secure, but we'll go with this for now. And then the source. So we could choose the IP ranges again, but what we want to do is place the DB server in the private subnet and allow the traffic to come from the web server. So the web server will accept traffic, and the web server will then go to the database to get the information it needs to display on its on the website. Or if people are entering information into the website, we want the information to be stored in our DB server. So basically we want to say that the DB servers can only accept SQL Server traffic from the web server security group. So we can select the Simplilearn web server security group as the source traffic for Microsoft SQL Server data. So we'll select that. Now our SQL Server is obviously going to be a Windows instance, so from time to time we might need to log in and configure it. So we want to give RDP access. Now again, you would probably put a specific IP range in there. We're just going to do all traffic for now. Then we click Save. And there we are. So now we have two security groups, DB servers and web servers. A network ACL is a network access control list, and it's an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets. You might set up network ACLs with rules similar to your security groups in order to add an additional layer of security to your VPC. Here is our network diagram, and we've added network ACLs to the mix. Now you can see they sit somewhere between the route tables and the subnets. This diagram makes it a little bit clearer, and you can see that a network ACL sits in between a route table and a subnet. And also you can see an example of the default network ACL, which is configured to allow all traffic to flow in and out of the subnets to which it's associated. Each network ACL includes a rule, whose rule number is an asterisk. This rule ensures that if a packet doesn't match any of the other numbered rules, it's denied. You can't modify or remove this rule. So if you take a look at this table, you can see on the inbound, some traffic would come in and it would look for the first rule, which is 100. And that's saying I'm allowing all traffic from all sources. So that's fine, the traffic comes in. If that rule 100 wasn't there, it would go to the asterisk rule. And the asterisk rule is saying traffic from all sources is denied. Let's take a look at the network ACL rules. Each subnet in your VPC must be associated with an ACL. If you don't assign it to a custom ACL, it will automatically be associated to your default ACL. A subnet can only be associated with one ACL. However, an ACL can be associated with multiple subnets. An ACL contains a list of numbered rules which are evaluated in order, starting with the lowest. As soon as a rule matches traffic, it's applied regardless of any higher numbered rules that may contradict it. AWS recommends incrementing your rules by a factor of 100, so there's plenty of room to implement new rules at a later date. Unlike security groups, ACLs are stateless. Responses to allowed inbound traffic are subject to the rules for outbound traffic. Welcome to the network ACL demonstration, where we're just going to have an overview of ACLs where they are in the dashboard. Now you don't need to know a huge amount about them for the exam, you just need to know how they work and where they are. So let's go to networking and VPC, and when the dashboard loads, on the left hand side under security there's network ACLs. So let's click on that. Now you can see some ACLs that are in my AWS account. So we want the one that's associated with our Simplilearn VPC. So if we extend this VPC column, that's our network ACL there, Simplilearn VPC. Now let's give it a name because it's not very clear to see otherwise. Also, I'm kind of an obsessive tagger. So let's call it Simplilearn ACL and click on the tick. So there we are. So now it's much easier to see. So we click on inbound rules. So this is exactly what we showed you in the lesson. The rule is 100, so that's the first rule that's going to get evaluated, and it's saying allow all traffic from all sources. And the outbound rules are the same. So if you wanted to tighten down the new rule, you could click edit. We would give it a new rule number, say which would be 200. So you should always increment them in 100. So that means if you had 99 more rules you needed to put in place, you'd have space to put them in between these two. And then you could do whatever you wanted. You could say, you know, we are allowing HTTP access from all traffic, and we're allowing, or you could say, actually, you know what, we're going to deny it. So this is the way of blacklisting traffic into your VPC. Now I'm not going to save that because we don't need it. but this is where network ACLs sit, and this is where you would make any changes. It's also worth having a look at the subnet associations with your ACL. So we have two subnets in our Simplilearn VPC, so we would expect to see both of them associated with this network ACL because it's the default. And there they are. There's both our public and our private subnets are associated. And you can also see up here on the dashboard, it says default. So this is telling us this is our default ACL. If you did want to create a new network ACL, you would click Create Network ACL. You'd give it a name, just say New ACL, and then you would associate it with your VPC. So we would say Simplilearn VPC. Takes a few seconds, and there we are. There we have our new one. Now you can see this one says default no, because it obviously isn't the default ACL for our Simplilearn VPC, and it has no subnets associated with it. So let's just delete that because we don't need it. But there you are. There's a very brief overview of network ACLs. Welcome to the Amazon VPC Best Practices and Costs, where we're going to take a look at the best practices and the costs associated with the Amazon Virtual Private Cloud. Always use public and private subnets. You should use private subnets to secure resources that don't need to be available to the internet, such as database services. To provide secure internet access to the instances that reside in your private subnets, you should provide a NAT device. When using NAT devices, you should use a NAT gateway over NAT instances because they're a managed service and require less administration effort. You should choose your CIDR blocks carefully. Amazon VPC can contain from 16 to 65,536 IP addresses, so you should choose your CIDR block according to how many instances you think you'll need. You should also create separate Amazon VPCs for development, staging, test and production, or create one Amazon VPC with separate subnets with a subnet each for production, development, staging and test. You should understand the Amazon VPC limits. There are various limitations on the VPC components. For example, you're allowed 5 VPCs per region, 200 subnets per VPC, 200 route tables per VPC, 500 security groups per VPC, 50 in- and outbound rules per VPC. However, some of these rules can be increased by raising a ticket with AWS support. You should use security groups and network ACLs to secure the traffic coming in and out of your VPC. Amazon advises to use security groups for whitelisting traffic and network ACLs for blacklisting traffic. Amazon recommends tiering your security groups. You should create different security groups for different tiers of your infrastructure architecture inside VPC. If you have web tiers and DB tiers, you should create different security groups for each of them. Creating tier-wise security groups will increase the infrastructure security inside the Amazon VPC. So if you launch all your web servers in the web server security group, that means they'll automatically all have HTTP and HTTPS open. Conversely, the database security group will have SQL Server ports already open. You should also standardize your security group naming conventions. Following a security group naming convention allows Amazon VPC operation and management for large-scale deployments to become much easier. Always span your Amazon VPC across multiple subnets in multiple availability zones inside a region. This helps in architecting high availability inside your VPC. If you choose to create a hardware VPN connection to your VPC using Virtual Private Gateway, you are charged for each VPN connection hour that your VPN connection is provisioned and available. Each partial VPN connection hour consumed is billed as a full hour. You'll also incur standard AWS data transfer charges for all data transferred via the VPN connection. If you choose to create a NAT gateway in your VPC, you are charged for each NAT gateway hour that your NAT gateway is provisioned and available. Data processing charges apply for each gigabyte processed through the NAT gateway. Each partial NAT gateway hour consumed is billed as a full hour. This is the practice assignment for designing a custom VPC, where you'll create a custom VPC using the concepts learnt in this lesson. Using the concepts learnt in this lesson, recreate the custom VPC as shown in the demonstrations. The VPC name should be Simplilearn VPC. The CIDR block should be 10.0.0.0/16. There should be two subnets, one public with a range of 10.0.1.0 and one private with a range of 10.0.2.0, and they should be placed in separate availability zones. There should be one internet gateway and one NAT gateway, and also one custom route table for the public subnet. Also create two security groups, Simplilearn Web Server Security Group and Simplilearn DB Server Security Group.
So let's review the key takeaways from this lesson.
Amazon Virtual Private Cloud, or VPC, enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using scalable infrastructure of AWS. There are three types of IP address in AWS. A private IP address. This is an IP address that's not reachable over the internet, and it's used for communication between instances in the same network. A public IP address is reachable from the internet, which you can use for communication between your instances and the internet. And there's an elastic IP address. This is a static, public, persistent IP address that persists after an instance restarts, whereas a public IP address is reassociated after each restart. Amazon defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select, and a subnet is always mapped to a single availability zone. Use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. To allow your VPC the ability to connect to the internet, you need to attach an internet gateway to it, and you can only attach one internet gateway per VPC. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only have an association with one route table. However, multiple subnets can be associated to the same route table. And you can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services. But a NAT device will prevent the internet from initiating connections with instances inside your private subnet. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. A Network Access Control List, or Network ACL, is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets.
Let's look into what we have in our session. So what's in it for you? We would be covering what is AWS, why do we need AWS SageMaker, what is AWS SageMaker Services, what are the benefits of using the AWS SageMaker, machine learning with AWS SageMaker, how to train a model with AWS SageMaker, how to validate a model with AWS, and the companies that are using AWS SageMaker. Along with that, we will be covering up one live demo on the AWS platform. Now let's understand what is AWS. So what is AWS? It's an Amazon Web Services. It's the largest or most widely used public cloud platform offered by Amazon. It provides services over the internet. AWS services can be used to build, monitor, and deploy any type of application in the cloud. AWS also uses the subscription pricing model. That means you only pay for whatever the services you use for. Now, why do we need AWS SageMaker? Let's look into it. So let's consider an example of one of the company, that is ProQuest. Now, before AWS SageMaker, the ProQuest is a global information content and technology company that provides valuable content such as ebooks, newspapers, etc. to the users. Before AWS SageMaker, the ProQuest requirement was to have a better user experience. maximum relevant search results. Now after AWS SageMaker, they were able to achieve those results. So they achieved more appealing video user experience. They achieved more relevant search results for the users. Now, what do we mean by AWS SageMaker? Why this service is primarily used? So Amazon SageMaker is a cloud machine learning platform that helps users in building, training, tuning, and deploying machine learning models in a production-ready hosted environment. So it's kind of a machine learning service which is already hosted on the AWS platform. Now, what are the benefits of using AWS SageMaker? The key benefits of using AWS SageMaker are: it reduces machine learning data cost, so you can do the cost optimization while running this particular service on the AWS. All ML components are stored in a particular place in a dashboard, so they can be managed together. Highly scalable, so it can be scalable you can scale this particular service on the fly. It trains the models quite faster, maintains the uptime, so you can be assured that your workloads will be running all the time, it will be available all the time. High data security, so security becomes a major concern on the cloud platforms, and it ensures that you have the high data security. Along with that, you can do a data transfer to different AWS services like S3 bucket and all with the simple data transfer techniques. Now, machine learning with AWS SageMaker, let's look into it. So machine learning with AWS SageMaker is a 3-step function. So one is to build, second is to test and tune the model, and third is to deploy the model. Now with the build, it provides more than 15 widely used ML algorithms for training purpose. Now to build a model, you can collect and prepare training data, or you can select from the Amazon S3 bucket also. Choose and optimize the required algorithm. So some of the algorithms that you can select are k-means, linear regressions, logistic regression. SageMaker helps developers to customize ML instances with the Jupyter Notebook interface. In the test and tune, you have to set up and manage the environment for training. So you would need some sample data to train the model. So train and tune a model with the Amazon SageMaker. SageMaker implements hyperparameter tuning by adding a suitable combination of algorithm parameters. Also, it divides the training data and stores that in the Amazon S3. S3 is a simple storage service which is primarily used for storing the objects and the data. Hence, it is used for storing and recovering data over the internet. And below you can see that AWS SageMaker uses Amazon S3 to store data as it's safe and secure. Also, it divides the training data and stores in Amazon S3, where the training algorithm code is stored in the ECR. ECR stands for Elastic Container Registry, which is primarily used for containers and Dockers. ECR helps users to save, monitor, and deploy Docker and the containers. Later, SageMaker sets up a cluster for the input data, trains it, and stores it in the Amazon S3 itself. So this is done by the SageMaker itself. After that, you need to deploy it. So suppose you want to predict limited data at a time, you use Amazon SageMaker hosting services for that. Okay. But if you want to get prediction for an entire data set, prefer using Amazon SageMaker batch transform. Now the last step, that is to deploy the model. So once tuning is done, models can be deployed to SageMaker endpoints, and in the endpoint, real-time prediction is performed. So you would have some data which you would reserve and validate your model whether it is working correctly or not. Now evaluate your model and determine whether you have achieved your business goals. Now the other aspect is how we can train a model with AWS SageMaker. So this is basically a flow diagram which shows you how to train a model with the AWS SageMaker, and here we have used a couple of services of an AWS to get that done. So model training in AWS SageMaker is done on machine learning compute instances, and here we can see there are two machine learning compute instances used as helper code and the training code. Along with that, we are using two S3 buckets and the ECR for the container registry. Now let's look into what are the ways to train the model as per the slides. So below are the following requirements to train a model. So here in the diagram you can see these are the following requirements to train a model. the URL of an Amazon S3 bucket where the training data is stored, that is mentioned. The compute resources on machine learning compute instances. So these are all your machine learning compute instances. Then the URL of an Amazon S3 bucket where the output will be stored, and the path of AWS Elastic Container Registry where the code data is saved. The inference code image lies in the Elastic Container Registry. Now, what are these called? These are called as the training jobs. Now, when a user trains a model in Amazon SageMaker, he/she creates a training job. So we need to first create a training job, and then the input data is fetched from the specified Amazon S3 bucket. Once the training job is built, Amazon SageMaker launches the ML compute instances. So these compute instances will be launched once the training job is built. Then it trains the model with the training code and the data set, and it shows the output and model artifacts in the AWS S3 bucket. So this is done automatically. Now here the helper code performs a task when the training code fails. The interference code, which is in the Elastic Container Registry, consists of multiple linear sequence containers that process the request for inference on data. The EC2 Container Registry is a container registry that helps users to save, monitor, and deploy container images, whereas container images are the ready applications. Once the data is trained, the output is stored in the specified Amazon S3 bucket. So here you can see the output will be stored here. To prevent your algorithm being deleted, save the data in Amazon SageMaker Critical System, which can process your ML compute instances. Now, how to validate a model? Let's look into it. So you can evaluate your model using offline or using the historical data. So first thing is that you can do the offline testing to validate a model. You can do an online testing with the live data. So if you have a live data coming or real-time streams coming, you can validate a model from there as well. You can validate using a holdout set, and also you can validate using the k-fold validation. Now use historical data to send requests to the model through the Jupyter Notebook in Amazon SageMaker for the evaluation. Online testing with live data deploys multiple models into the endpoints of Amazon SageMaker and directs live traffic to the model for validation. Validating using a holdout set is part of the data is set aside, which is called holdout set. So the part of the data is left, which is basically called as the holdout set. This data is not used for the model training. So later, when the model is trained with the remaining input data and generalize the data based on what is learned initially. So whatever the data which is left out will be used for validating a model, because we have not used that data while training a model. The k-fold validation is the input data is split into two parts. One part is called k, which is the validation data for testing the model, and the other part is k-1, which is used as a training data. Now, based on the input data, the machine learning model evaluates the final output. Now, the companies that are using AWS SageMaker, one is the ADP. So you must be knowing about ADP, Zalando, Dow Jones, which is the stock market, ProQuest, and the Intuit. Now let's look into the demo that how we can actually run the AWS SageMaker. So we'll use the R algorithm and then package the algorithm as a container for building, training, and deploying a model. We are going to use the Jupyter Notebook for that, for model building, for model training, for model deployment, and the code for the demo is in the below link. So you can see here that from this link you can get the code for the demo. Let's try to do a demo on the AWS. Now I would be using a link which is provided by Amazon to build, train, and deploy the machine learning model on the SageMaker, as you can see on my screen. And in this tutorial, you would have some steps where you can put those steps and the code, Python codes, into your AWS SageMaker Jupyter Lab. So in this tutorial, you will learn how to use Amazon SageMaker to build, train, and deploy a machine learning model. And for that, we will use the popular XGBoost ML algorithm for this exercise. So first of all, what you need to do is you have to go to the AWS console, and there you have to create a notebook instance. So in this tutorial, you will be creating a notebook instance. You will prepare the data, train the model to learn from the data, deploy the model, evaluate your ML model's performance, and once all those activities are done, then we'll see how we can actually remove all the resources in order to prevent the extra costing. Now the first step is we have to enter to the Amazon SageMaker console. So here you can see I'm already logged in into the SageMaker console. You can click on the services, search for the SageMaker here, and here you get the Amazon SageMaker service. Now the next step is that we have to create a notebook instance. So we will select the notebook instance from the SageMaker service, and then after the notebook instance is selected, we'll put a name to our instance and we'll create a new IAM role for that. So let's wait for the SageMaker Studio to open. So here you can see the Studio is open, and you just have to click on the notebook instances, and here you have to create a notebook instance. So here you can see a couple of notebook instances have already been created. One of them is in service. So this is the notebook instance that we are going to use for creating the demo model. I'll show you how you can create a notebook instance. You just have to click on create notebook instance button and put your notebook instance name. So you can put something like demo-sagemaker 987, or we can put it as model. We'll go with notebook instance type as default, which is mlt2.media. And in the permission and encryptions under the IAM role, we'll click on create a new IAM role. Now why we are creating a new IAM role? So that we can allow the SageMaker to access any S3 bucket that has been created on our account. Just click on create a role, and here you would see that the new IAM role will be created with the set of permissions. Then rest of the things we'll keep it as default, and then you just have to click on create a notebook instance. The notebook instance creation takes some time, so you just have to wait for a couple of minutes to get that in service. We already have one of the notebook instance that has been created, so we will be using that to create a demo. Now going back to the steps, so these are the steps that we have already performed. Now once the notebook instance is created, then we have to prepare the data. So in this step, we will be using the SageMaker notebook instance to pre-process the data that would require to train the machine learning model. And for that, we would be opening up the Jupyter notebook, and then we have to select an environment, a kernel environment in the Jupyter notebook that would be conda_python 3. So let's follow these steps. Go back to the SageMaker, click on the notebook instances, select the running notebook instance, and here you would select the Open Jupyter Lab. Now here you would see that the SageMaker would try to open up the Jupyter notepad, and we would be performing all our inputs into that Jupyter notebook and executing the results there itself. So just wait for the notebook to open. Now here you can see the Jupyter Lab notebook has been opened. So I would be selecting one of the notebook that has been created. So this one. So likewise, you can create your own notebook also. How you can do that? First of all, let me select the kernel environment. So I would be selecting conda_python 3 and just click on select. So how you can create your own notebook? Just have to click on file, click on new, and here you can select the notebook. Just name your notebook, select the environment conda_python 3 to run this demo. So I have my notebook open. So in the tabs, I would be putting up the Python codes and I would be executing those codes to get the output directly. So the next step is to prepare the data, train the ML model and deploy it. We will need to import some libraries and define a few environment variables in the Jupyter notebook environment. So I would be copying this code, which you can see that would try to import NumPy, pandas. These are all required to run the Python syntax. So just copy this code and paste it into your notebook. Right? So once you do that, execute your code, and here you can see that you get the output, which is that it has imported all the necessary libraries that have been defined in the code. Now the next step is we would create an S3 bucket into the S3 service, and for that you have to copy this Python code, just that you have to edit it. So you have to specify this bucket name that you want to get created. So here I would provide the bucket name, which should be unique, should not overlap. So something like SageMaker dash demo is the name that I have selected for the bucket, and now you have to execute that code. It says that the S3 bucket has been created successfully with the name SageMaker-demo 9876. So this is something which you can verify. So you can go to the S3 service and there you can verify whether the bucket has been created or not. Now the next task is that we need to download the data to the AWS SageMaker instance and load it into the data frame. And for that we have to follow this URL. So from this URL, which is build, train, deploy machine learning model, would have a data in the form of bank_clean.csv, and this will be deployed onto our SageMaker instance. We'll copy this code and paste it here and execute the code. So it says that it has successfully downloaded bank_clean.csv, which has the data inside it, and that has been loaded into the SageMaker data frame successfully. Now we have a data to build and train our machine learning model. So what we are going to do, we are going to shuffle the data and we are going to split it, one into the training data set and the other one into test data set. So for the training data set, we are going to use 70% of the customers that are listed in the CSV file, and 30% of the customers in the CSV file data, we will be using it as a test data to train the model. So we will copy the following code into a new code cell and then we are going to run that code cell. So I'll just copy it for training the data so that we can segregate the data model, 70% for building the model and 30% for testing the data. So click on run the execution and here you can see that we got the output successfully. Now we have to train the model from that data. So how we are going to train that model? And for that we'll use SageMaker pre-built XGBoost model, which is an algorithm. So you will need to reformat the header and first column of the training data and load the data from the S3 bucket. So what I'll do is I'll copy this syntax and paste it in the node cell. So it has the train data, it would train the model. Click on run execution. Now it is changing the S3 input class, which will be renamed to training input, because now we are training the model with the training data. So we just have to wait for some time till it gets executed completely. Now the next thing is that we need to set up the Amazon SageMaker session to create an instance of the XGBoost model. So here we are going to create this SageMaker session. We are going to create an instance of the XGBoost model, which is an estimator. So just copy that code and paste it here. Execute it. And here you can see that it will start. It has basically changed the parameter image name to the image_URI in the SageMaker Python SDK v2. Now we'll follow the next step, that is with the data loaded in the XGBoost estimator, we'll set up train the model using gradient optimization. And we'll copy the following code and that would actually start the training of the model. So copy this code and this would actually start training the model using our input data that we have reserved, 70% of that data that we have reserved for training the model. So just copy that, again initiate the execution, and it will start the training job. Now we'll deploy the model, and for that I would copy the deploy code, put that in the cell, and execute it. So it says parameter image will be renamed to image URI and using already existing model. So XGBoost was deployed already. If you have not done that, if you're doing it the first time, so it will initiate another XGBoost instance. So where you can find your XGBoost endpoints created, you just have to scroll down, and here under the inference, click on the endpoints, and you should find the XGBoost endpoints defined here. So here you can see that today I have created one XGBoost endpoint, and that is now in process of creating. So just refresh it. So it is still created. It is going to take some time to get that in service. Now our endpoint is in service state, so now we can use it. So going forward with the next steps, we'll try to predict whether the customer in the test data enroll for the bank product or not. For that, we are going to copy this code, put that in the Jupyter cell function, and execute it. So here it gives you the output that it has actually evaluated, and the same output we got in the screenshot of the demo as well. Now we are going to evaluate the model performance. So what we are going to do, we are going to get the prediction done. So based on the prediction, we can conclude that you predicted a customer that will enroll for a certificate of deposit accurately for 90% of the customers in the test data, with a precision of 65% for enrolled and 90% which haven't enrolled for it. So for that, we are going to copy this code and execute it here in the cell. So if it is predicted correctly, that means our model is working absolutely fine. So here you can say the overall classification rate is 89.5%, and there is the accurate prediction that has been made by the model. And that's what the output we can see here in the screenshot of a model. So that means our model is absolutely working fine. It has been built, deployed, and trained correctly. Now the next thing is that once you are done with that, you terminate your resources, and for that you just have to copy this code and put that in the cell function, so that the additional resources and the endpoints and the buckets that have been created by the Jupyter Notepad should be terminated, so that you would not be incurred with the extra costing. So just execute it, and here you would see that it would try to terminate all the additional resources that we have created from the Jupyter Notebook. Let's look into what we have in the CloudFront. So what's in it for you? We would be covering up the concept of what is AWS, what was earlier before AWS CloudFront, after AWS CloudFront, what were the services that were introduced, how it benefited, what do we mean by AWS CloudFront, benefits of the using AWS CloudFront, and how AWS CloudFront actually is known as a content delivery service, the name of the companies that are using AWS CloudFront, and we would be covering up one live demo. Now, AWS is the Amazon Web Services. It's a cloud service provider that basically offers a multiple services, variety of services, such as compute power, database storage, networking, and other resources, so that you can create your solutions on the cloud and help the business grow. Now, with AWS, you only pay for whatever the services you use. So for example, if you're using a service for a couple of hours, then you pay for only that many hours that you have used that service. Before AWS CloudFront, so there is an example that we are going to talk, and that is you must be aware of an application called Spotify. So when you used to access Spotify, and when you click on it, it kept on loading, and at the end you used to get the error, and the error was that the connection failed. And why you received that error? Because of a latency issue, probably a network error. right? So how you can solve these kind of a latency issues, and that is also going to, these kind of an issues are also going to impact the performance of an application. So with the introduction of AWS CloudFront, this problem of loading the application got resolved. So after AWS CloudFront, with the help of AWS CloudFront, Spotify gives the facility of updating new features, access to million songs that you can access instantly. So with the use of AWS CloudFront, the latency issues were solved and successfully you can basically access your application. Now, what we mean by AWS CloudFront? So AWS CloudFront is a globally distributed network that is offered by AWS, Amazon Web Services, which securely delivers content to the end users across any geography with a higher transfer speed and an improved or a low latency. Now, what are the benefits of AWS CloudFront? There are multiple benefits. One is the cost effective. So it helps you to do the cost optimization when you use the CloudFront. It is time saving. So it is implemented easily, and also a lot of issues with respect to accessing the application with respect to latency and all can be resolved. Content privacy. So the content is placed to the end users and also to the CloudFront servers in a secured manner, in a secured way. It is highly programmable and you can make the changes, amend the changes on the fly, and you can target any location, any geography across the globe. Along with that, it helps you to get the content deliver quickly. Now, how AWS CloudFront delivers the content? Let's look into the architecture. So this is a flow, and the flow is with respect to how the user is going to get a content from the CloudFront. Now, the client first access a website by typing a URL on the browser, and in the step 1 it tries to access the application. Then the client requests, when the website is open, the client requests for an object to download, such as, for example, a particular file. Now at that time the DNS routes user request to download that file to AWS CloudFront. The AWS CloudFront connects to the nearest edge locations. Edge locations are basically the servers where it caches the files, documents, and the web codes. AWS CloudFront connects to its nearest edge location in order to serve the user the request. At edge location, AWS CloudFront looks for its requested cache file. Once the file is found, let's say if the file is available in the cache of an edge location, AWS CloudFront then sends the file to the user. Otherwise, if the file is not found in the cache memory of an edge location, AWS CloudFront compares the requirement with the specification and share it with a respected server. That means a web server or a server where the file is actually available. The web server responds to the edge location by sending the file back to the CloudFront edge location. And then as soon as the AWS CloudFront receives the file, it shares with the client, also adds the file to the cache of an edge location for a future reference. This is how the flow of a CloudFront is. Now, the name of the companies that are using the AWS CloudFront. So one of them is Geo7 app, which is a very popular app. So it uses Amazon CloudFront to deliver 15 petabytes of audio and video to its subscribers globally, which is a huge data. Sky News, it uses the service in order to unify the content for faster distribution to subscribers. The Discovery Communications also uses the CloudFront. It uses the service for delivering API, static asset, and also the dynamic content. And then the TV1 EU, Streaming Europe, is basically also uses the CloudFront service that helps in improving latency and performance that results in fastest delivery of content. Now let's look into the demo how to use CloudFront to serve private S3 bucket as a website. Now I'm going to run a CloudFront distribution demo on the AWS console, and we'll basically try to deliver the content from a private S3 bucket and then map that with the domain name using the Route 53 service. So what we need for this demo, we would need a domain URL, we would need Route 53 service, we would need CloudFront. We have to create a CloudFront distribution, and that will be linked with our S3 bucket, the private S3 bucket, right? And in the S3 bucket, we would have one HTML file, the index.html file. So let's move into AWS console. So right now I have opened up the CloudFront distribution, and here you can see that couple of distributions have already been created. So what I'm going to do, I'm going to create a distribution. Now there are two types of delivery method for your content. One is the web distribution and the other one is RTMP. RTMP stands for real-time audio or video distribution. It's basically used for distribution of a media content or a media file which are available in the S3 bucket. Here we are going to select a web distribution because primarily we will be using files which uses protocols HTTP or the HTTPS. So you have to click on get started, and in the origin domain name you have to specify the bucket where your code is available. So I have a bucket already created, here you can see, and what you need to do is you have to create a bucket with the URL name or the domain name which you would be mapping with the Route 53 service. So this is a bucket that has already been created. Let me show you in a new tab. So here you have to go to the storage. Under the storage you have to select the S3 bucket. Let's open the link in the new tab and let's look into how we can create the S3 buckets. Now here are a couple of buckets already created. I have created one bucket with the domain name that I'm going to use and map it with the Route 53 service. So that is basically mapped to a region which is in Ohio. And if you open up this bucket, here you will find an HTML web page. The index.html has been already added, right? So similarly, you have to create a bucket with a domain, and an index.html page needs to be uploaded there. Now again we'll go to the CloudFront. We'll try to create a distribution. Just have to click on create distribution, select a web delivery method, select an origin domain which is sunshinelearning.in, and origin path you don't have to specify. Origin ID is this one. So basically when you define an origin domain name, automatically the origin ID appears. You can customize this origin ID as per your requirement also. So rest of the things primarily we keep it as a default settings only until and unless if we require some customized settings to be done. So let's say if you have to change the cache behavior settings, you can do that. Otherwise we'll keep it as default. Now in the distribution setting, you can either select use all edge locations for the best performance. So what does AWS basically do here? It uses all the edge locations which are associated with AWS across the globe. Otherwise you can specify based on the regions also, right? Apart from that, if you want to enable firewalls or the access control list, you can specify here. And then what you need to do is in the default root object, here you have to specify your index.html page which is in the S3 bucket. The distribution state has to be enabled, and if you want to use IP version 6 as well, you need to enable it. Click on create distribution. Now you can see here a distribution has been created. It's in progress and it is enabled, and it takes around 15 to 20 minutes to get that distribution completed. The reason is that the web codes, the web pages will be distributed across all the edge locations across the globe, so hence it takes time to get that done, right? Well, let's move on to Route 53 service, and let's create the hosted zones. So we'll type Route 53 here, scalable DNS and domain name registration. And what we are going to do here is we are going to map our URL, the domains pointed to the name servers that will be provided by the Route 53. So we have to create a hosted zone. Let's wait for it. So now the Route 53 dashboard is open, and you can see one hosted zone is already created. So just click on the hosted zone. And in order to point the traffic from the external domains towards the AWS, you have to first point the domains traffic to the hosted zone in the Route 53. So I'll click on create hosted zone, but before that I will first delete the existing one, and then I'll create another record, another hosted zone. Right. Put your domain name. Let's say I put as sunshinelearning.in, and it is acting as a public hosted zone. Rest of the things will be default. Click on create hosted zone. Now it gives you 4 name servers, and these 4 name servers has to be updated in the domain. So you have to update these name servers in a platform from where you have purchased the domain, right? So this is half of the work done. Then what you need to do is you have to go and create records. Now in the records you can select a routing policy. So right now what we are targeting basically that the traffic from the domain should be pointed directly towards the CloudFront distribution. Hence we are going with a simple routing right now. Click on next. Here you have to specify the record sets. So we are going to create the records. Just click on default simple record. Put here as World Wide Web. And you have to select an endpoint. So endpoint we are selecting for the CloudFront distribution. So we have to specify alias for the CloudFront distribution. Now here we are going to put the CloudFront distribution URL, and then we are going to define the simple record set. So what we need is we need a CloudFront distribution URL, which you can find it from the CloudFront service itself, and you can find the domain name here itself. You just have to copy that and then paste it here in the distribution, and then just click on define simple records. Again click on create records, and here you can see the record set has been updated. Now this domain is basically pointed towards these name servers, which are further pointed towards the CloudFront distribution, right? Now the only thing which is left is that within the domain, from wherever you have purchased the domain, you should update these 4 name servers, and then you can see the live traffic coming on this domain will have an output from the CloudFront distribution. Let's begin with our tutorial, and let's look into what we have in AWS Auto Scaling. So I would be covering up why we require AWS Auto Scaling, what is AWS Auto Scaling, what are the benefits of using the scaling service, how this auto scaling works, the different scaling plans we have, what is the difference between the snapshot and the AMI, what is a load balancer, and how many types of load balancers we have, and along with that I would be covering up a real live demo on the AWS. Let's begin with why we require AWS Auto Scaling. Now before AWS Cloud Scaling, there was a question in the mind of enterprises that they were spending a lot of money on the purchase of the infrastructure. If they have to set up some kind of a solution, so they have to purchase an infrastructure, and a one-time cost was required. So that was a burden for them in terms of procuring a server, hardware, software, and then having a team of experts to manage all those infrastructure. So they used to think that no longer they require these resources if there was a cost-efficient solution for their project. That was the project manager used to think. Now, after the AWS Cloud Scaling that was introduced, automatically the auto scaling maintains the application performance based on the user requirements at the lowest possible price. So what does the auto scaling does is that whenever there is a scalability required, it manages it automatically, and hence the cost optimization became possible. Now, what is AWS Auto Scaling? Let's look into deep. So AWS Auto Scaling is a service that helps users to monitor their applications and the servers and automatically adjust the capacity of their infrastructure to maintain the steadiness. So they can increase the capacity, they can even decrease the capacity also for the cost optimization. And also predictable performance at the lowest possible cost. Now, what are the benefits of auto scaling? It gave the better fault tolerance applications. You can get the servers created and you can have a clone copy of the servers so that you don't have to deploy the applications again and again. Better cost management because the scalability is decided by the AWS automatically based on some threshold parameters. It was a reliable service, and whenever the scaling is created or initiated, you can get the notifications onto your mail IDs or to your cell phones. Scalability, as I mentioned, is always there in the auto scaling. It can scale up, it can scale down as well. And it has the flexibility in terms of whenever you want to schedule it, if you want to stop it, if you want to keep the size of the servers at a fixed number, you can always make the changes on the fly. And the better availability. Now, with the use of the auto scaling, we come around with the terminology called snapshot and the AMI. Let's look into the difference between the snapshots and the AMI. Snapshots versus AMI. So in a company, there was one of the employee that was facing an issue with launching the virtual machines. So he asked his colleague a question. Is it possible to launch multiple virtual machines with a minimum amount of time? Because it takes a lot of time in terms of creating the virtual machines. The other colleague said that yes, it is possible to launch multiple EC2 instances, and that can be done at a lesser time and with the same configuration. And this can be done either you use a snapshot or the AMI on the AWS. Then the colleague said that what are the differences between the snapshot and AMI? Let's look into the difference now. The snapshots basically kind of a backup of a single EBS volume, which is just like a virtual hard drive that is attached to the EC2 instance. Whereas the AMI, it is basically used as a backup of an EC2 instance only. The snapshots opts for this when the instance contains multiple static EBS volumes. When you opt for the snapshot, whenever the instance contains multiple static EBS volumes. AMI, this is widely used to replace the failed EC2 instance. In the snapshots, here you pay only for the storage of the modified data, whereas with the AMI, you pay only for the storage that you use. The snapshots are non-bootable images on EBS volume, whereas AMI are bootable images on the EC2 instance. However, creating an AMI image will also create the EBS snapshots. Now, how does AWS Auto Scaling work? Let's look into it. So for the AWS Auto Scaling to work, you have to configure single unified scaling policy per application resource. And this scaling policy, with that you can explore the applications also. And then select the service you want to scale. Also, for the optimization, select do you want to optimize the cost or do you want to optimize the performance. And then keep track of scaling by monitoring or getting the notifications. Now, what are the different scaling plans we have? So in the auto scaling, a scaling plan basically helps a user to configure a set of instructions for scaling based on the particular software requirement. The scaling strategy basically guides the service of AWS Auto Scaling on how to optimize resources in a particular application. So it's basically kind of the parameters that you set it up so that how the resource optimization can be achieved in the auto scaling. With the scaling strategies, users can create their own strategy based on their required metrics and thresholds, and this can be changed on the fly as well. What are the two types of scaling policies we have? So there are basically dynamic scaling and the predictive scaling. Now, what is dynamic scaling? It basically guides the service of AWS Auto Scaling on how to optimize the resources. And it is helpful in optimizing resources for availability and particular price. Now, with scaling strategies, users can create their plan based on the required metrics and thresholds. So a metric can be like, let's say, a network in, network out, or it can be a CPU utilization, memory utilization likewise. Now, in the predictive scaling, Its objective is to predict future workload based on daily and weekly trends and regular forecast future network traffic. So it is kind of a forecast that happens based on the previous past experiences. It uses a machine learning technique for analyzing that network traffic, and this scaling is like how weather forecast works, right? It provides schedule scaling actions to ensure the resource capacity is available for application requirement. Now, with the auto scaling, you would need the load balancers also, because if there are multiple instances that are created, then you would need a load balancer to distribute the load to those instances. So let's understand what do we mean by a load balancer. A load balancer basically acts as a reverse proxy, and it is responsible for distributing the network or the application traffic across multiple servers. With the help of a load balancer, you can achieve a reliability, you can achieve a fault tolerance of an application. That is basically, it increases the fault tolerance and the reliability. So for example, when there is a high network traffic that is coming to your application, and if that much traffic comes to your application to the instances, your instances may crash. So how you can avoid that situation? So you need to manage the network traffic that is coming to your instances, and that can be done with the load balancer. So thanks to the AWS load balancers, which helps in distributing network traffic across backend servers in a way that it increases performance of an application. Here in the image, you can see the traffic coming from different resources landing onto the EC2 instance, and the load balancer is actually distributing that traffic to all the three instances, hence managing the network traffic quite properly. Now, what are the types of load balancers we have? There are three types of load balancers on the AWS. One is the classic load balancer, second is the application load balancer, and the third one is the network load balancer. Let's look into what we have in the classic load balancer. So the classic load balancer is the most basic form of load balancing, and we call it as a primitive load balancer also, and it is widely used for the EC2 instances. It is based on the IP address and the TCP port, and it routes network traffic between end users as well as in between the backend servers. And it does not support host-based routing, and it results in low efficiency of resources. Let's look into what we have in the application load balancer. This is one of the advanced forms of load balancing. It performs a task on the application level in the OSI model. It is used when there are HTTP and HTTPS traffic routing is required, and also it supports the host-based and path-based routing and performs well with the microservices or the backend applications. The network load balancer performs the task at layer 4 of the connection level in the OSI model. The prime role of the network load balancer is to route the TCP traffic, and it can manage a massive amount of traffic and is also suitable to manage the low latencies. Let's look into the demo and see how practically we can create the auto scaling. Hi guys, let's look into the demo for how we can create an auto scaling on the AWS console. So right now I'm logged in into the AWS console and I am in the Mumbai region. What you need to do is you have to go to the compute section, and under that click on the EC2 service. Let's wait for the EC2 service to come. Now just scroll down, and under the load balancing there is an option called auto scaling. So there first you have to create a launch configuration, and then after that you have to create the auto scaling groups. So click on launch configuration, and then you have to click on create launch configurations. So click on create launch configuration. Now this launch configuration is basically the set of parameters that you define while launching an auto scaling, so that this uniformity is maintained with all the instances. So that includes, let's say if you select a Windows OS or a Linux OS, that particular type of an operating system will be implemented in all the instances that will be part of an auto scaling. So there are certain set of parameters that we have to specify during the launch configuration, so that we can have a uniformity in terms of launching the servers. So here I would select an Amazon Linux AMI, and then I would select the type of a server, which will be t2.micro. Click on configure details, put the name to the launch configuration. Let's say we put it as a demo, and the rest of the things we'll keep it default. Click on add storage. Since it's a Linux AMI, we can go with the 8 GB storage. That should be fine. click on Configure Security Group. Let's create a new security group which has the SSH port open, and that is open for anywhere, which is basically source IPv4 and IPv6 IPs. Any IP will be able to access that. Click on Review. Just review your launch configuration. If you want to make changes, you can do that. Otherwise, click on Create a Launch Configuration. You would need the key pair, and this key pair will be a unique key pair which will be used with all the instances that are part of the auto scaling group. So we can select an existing key pair if you have that. Otherwise, you can create a new key pair. So I have an existing key pair. I'll go with that, acknowledge it, and click on Create Launch Configuration. Now we have successfully launched the configuration of an auto scaling. The next thing is to create an auto scaling group. So click on Create an Auto Scaling Group using this launch configuration. Put a group name. Let's say we put something like test, and the group size to start with, it says one instance, so that means at least a single instance will always be running, and it will be initiated and running 24/7 till the auto scaling is available. You can increase the size of the minimum base instances also. Let's say you can change it to 2 also, so you would get at least 2 servers running all the time. So we'll go with the one instance. The network would be the VPC default, and in the VPC particular region, we can select the availability zones. So let's say if I select availability zone 1A and then availability zone 1B. So how the instances will be launched? So one instance will be launched in 1A, the other one in the 1B, the third one in the 1A, fourth one in the 1B. Likewise, it will be equally spread among the availability zones. Next part is to configure the scaling policies. So click on it. If you want to keep this group at its initial size, let's say if you want to go with only a single instance or 2 instances and you don't want the scaling to progress, you can put it, keep this group at its initial size. So this is basically a way to halt the scaling. But we'll use the scaling policies to adjust the capacity of this group. So click on it. And we would scale between, let's say, minimum 1 instance that we have, and we'll scale it between 1 to 4 instances. And what condition, on what basis these instances will be scaled up or scaled down would be defined in the scale group size. So the scaling policies you can implement based on a scale group size or using the simple scaling policies using the steps. So in the scale group size, you have certain metrics. You can use average CPU utilization. You can define a metric related to average network in, average network out, or the load balancer request counts per target. And if you create the simple scaling policies using steps, then you need to create the alarms, and there you can get some more metrics that you can add up as a parameter for the auto scaling. Let's go with the scaling group size. Let's go with the metric type as average CPU utilization, and the target value here you have to specify what would be the threshold that when the instance CPU utilization is crossed, then a new instance should be initiated. So you can put a reasonable threshold for that. Let's say we put something like 85%, and whenever the instance CPU utilization is crossed 85% threshold, you will see that there will be a new instance created. Let's go to the next configure notifications, and here you can add notifications. So let's say if there is a new instance that is initiated and you want to basically be notified, so you can get notifications over your email IDs, or you can get it on the cell phones. So for that, for adding the notification, you would need the SNS service, and that is called as a simple notification service. And you have to create a topic there. You have to subscribe for the topic using your email ID, and then you should get the notifications. Click on configure tags. The tags are not mandatory. You can basically put a tag. Let's say if you want to identify the instance or purpose it was created. Otherwise, you can leave it blank also. Click on review and review your scaling policies, notification, tags, as well as the scaling group details. Click on create auto scaling group, and here you go. Your scaling has been launched. Click on close, and you should get at least a single instance initiated automatically by the auto scaling. So let's wait for the details to appear. So here you can see our launch configuration name, demo, Auto scaling group name test. Minimum instance we want 1. The maximum instances we want 4. We have selected 2 availability zones, AP South 1A, AP South 1B, and the instance 1 has been initiated. And if you want to verify where exactly this instance has been initiated, just click on the instances here, and here you will see that our single instance has been initiated, that is in service, and that has been initiated in AP South 1B. Now once the threshold of this instance crosses 85%, that is what we have defined in the scaling policies, then you should see that another instance will be initiated. So likewise, this is basically I have created steps to initiate a scaling policy, that means to increase the number of servers whenever the threshold crosses. Likewise, here itself you can add another policy to scale down the resources in case if the CPU utilization goes to a normal value. So let's begin with Amazon Redshift, and let's see what we have for today's session. So what's in it for you today? We'll see what is AWS, why we require Amazon Redshift, what do we mean by Amazon Redshift, the advantages of Amazon Redshift, the architecture of Amazon Redshift, some of the additional concepts associated with the Redshift, and the companies that are using the Amazon Redshift. And finally, we'll cover up one demo which will show you the practical example that how you can actually use the Redshift service. Now, what is AWS? As we know that AWS stands for Amazon Web Service. It's one of the largest cloud providers in the market, and it's basically a secure cloud service platform provided from the Amazon. Also, on the AWS, you can create and deploy the applications using the AWS service. Along with that, you can access the services provided by the AWS over the public network, that is over the internet. They are accessible. Plus, you pay only whatever the service you use for. Now let's understand why we require Amazon Redshift. So earlier, before Amazon Redshift, what used to happen that the people used to, or the developers used to fetch the data from the data warehouse. So data warehouse is basically a terminology which is basically represents the collection of the data. So a repository where the data is stored is generally called as a data warehouse. Now, fetching data from the data warehouse was a complicated task because might be a possibility that the developer is located at a different geography and the data warehouse is at a different location, and probably there is not that much network connectivity or some networking challenges, internet connectivity challenges, security challenges might be, and a lot of maintenance was required to manage the data warehouses. So what were the cons of the traditional data warehouse services? It was time consuming to download or get the data from the data warehouse. Maintenance cost was high, and there was the possibility of loss of information in between the downloading of the data, and the data rigidity was an issue. Now, how these problems could overcome, and this was basically solved with the introduction of Amazon Redshift over the cloud platform. Now, we say that Amazon Redshift has solved traditional data warehouse problems that the developers were facing, but how? What is Amazon Redshift actually is? So what is Amazon Redshift? It is one of the services over the AWS, Amazon Web Services, which is called as a data warehouse service. So Amazon Redshift is a cloud-based service or a data warehouse service that is primarily used for collecting and storing the large chunk of data. So it also helps you to get or extract the data, analyze the data using some of the BI tools. So business intelligence tools you can use and get the data from the Redshift and process that. And hence it simplifies the process of handling the large scale data sets. So this is the symbol for the Amazon Redshift over the AWS. Now let's discuss about one of the use case. So DNA is basically a telecommunication company, and they were facing an issue with managing their website and also the Amazon S3 data, which led down to slow process of their applications. Now, how could they overcome this problem? Let's see that. So they overcome this issue by using the Amazon Redshift, and all the company noticed that there was a 52% increase in the application performance. Now, did you know that Amazon Redshift is basically cost less to operate than any other cloud data warehouse service available on the cloud computing platforms? And also the performance of an Amazon Redshift is the fastest data warehouse, we can say that is available as of now. So in both cases, one is that it saves the cost as compared to the traditional data warehouses, and also the performance of this Redshift service or a data warehouse service, the fastest available on the cloud platforms. And more than 15,000 customers presently they are using the Amazon Redshift service. Now let's understand some of the advantages of Amazon Redshift. First of all, as we saw that it is one of the fastest available data warehouse service, so it has the high performance. Second is, it is a low cost service. So you can have a large scale of data warehouse or the databases combined in a data warehouse at a very low cost. So whatever you use, you pay for that only. Scalability. Now, in case if you wanted to increase the nodes of the databases in your Redshift, you can actually increase that based on your requirement, and that is on the fly. So you don't have to wait for the procurement of any kind of a hardware or the infrastructure. It is whenever you require, you can scale up or scale down the resources. So the scalability is again one of the advantage of the Amazon Redshift. Availability, since it's available across multiple availability zones, so it makes this service as a highly available service. Security. So whenever you access Redshift, you create a clusters in the Redshift, and the clusters are created you can define a specific virtual private cloud for your cluster, and you can create your own security groups and attach it to your cluster. So you can design the security parameters based on your requirement, and you can get your data warehouse or the data items in a secured place. Flexibility, and you can remove the clusters, you can create another clusters. If you are deleting a cluster, you can take a snapshot of it and you can move those snapshots to different regions. So that much flexibility is available on the AWS for the service. And the other advantage is that it is basically a very simple way to do a database migration. So if you're planning that you wanted to migrate your databases from the traditional data center over the cloud on the Redshift, it is basically very simple to do a database migration. You can have some of the inbuilt tools available on the AWS, you can connect them with your traditional data center and get that data migrated directly to the Redshift. Now let's understand the architecture of the Amazon Redshift. So architecture of an Amazon Redshift is basically it combines of a cluster, and that we call it as a data warehouse cluster. In this picture, you can see that this is a data warehouse cluster and this is a representation of a Amazon Redshift. So it has some of the compute nodes which does the data processing, and a leader node which gives the instructions to these compute nodes. And also the leader node basically manages the client applications that require the data from the Redshift. So let's understand about the components of the Redshift. The client application of Amazon Redshift basically interact with the leader node using JDBC or the ODBC. Now what is JDBC? It's a Java database connectivity, and the ODBC stands for Open Database Connectivity. The Amazon Redshift service using a JDBC connector can monitor the connections from the other client applications. So the leader node can actually have a check on the client applications using the JDBC connections. Whereas the ODBC allows a leader node to have a direct interaction or to have a live interaction with the Amazon Redshift. So ODBC allows a user to interact with live data of Amazon Redshift. So it has a direct connectivity, direct access of the applications, as well as the leader node can get the information from the compute nodes. Now, what are these compute nodes? These are basically kind of a databases which does the processing. So Amazon Redshift has a set of computing resources which we call it as a nodes, and the nodes, when they are combined together, they are called it as a clusters. Now a cluster, a set of computing resources which are called as nodes, and this gathers into a group which we call it as a data warehouse cluster. So you can have a compute node starting from 1 to n number of nodes, and that's why we call that the Redshift is a scalable service, because we can scale up the compute nodes whenever we require. Now the data warehouse cluster, or each cluster, has one or more databases in the form of a nodes. Now what is a leader node? This node basically manages the interaction between the client application and the compute node. So it acts as a bridge between the client application and the compute nodes. Also, it analyzes and develops designs in order to carry out any kind of a database operations. So leader node basically sends out the instructions to the compute nodes, basically perform or execute that instruction and give that output to the leader node. So that is what we are going to see in the next slide, that the leader node runs the program and assign the code to individual compute nodes. And the compute nodes execute the program and share the result back to the leader node for the final aggregation. And then it is delivered to the client application for analytics or whatever the client application is created for. So compute nodes are basically categorized into slices, and each node slice is allotted with specific memory space, or you can say a storage space, where the data is processed. These node slices works in parallel in order to finish their work, and hence when we talk about a Redshift as a faster processing capability as compared to other data warehouses or traditional data warehouses, this is because that these node slices work in a parallel operation that makes it more faster. Now, the additional concept associated with Amazon Redshift is there are two additional concepts associated with the Redshift. One is called as the column storage and the other one is called as the compression. Let's see what is the column storage. As the name suggests, column storage is basically kind of a data storage in the form of a column, so that whenever we run a query, it becomes easier to pull out the data from the columns. So column storage is an essential factor in optimizing query performance and resulting in quicker output. So one of the examples are mentioned here. So below examples show how database tables store record into disk block by row. So here you can see that if we wanted to pull out some kind of an information based on the city, address, age, we can basically create a filter, and from there we can put out the details that we require, and that is going to fetch out the details based on the column storage. So that makes data more structured, more streamlined, and it becomes very easier to run a query and get that output. Now the compression is basically to save the column storage, we can use a compression as an attribute. So compression is a column level operation which decreases the storage requirement, and hence it improves the query performance. And this is one of the syntax for the column compression. Now the companies that are using Amazon Redshift, one is LYA, the other one is Equinox, the third one is the Pfizer, which is one of the famous pharmaceuticals company, McDonald's, one of the burger chains across the globe, and Philips, it's an electronic company. So these are one of the biggest companies that are basically relying and they are putting their data on the Redshift data warehouse service. Now in another video, we'll see the demo for using the Amazon Redshift. Let's look into the Amazon Redshift demo. So these are the steps that we need to follow for creating the Amazon Redshift cluster. And in this demo, what we'll be doing is that we'll be creating an IAM role for the Redshift so that the Redshift can call the services, and specifically we'll be using the S3 service. So the role that we'll be creating, we'll be giving the permission to Redshift to have an access of an S3 in the read-only format. So in the step one, what we require, we'll check the prerequisites, and what you need to have is the AWS credentials. If you don't have that, you need to create your own credentials, and you can use your credit and the debit card. And then in the step two, we'll proceed with the IAM role for the Amazon Redshift. Once the role is created, we'll launch a sample Amazon Redshift cluster mentioned in the step 3, and then we'll assign a VPC security groups to our cluster. Now you can create it in the default VPC also, you can create a default security groups also, otherwise you can customize the security groups based on your requirement. Now to connect to the sample cluster, you need to run the queries, and you can connect to your cluster and run queries on the AWS Management Console query editor, which you will find it in the Redshift only. Or if you use the query editor, you don't have to download and set up a SQL client application separately. And in the step 6, what you can do is you can copy the data from the S3 and upload that in the Redshift, because the Redshift would have an access, a read-only access for the S3, as that will be created in the IAM role. So let's see how we can actually use the Redshift on the AWS. So I am already logged into my account. I am in North Virginia region. I'll search for Redshift service, and here I find Amazon Redshift. So just click on it. Let's wait for the Redshift to come. Now this is a Redshift dashboard, and from here itself you have to run the cluster. So to launch a cluster, you just have to click on this launch cluster, and once the cluster is created, and if you wanted to run queries, you can open query editor, or you can basically create queries and access the data from the Redshift. So that's what it was mentioned in the steps also, that you don't require a separate SQL client application to get the queries run on the data warehouse. Now, before creating a cluster, we need to create the role. So what we'll do is we'll click on the services and we'll move to IAM role section. So IAM role I can find here under the security, identity and compliance. So just click on the identity access management and then click on create roles. So let's wait for IAM page to open. So here in the IAM dashboard, you just have to click on the roles. I already have the role created. So what I'll do is I'll delete this role and I'll create it separately. So just click on a create role, and under the AWS services, you have to select for the Redshift, because now the Redshift will be calling the other services, and that's why we are creating the role. Now, which other services that the Redshift will be having an access of? S3. Why? Because we'll be putting up the data on the S3, and that is something which needs to be uploaded on the Redshift. So we'll just search for the Redshift service, and we can find it here. So just click on it and then click on Redshift customizable in the use case. Now click on next permissions, and here in the permissions, give the access to this role, assign the permissions to this role in the form of an S3 read-only access. So you can search here for the S3 also. Let's wait for the policies to come in. Here it is. Let's type S3. And here we can find Amazon S3 read-only access. So just click on it and assign the permissions to this role. Tags, you can leave them blank. Click on next review. Put a name to your role. Let's put my Redshift role and click on a create role. Now you can see that your role has been created. Now the next step is that we'll move to Redshift service and we'll create one cluster. So click on the services. Click on Amazon Redshift. You can find that in the history section since we browsed it just now. And from here, we are going to create a sample cluster. Now to launch a cluster, you just have to click on launch this cluster. Whatever the uncompressed data size you want in the form of a gigabyte, terabyte or petabyte, you can select that. And let's say if you select in the form of GB, how much GB memory you want, you can define it here itself. This also gives you the information about the costing. On demand is basically pay as you use. So they are going to charge you $0.5 per hour for using the 2 node slices. So let's click on launch this cluster, and this will be a DC2.large kind of an instance that will be given to you. It would be in the form of a solid state drive, SSDs, which is one of the fastest way of storing the information. And the nodes 2 are mentioned by default. That means there will be 2 node slices that will be created in a cluster. You can increase them also. Let's say if I put 3 node slices, so it is going to give us 3 into 0.16 TB per node storage. Now here you have to define the master username password for your Redshift cluster, and you have to follow the password instructions. So I would put a password to this cluster, and if it accepts, that means it does not give you any kind of a warning. Otherwise it is going to tell you about you have to use the ASCII characters and all. And here you have to assign this cluster the role that we created recently. So in the available IAM roles, you just have to click on my Redshift role, and then you have to launch the cluster. If you wanted to change something in with respect to the default settings, let's say if you wanted to change the VPC from default VPC to your custom VPC, and you wanted to change the default security groups to your own security groups, so you can switch to advanced settings and do that modification. Now let's launch the cluster, and here you can see the Redshift cluster is being created. Now if you wanted to run queries on this Redshift cluster, so you don't require a separate SQL client, you just have to follow the simple steps to run a query editor, and the query editor you will find it on the dashboard. So let's click on the cluster, and here you would see that the Redshift cluster would be created with the 3 nodes in the US East 1B availability zone. So we have created the Redshift cluster in the Ohio region, and now what we'll do is we'll see how we can create the tables inside the Redshift, and we'll see how we can use the copy command so that we can directly move the data uploaded on the S3 bucket to the Redshift database tables. And then we'll query the results of a table as well. So how we can do that? First of all, after creating the Redshift cluster, we have to install SQL Workbench /J. This is not a MySQL, which is managed by Oracle, and you can find this on the Google. You can download it from there. And then you have to connect this client with the Redshift database. How you can do? Click on File, click on Connect Window, and after connecting a window, you have to paste the URL, which is a JDBC driver. This driver link, you can find it onto the AWS console. So if you open up a Redshift cluster, there you would find the JDBC driver link. Let's wait for it. So this is our cluster created. Let's open it, and here you can find this JDBC URL. And also make sure that in the security groups of a Redshift, you have the port 5439 open for the traffic, incoming traffic. You also need to have the Amazon Redshift driver, and This is the link where you can download the driver and specify the path. Once you are done with that, you provide the username and the password that you created while creating the Redshift cluster. Click on OK. So this connects with the database, and now the database connection is almost completed. Now what we will be doing in the SQL workbench, we'll be first creating the sales table, and then in the sales table we'll be adding up the entries copied from the S3 bucket and then move it to the Redshift database, and after that we'll query the results in the sales table. Now whatever the values you are creating in the table, the same values needs to be in the data file, and I have taken up this sample data file from this link, which is docs.aws.amazon.com Redshift sample database creation, and here you can find a download file ticketdb.zip file. This folder has basically multiple data files, sample data files, which you can actually use it to practice uploading the data on the Redshift cluster. So I have extracted one of the files from this folder, and then I have uploaded that file in the S3 bucket. Now we'll move into the S3 bucket. Let's look for the file that has been uploaded on the S3 bucket. So this is the bucket sample, and sales_tab.txt is the file that I have uploaded. This has the entries, data entries that will be uploaded using a copy command onto the Redshift cluster. Now after putting up the command for creating up the table, then we'll use a copy command, and copy command we have to define the table name. The table name is sales, and we have to define the path from where the data would be copied over to the sales table in the Redshift. Now path is the S3 bucket, and this is the Redshift bucket sample, and it has to look for the data inside the sales_tab.txt file. Also we have to define the role ARN that was created previously, and once it is done, then the third step is to query the results inside the sales table to check whether our data has been uploaded correctly on the table or not. Now what we'll do is we'll execute all these three syntax. It gives us the error because we have to connect it again to the database. Let's wait for it. Execute it. It again gives us the error. Let's look into the name of the bucket. It's Redshift bucket sample. So we have two T's mentioned here. Right. Let's connect with the database again and now execute it. So table sales created, and we got the error. The specified bucket does not exist. Redshift bucket sample. Let's view the bucket name, Redshift bucket sample. Let's copy that, put it here, connect to the window, connect back to the database. Right, and now execute it. So table sales created. The data in the table has been copied from the S3 bucket to sales_tab.txt to the Redshift, and then the query of the results. The results from the table has been queried.
In this section, you'll learn what elastic load balancing is. Elastic load balancing automatically distributes incoming application traffic across multiple Amazon EC2 instances. It enables you to achieve increased levels of fault tolerance for your applications by seamlessly providing the required amount of load balancing capacity needed to distribute the application traffic. You can distribute incoming traffic across your EC2 instances in a single availability zone or multiple availability zones. Elastic load balancing automatically scales its request handling capacity in response to incoming traffic. Elastic load balancing can also detect the health of your Amazon EC2 instances. When it detects an unhealthy instance, it will spread the load across the remaining instances and no longer route traffic to the unhealthy instance. When you're using VPC, you can create and manage security groups associated with elastic load balancing to provide additional networking and security options. You can also create a load balancer without a public IP address, so it serves as an internal, i.e. non-internet facing, load balancer. Elastic load balancing also supports the ability to stick user sessions to specific EC2 instances using cookies. And if you remember from lesson 2 when we talked about session affinity, this is a version of that. In this demonstration, we're going to create a load balancer for our Simplilearn web servers. So to do that, we'll go to the Compute EC2 section. And I want to show you that before we can configure load balancing, there's a couple of things we need to do. So if we go to load balancers on the left-hand side, and then click on Create Load Balancer. So we want to create the load balancer inside Simplilearn VPC. Now I want to show you this warning that comes up. It says please select at least 2 subnets in different availability zones to provide high availability for your load balancer. And you could think, well, that's great, we have 2 subnets. We have a public subnet and a private subnet, and they're both in different availability zones. So if we add them both, we get another warning. It says this is an internet-facing elastic load balancer, but there is no internet gateway attached to the subnet you've just selected. So obviously our private gateway, private subnet, only has a NAT gateway to provide its internet access, so it's not a public internet-facing subnet. So what that means is we need to create a new public subnet in a different availability zone for our load balancer. So we already have this one, public, in US East 1B. We're going to create a public subnet in US East 1C as well. So to do that, let's go back to the networking VPC section, and this is going to be a quick review of the VPC lesson. So we'll go to subnets, we'll sort by VPC. So here are our 2 existing subnets. So we'll create a new subnet, and we're going to call it, let me just paste what I copied, we're going to call it 10.0.3.0 US East 1C Simplilearn Pub. And we're going to put it in our Simplilearn VPC, and we want to put it in the US East 1C availability zone, so it's different to our existing public subnet. And we're going to put it in that CIDR block. So let's click Create. So there we are. Now we have 3 subnets in our Simplilearn VPC, 2 of them are public. Now, if you remember, when you create a new subnet, it will get attached to your default route table by default. So that's no good because our default route table doesn't have internet access. So we need to go to route tables. We click on our main default route table and have a look at subnet associations. We can see that our new subnet is in here. So we need to move it into our custom route table, so it will be the same as our existing public subnet. So if we click on Edit, we just tick the box next to our new public subnet and click Save. So now our new public subnet is in this route table, so it has internet access. So now we're good to go. So let's go back to the EC2 section, and we want to launch a new web server into this new public subnet. So we'll go to, well, we'll launch it from our AMI because we've already configured our web servers as an AMI. So we'll click Launch. We'll choose T2 Nano. We'll configure our instance details. So we're going to place it in the Simplilearn VPC. We're going to place it in our new public subnet in the US East 1C availability zone. We're going to enable a public IP. We're going to give it the administrator IAM role, and we're going to protect against accidental termination. The storage is fine. We're going to tag this one as Simplilearn Web Server 3. We'll configure the security group, so we'll put it in an existing group, which will be the web servers group, and we'll launch it using our existing Simplilearn key pair, which I have possession of. Okay, so that's launching. So we can see our Simplilearn web servers. So there we are, we've got 3 of them. We've got 1, 2 which are already up and running, and number 3 which is coming online. So now we're ready to create our load balancing. So let's go to load balancers again and create load balancer. We want to put it in our VPC and we'll give it a name. So this is the kind of internal name. We can tag it differently later on because you can't put any underscores or hyphens in this section. So we'll call it Simplilearn LB, Simplilearn VPC. If we wanted to create an internal load balancer, so it was balancing traffic that was just internal to our AWS VPC, we could tick this box. Here's the listener configuration. So what we can do here is we're saying that any HTTP traffic that comes in on port 80 to the load balancer is being pushed to port HTTP 80 on our instances. So what we could do is you could change this. You could have a different port for the load balancer and it maps it to your web servers. You could protect your web servers, but we're just going to leave it as it is. Now we want to add the subnets, so we're going to add both of our public subnets, and that warning's now gone, so now we're good. We have 2 subnets in 2 availability zones. Next we assign security groups. So we could just use our existing web server security group because that has HTTP port 80 open. It also has HTTPS open and SSH. So it's probably good practice to create a new security group just for our load balancer. So we'll call it Simplilearn Load Balancer SG. And we're simply going to have HTTP port 80 open from anywhere and nothing else. And we should probably just give it a quick description so we know what it is. Security group for load balancing. Okay, so let's click Next, Configure Security Settings. And it's just telling us that our load balance security isn't using a secure listener because we're not using HTTPS or SSL, which is fine for this demonstration. Next we configure the health check. So this is the check that the load balancer is going to perform to see if our instances are healthy. So it's using HTTP port 80 and it's going to look for existence of a file. So we're going to tell it to look for our healthcheck.html file. And if that doesn't exist, then the instance isn't healthy. Now we can configure some more details. So the response timeout is 5 seconds. We'll leave that. The interval between checks, the default value is 30. So let's bring that down because we want things to happen quicker. So that's 10 seconds. Unhealthy threshold is set to 2. So if it has 2 checks where it doesn't find the file, it's going to determine that the instance is unhealthy. And the healthy threshold is 10. We're also going to bring that down. We'll bring that down to 3. So after 3 consecutive healthy checks, it will say the instance is healthy. Okay, so now we can add our EC2 instances. So we'll add our 3 web servers. We've enabled cross-zone load balancing, so it can push traffic across both availability zones. And the connection draining setting we'll just leave as default. That's when it detects an unhealthy instance, that's how long before it will start redirecting traffic elsewhere. So next we'll click on Add Tags, so we can give this a more meaningful name. Simplilearn _ load balancer, and review and create. Okay, so we can review everything we did. We should be okay, so let's click create, and our load balancer is now being created. So let's have a look. So here it is. We click on instances, you can see the instances, and it's saying they're all out of service at the moment. So that's because it's just configuring itself and it will take a while to come up. So I'm going to pause the demonstration and we'll come back when everything's up and running. Okay, so the load balancer has configured, and you can see that 2 of our 3 web servers are in service, but our 3rd web server is out of service. So why do you think this is? Well, I'll tell you why. It's because our new web server, Simplilearn Web Server 3, has just come up and we haven't done anything to it other than just launch the AMI. So let's go and check out what's going on the instance. So I've opened sessions to our 3 web servers here, and this is the new one, and it's because the Apache service isn't started by default. So we need to start the Apache service. Okay, so we get that weird error, but it tells me it's okay. So if we now go back to the load balancer and we wait a few seconds, we should see the Simplilearn web server number 3 come online. There you are, so now we're online. So it was as simple as just starting the service. So that shows how load balancing works.
Today, I'm joined by 2 giants of the cloud computing industry. They'll be going head to head with each other to decide who amongst them is better. It's going to be one hell of a fight. Now, let's meet our candidates. On my left, we have AWS, who's voiced by Apeksha.
Hi guys.
And on my right, we have Microsoft Azure, who's voiced by Anjali.
Hey there.
So today, we'll be deciding who's better on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, free tier, and instance configuration. Now, let's listen to their opening statements. Let's start with AWS.
Launched in 2006, AWS is one of the most commonly used cloud computing platforms across the world. Companies like Adobe, Netflix, Airbnb, HTC, Pinterest, and Spotify have put their faith in AWS for their proper functioning. It also dominates the cloud computing domain with almost 40% of the entire market share. So far, nobody's even gotten close to beating that number. AWS also provides a wide range of services that covers a great number of domains. Domains like compute, networking, storage, migration, and so much more.
Now, let's see what Azure has to say about that.
Azure was launched in 2010 and is trusted by almost 80% of all Fortune 500 companies. The best of the best companies in the world choose to work only with Azure. Azure also provides its services to more regions than any other cloud service provider in the world. Azure covers 42 regions already, and 12 more are being planned to be made. Azure also provides more than 100 services spanning a variety of domains.
Now that the opening statements are done, let's have a look at the current market status of each of our competitors. This is the performance round. Here we have the stats for the market share of AWS, Azure, and other cloud service providers. This is for the early 2018 period. Amazon Web Services takes up a whopping 40% of the market share, closely followed by Azure at 30% and other cloud services adding 30%.
This 40% indicates most organizations' clear interest in using AWS. We are number one because of our years of experience and trust we've created among our users.
Sure, you're the market leader, but we are not very far behind. Let me remind you, more than 80% of the Fortune 500 companies trust Azure with their cloud computing needs. So it's only a matter of time before Azure takes the lead.
The rest of the 30% that is in AWS or Azure accounts to the other cloud service providers like Google Cloud Platform, Rackspace, IBM SoftLayer, and so on. Now for our next round, the comparison round. First, we'll be comparing pricing. We'll be looking at the cost of a very basic instance, which is a virtual machine of 2 virtual CPUs and 8 GBs of RAM. For AWS, this will cost you approximately $0.0928 per hour. And for the same instance in Azure, it'll cost you approximately $0.096 per hour. Next up, let's compare market share and options.
As I mentioned before, AWS is the undisputed market leader when it comes to the cloud computing domain, taking up 40% of the market share. By 2020, AWS is also expected to produce twice its current revenue, which comes close to $44 billion. Not to mention, AWS is constantly expanding its already strong roster of more than 100 services to fulfill the shifting business requirements of organizations.
All that is great, really, good for you. But the research company Gartner has released a magic quadrant that you have to see. You see, the competition is now neck to neck between Azure and AWS. It's only a matter of time before Azure can increase from its 30% market share and surpass AWS. This becomes more likely considering how all companies are migrating from AWS to Azure to help satisfy their business needs. Azure is not far behind AWS when this comes to services as well. Azure's service offerings are constantly updated and improved on to help users satisfy their cloud computing requirements.
Now, let's compare AWS and Azure's free offerings.
AWS provides a significant number of its services for free, helping users get hands-on experience with the platform, products, and services. The free tier services fall under 2 categories: services that will remain free forever and the others that are valid only for 1 year. The always free category offers more than 20 services, for example Amazon SNS, SQS, CloudWatch, etc. And the valid for a year category offers approximately 20 services, for example Amazon S3, EC2, Elasticache, etc. Both types of services have limits on their usage, for example storage, number of requests, compute time, etc. But users are only charged for using services that fall under the valid for a year category after a year of their usage.
Azure provides a free tier as well. It also provides services that belong to the categories of free for a year and always free. There are about 25 plus always free services provided by Azure. These include App Service, Functions, Container Service, Active Directory, and lots more. And as of the valid for a year, there are 8 services offered. There's Linux or Windows virtual machines, blob storage, SQL database, and few more. Azure also provides the users with credits of $200 to access all their services for 30 days. Now this is a unique feature that Azure provides, where its users can use their credits to utilize any service of a choice for the entire month.
Now let's compare instance configuration. The largest instance that AWS offers is that of a whopping 256 GBs of RAM and 16 virtual CPUs. The largest that Azure offers isn't very far behind either, 224 GBs of RAM and 16 virtual CPUs. And now for the final round. Now each of our contestants will be shown facts and they have to give explanations for these facts. We call it the rapid fire round. First, we have features in which AWS is good and Azure is better.
AWS does not cut down on the features it offers its users. However, it requires slightly more management on the user's part.
Azure goes slightly deeper with the services that fall under certain categories like platform as a service and infrastructure as a service.
Next, we have hybrid cloud, where AWS is good and Azure is better.
Okay, although AWS did not emphasize on hybrid cloud earlier, they are focusing more on technology now.
Azure has always emphasized on hybrid cloud and has features supporting it since the days of its inception.
For developers, AWS is better and Azure is good.
Of course it's better, because AWS supports integration with third-party applications.
Well, Azure provides access to data centers that provide a scalable architecture.
For pricing, both AWS and Azure are at the same level.
It's good for AWS because it provides a competitive and constantly decreasing pricing model.
And in the case of Azure, it provides offers that are constantly experimented upon to provide its users with the best experience.
And that's it. Our contestants have finished giving their statements. Now, let's see who won. Surprisingly, nobody. Each cloud computing platform has its own pros and cons. Choosing the right one is based entirely on your organization's requirements. We're going to talk about the best cloud computing platform available, Amazon Web Services.
Rahul, I think you said something wrong here. The best cloud computing platform is obviously Google Cloud Platform.
No, it isn't. AWS has more than 100 services that span a variety of domains.
Alright, but Google Cloud Platform has cheaper instances. What do you have to say about that?
Well, I guess there's only one place we can actually discuss this. A boxing ring.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Hi guys, this is Rahul from Simplilearn, and today we'll be talking about one of the fastest growing and second largest cloud computing platform in the market right now. I'm talking about Microsoft Azure. Now before we begin, let's talk about what we'll be covering in this video. First, we'll talk about why you should be interested in cloud computing, what exactly is cloud computing, what is Microsoft Azure, some of its services, and the uses of Azure. Now, let's start with why you should be interested in cloud computing. Now, let's say you have an idea for a revolutionary application, an idea that ticks both the boxes when it comes to good applications. One, it has great user experience, and two, it'll be highly profitable. Now, for it to be successful, you'll have to release it on the internet. People need to use it, they need to spread the word, and then it'll become truly famous. However, for that, you're going to need servers, storage, developers, a dedicated network, and application security to ensure your application works the way it does. Now, these are a lot of components, and that's where the problem lies. There are two major disadvantages to this approach. The initial setup is very expensive and risky, which means this requires a huge amount of capital upfront to ensure that it works properly. And the downside is, if your application does not become famous or it doesn't return as much as you expect it to, you're probably not going to get the money back, which means it provides a huge amount of risk. And then, on the flip side, if it does become famous, your number of users have increased, which means that you'll have to buy more servers and storage systems to keep up with your demand. And this problem can be solved with the help of cloud computing. Now that you know why you should be interested in cloud computing, let's go into the details of what exactly is cloud computing. Now, cloud computing is basically a platform that gives you access to a number of computing resources. And this is possible with the help of the internet. Now, as a user, all you need to do is go to a cloud service provider through your laptop or your computer, through the internet, of course, connect to that cloud service provider, and then there you go. You have access to computing resources. Now, computing resources may include, serverless computing, virtual machines, storage, and so much more. Now, let's dig a little deeper. Now, basically, these cloud service providers actually have massive data centers. Now, in these data centers, what you have are hundreds of servers. Also included are storage systems and mainly several organizations' critical components. So these are very secure, safe locations where a large amount of data is stored, hence the name data centers. Now, it is to these data centers that users actually connect to collect their data or use it. So actually, users can access any service based on their requirement. Now, like I told you, there's a number of services the user can use. For example, now if you want a notification every time someone sends you a message, or perhaps once you get an email, you need a copy of it created. Now, for all of this, there are services. And most importantly, almost every cloud service provider has this option where users only pay for the service that they use. So there's no charge upfront where they tell you that you need to pay X amount of money so that you can use our services. You're only paying for the amount of time that you're using these services. Now, cloud computing is used for a wide variety of reasons. Firstly, there's machine learning and data analysis. Now, basically, there are services that analyze your data and tell you how you can work with this data better. Then there's data storage and backup, streaming media content. For example, did you know that the shows that you watch on Netflix, actually all of them are in the cloud. So you're connected to the internet and you browse through Netflix and you get access to the videos. These are possible with the help of cloud service providers. There's creating and testing applications, automating software delivery, which is a component in DevOps, and hosting blogs and applications. So now, what is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now, it's basically an online portal through which you can access and manage resources and services. Now, resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched on February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure Services. Now, Azure Services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have ExpressRoute. Now with this, you can actually connect your on-premise network onto the Microsoft cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have virtual network. Now with virtual network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development. It could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices. For example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines where these services are able to provide you a large amount of storage where data can be stored.
I'm Sam, an Azure Cloud Architect working for Simplilearn. And I'm more than glad to walk you through this session where we're going to talk about Azure in great length and breadth. And without any further delay, let's get started. Everybody likes stories, so let's get started with a story. In a city not so far away, a CEO had plans to expand his company globally and called one of his IT personnel for an IT opinion. And this guy has been in the company for a long time and is very seasoned with the company's infra, and he nicely answered the questions with what he foresaw. And he said, I have a good news and a bad news for us to go global. And he starts with the good news. He said, Sir, we're well on our way to become one of the world's largest shipping company. And the bad news is, however, our data centers have almost run out of space, and setting up new ones around the world would be too expensive and very time consuming. Now the IT personnel, let's call him Mike, now he explains the situation from how he saw it. But the CEO had done some homework about how he was going to do it, and he answered Mike saying, don't worry about that, Mike. I've come up with a solution for a problem, and it's called Microsoft Azure. Well, Mike is an hard-working and honest IT professional working for that company, but he did not spend time on learning the latest technologies. And he asked this question very honestly, oh, how does it solve a problem? And the CEO begins to explain Azure to Mike, and he starts with what is cloud computing, and then he goes on and talks about Azure and the services offered by Azure and why Azure is better than the other cloud providers, and what are the great companies that uses Azure and how they got benefited out of it. And then he winds it all up with the use cases of Azure. So he begins his explanation saying Microsoft Azure is known as the cloud service provider, and it works on the basis of cloud computing. Now, Microsoft Azure is formerly known as Windows Azure, and it's Microsoft's public cloud computing platform. It also provides a range of cloud services, including some of them are compute, analytics, storage, and networking. We can always pick and choose from these services to develop and scale our applications, or even plan on running existing applications in the public cloud. Microsoft Azure is both a platform as a service and infrastructure as a service. Let's now fade their conversation out and let's talk about what is cloud computing, Azure, services offered by Azure, how is Azure leading when compared to other cloud service providers, and what are the companies that are using Azure. Let's talk about that. In simple terms, cloud computing is being able to access compute services like servers, storage, database, networking, software analytics, intelligence, and a lot more over the internet, which is the cloud, with the flexibility of the resources that we use. Like anytime I want a resource, I can use one and it becomes available immediately, and anytime if I want to retire a resource, I can simply retire a resource and not pay for it. And we also typically pay only for the services that we use, and this helps greatly with our operating cost to run our infrastructure more efficiently and scale our environment up or down depending on the business needs and changes. And all the servers and storages and databases and networking, all that are accessed through the network of remote systems or remote computers hosted in the internet, typically in the provider's data center, which is Azure in this case. Now, we don't use any physical server or an on-premises server here. Well, we still use physical servers and VMs, hosted on a hardware or a physical server, but they're all in the provider's environment and none of them sit on premises or in our data center. We only access them remotely. It looks and feels the same, except for the fact that they are in a remote location. We access them remotely, do all the work remotely, and when we're done, we can shut it down and not pay for them. So some of the use cases of cloud computing are creating applications and services. The other use cases are storing or using cloud for storage alone. If there is one thing that ever grows in an organization, is the storage. Every new day there is a new storage requirement, and it's very dynamic. It's very hard to predict, and if we go out and buy a big storage capacity upfront, until we use the storage capacity fully, the empty storages, we're wasting money on them. So instead, I can go for a storage which scales dynamically, that's in the cloud. Put storage or put data in the cloud and pay only for what you're storing. And for the next month, if you have deleted or flushed out some files or data, pay less for it. So it's a very dynamic storage in the cloud, and a lot of companies are getting benefited from storing data in the cloud because of its dynamic in nature and the cost that comes along with it, the cheap cost that comes along with it. And also they give a lot of the providers like Azure, they give data replication for free. They promise an SLA along with the data we store in the cloud. So there's an SLA attached to it. And they also provide data recoveries as well. If in case something goes wrong with the physical disk where our data is stored, Azure automatically makes our data available from the redundant or other places where it had stored our data because of the SLA they wanted to keep. The other use case for Azure is hosting websites and running blogs using the compute service. Be it storing music and letting your users stream the music, Azure is a good place to store music and stream the music with the benefit of CDN, Content Delivery Network, which allows us to stream video or audio files with great speed. With Azure, our audio or video application works seamlessly because they are provided to the client with very low latency, and that improves the customer experience for our application. Azure Compute Service is a good place for delivering software on demand. There are a lot of softwares, embedded softwares that we can buy using Azure, and everything on a pay-as-you-go service model. So anytime we need a software, we can go out and immediately buy the software for the next 1 hour or 2 hours, let's say, and use them and then return it back. We're not bound to any yearly licensing cost by that. Azure Computing Services has analytics available for us with which we can analyze, get a good visualization of what's going on in a network, be it logs, be it the performance, be it the metrics. Instead of looking at logs and searching logs and trying to do manual things over the heaps and heaps of logs that we have saved, Azure Analytics Services helps us to get a good visual of what's going on in the network. Where have we dropped? Where have we increased? Or what's causing? What's the major driver? What is the top 10 errors that we get in the server, in the application? Stuff like that. Those can be easily gathered from the Azure Analytic Services. Now, cloud is really a very cool term for the internet. A good analogy would be looking back anytime we look at a diagram. When we do not know how things are transferred, we simply draw a cloud, right? For example, a mail gets sent from a person in one country to a person in the other country. There are a lot of things happening in between from the time you hit the send button and the time the other person hits the read button, right? And the simple and the easiest way of putting it in a picture is simply draw a cloud, and on the one end, one person will be sending the email, and on the other end, the other person will be reading the email. So a cloud is a really cool term for the internet. Now that's some basics about cloud computing. Now that we've understood about cloud computing in general, let's talk about Microsoft Azure as a cloud service. Now, Microsoft Azure is a set of cloud services to build, manage, and deploy applications on a network with the help of Microsoft Azure's frameworks. Now, Microsoft Azure is a computing service created by Microsoft basically for building, testing, deploying, and managing applications and services through a global network of Microsoft managed data centers. Now, Microsoft Azure provides SaaS, which is software as a service, and PaaS, which is platform as a service, and IaaS, infrastructure as a service, and they support many different programming languages, tools, and framework. And those tools and framework include both Microsoft specific and third-party software. Now let me pick and talk about a specific service. For example, management. Azure Automation provides a way for us to automate the manual, long running and frequently repeated tasks that are commonly performed tasks both in cloud and enterprise environment. It saves us a lot of time and increases the reliability, and it kind of gives a good administrative control and even schedules the task automatically to be performed on a regular basis. To give you a quick history of Microsoft Azure, it was launched on 1st February 2010, and it was awarded, or it was called an industry leader for infrastructure and platform as a service by Gartner. Now, Gartner is the world's leading research and advisory company. This Microsoft Azure supports a number of programming languages like C#, Java, and Python. All these cool services we get to use and pay only for how much we use. For example, if we use for an hour, we only get to pay for an hour, even the costliest system available. If we use them for an hour, we only pay for that particular hour, and then we're done. No more billing on the resource that we have used. Microsoft Azure has spread itself more than 50 regions around the world. So it's quite easy for us to pick a region and start provisioning and running our applications probably from day one. because the infrastructure and the tools and technologies needed to run our application are already available. All that we have to do is commit the code in that particular region or build an application and launch it in that particular region, and they become live starting day one. Now, because we have 50 regions around the world, we can very carefully design our environment to provide low latency services to our customers. All right, instead of in traditional data center, let's say, customers will have to, or their request will have to travel all the way around the globe to reach a data center which lives in the other side of the planet. And this adds more latency to it. And it is really not feasible to build a data center near each customer location because of the cost involved. But with Azure, it's possible. Azure already has data centers around the world, and all that we have to do is just pick a data center, build an environment there. They're available starting day one, number one. And also the cost is considerably saved because we are using a public cloud instead of an physical infrastructure to serve those customers from a very local location. And the services that Azure is offering is ever increasing. As of now, as we speak, we have like 200 plus services offered, and they span through different domain or different platform or different technologies available within the Azure console portal. Now, we're going to talk about that later in this section, so hold your breath till we talk about it. But for now, just know that we have like 200 plus services offered by Azure. Let's now talk about different services in Azure, starting with artificial intelligence plus machine learning, where we have a lot of tools and technologies. So the wide variety of services available in Azure includes artificial intelligence plus machine learning plus analytic services to get to give us a good visual of how the data or how the application is performing, or the type of the category of data stored, and to read from the logs. And variety of compute services, different VMs with different size and different operating systems, different containers available, different type of databases available, a lot of developer tools that are available for us, and identity service to manage our users in the Azure cloud. And those users can be integrated or federated with, let's say, Google, Facebook, LinkedIn. So there are some external federation services. They can be used to integrate with our identity system. IoT services, IoT tools and technologies available, and management tools to manage the users. Creating identity is one, and then managing them on top of it is a totally different thing. And we have tools, technologies to manage the users. Cool services for data migration. Data migration is now made simple. Tools and technologies available for mobile application development. And I can plan my own network in the cloud with the networking services. I can implement my own security, both Azure provided and third-party security services on Azure cloud. That's now possible. And a lot of storage options available in the cloud. So these are just a glimpse of the big list of services available in Azure cloud. So that was a glimpse of what's available in the cloud. Let's talk about the services in specific. Let's take compute for example. Whenever we're building a new application or deploying existing ones, the Azure Compute Service provides the infrastructure we need to run and maintain our application. We can easily tap in the capacity that Azure Cloud Service has, and we can scale our compute requirement on demand. We can also containerize our application. We have the option of choosing Windows or Linux VM machine and take the advantage of the flexible options Azure provides for us to migrate our VMs to Azure and a lot more. And these compute services also include a full-fledged identity solution, meaning integration with Active Directory in the cloud or on-premises, and a lot more. Let's look at some of the services that this compute domain provides. Some of the services the compute domain provides are virtual machines. And this Azure Virtual Machines gives us the ability to develop and manage a virtual computer environment or a virtualized environment inside Azure's cloud environment, that too in a virtual private network. Now we will talk about virtual private network at a later point, but as of now just know that there are a lot of services available in Azure Compute Service that we can get benefited from. We can always choose from a very wide range of compute options. For example, we have an option to choose the operating system. We have the option to choose whether the system should be in on-premises or in the cloud, or do we want to maintain the environment both in on-premises and in the cloud. We have the option of choosing the operating system, whether we want to use our own operating system with some software attached to it, or do we want to go and buy the operating system from the cloud, from Azure Marketplace. And these are just a few of the options available for us when we want to buy the compute environment. And these compute environments are easily scalable, meaning we can easily scale our VM instances from one instance to thousands of virtual machines in a matter of minutes, or simply put, in a couple of button clicks. And all these services are available on a pay for what we use model, meaning there is no upfront cost. We use the service and then pay for the services that we have used. There is no literal long-term commitment when it comes to using virtual machines in the cloud. And most of the services are built on a pay per minute billing basis. All right. And at no point, because of the pay per minute billing model, at no point we will be overpaying for any of the services. That's attractive, isn't it? Now let's talk about batch service. Now, batch service is always independent, regardless of whether you choose Windows or Linux, it's going to run fairly well. And with batch service, we can take advantage of the environment's unique features. And not only that, in short, the batch service helps us to manage the whole batch environment, and also it helps to schedule the jobs. Now, this Azure batch service actually runs on a large scale parallel and high performance computing. Because of that, batch jobs are highly efficient in Azure. And when we run batch services, this Azure batch creates a pool of computer nodes and installs the needed applications that we want to run, and then it schedules jobs to those individual nodes in those pools. As a customer, there is no need for us to install a cluster, or there is no need for us to install a software that actually schedules the jobs, or even to manage or even to scale those infrastructure or the software, because everything is managed by Azure. And this batch service is a platform as a service. There is no additional charge for using this batch service, except for, the only charges that we'll be paying is for the virtual machines that the service uses, and the storage that we will be using, of course, and the networking services that we will be using for this batch service. Let's summarize. This batch service, we have a choice of operating system that we can pick and use, and it scales by itself. Now, the alternative for the batch would be queues, but in queues, we'll have to pre-provision and pay for the infrastructure even if we're not using it. But with a batch, we only pay for what we use. And this batch service helps us to manage the application, manage the scheduling as a whole, as if they are just one thing. As next thing in the compute domain, let's talk about this Fabric service. Now, this Fabric service is actually a distributed system platform that helps us to package, deploy, and manage a scalable and a very reliable microservice and containers. And what does it help? This Azure Fabric service helps us, or it helps the developers and administrators so they can avoid the complex infrastructure problems, and they can focus only on implementing workloads or taking care of their development, taking care of their application instead of spending time on infrastructure. So what's Service Fabric? Service Fabric, it provides runtime capabilities and life cycle management to applications that are composed of microservices, no infrastructure management at all.
And with Service Fabric, we can easily scale the application to tens or hundreds or even to thousands of machines. Here, machines represent containers. As next thing in compute domain, let's talk about virtual machine scale set. Now, this virtual machine scale set, it lets us to create a group of identical load balanced VMs. I just want to mention it again. It helps us to manage a group identical and load balanced VMs. The number of instances or the number of VM instances in a scale set can increase or decrease in response to the demand or in response to a schedule that we define. The resources needed on a Monday morning is not the same as that would be required on a Saturday or a Sunday morning. All right. And even within the day, the resources that would be needed in the beginning of the business hour is not the resources that would be needed at noon or, after 8 or 9 in the evening. So the demands could actually vary in the environment, and this scale set helps us to take care of the varying demand or take care of the different infrastructure requirement at a different schedule throughout the day, throughout the week, throughout the month, or could be throughout the year as well. The scale set also allows us to provide high availability to our applications, and it helps us to centrally manage, configure, and update a large number of VMs as if they are just one thing. Now you might ask, well, virtual machines are enough. Why would we need a virtual machine scale set? Just like I said, this virtual machine scale set helps us with a greater redundancy and improved performance for our applications. And those applications can be accessed through a load balancer that actually distributes the requests to the application instances. So in a nutshell, this virtual machine scale set, it helps us to create a large number of identical virtual machines, number one. And with scale set, we can increase or decrease the virtual machines. With virtual machine scale set, we can centrally manage and configure and update a big group of VMs. And it's a great use case when it comes to big data or container workloads. As next thing in compute domain, let's talk about cloud services. Now this Azure Cloud Service is actually a platform as a service, and it's very friendly. In fact, it is designed for applications that support scalability or an application that requires scalability or reliability, and on top of it, you want them to be very inexpensive to operate. So Azure Cloud Service provides all these. So where would this cloud service run? Well, it runs on a VM, but it's a platform as a service. VMs are infrastructure as a service, and when we run applications on VM through cloud service, it becomes platform as a service. So here is how you got to be thinking. With infrastructure as a service like VMs, we first create and configure the environment, and then we run applications on top of it. Let's look at the responsibility. The responsibility for us in VM is that we manage everything end to end, like deploying new patches, picking the versions of the operating system, and making sure they are intact and all that stuff. It's all managed by us. But on the contrary, with platform as a service, it's as if the environment is already ready. All that you have to do is deploy your application in it and manage the platform. Manage the platform not as an administrator, because all the administration is taken care by Azure, like deploying new versions of the operating system. It's all handled by the Azure. So we deploy the application and we manage the application. That's it. Infrastructure management is handled by Azure. So what does cloud service provide? This cloud service provides a platform where we can write the application code, and we don't have to worry about hardware. Simply hand over the code and cloud service takes care of it. So no worry on the hardware at all. So responsibilities like patching, what do we do if something crashes? How do I update the infrastructure? How do I manage the maintenance or the downtime in the underlying infrastructure? All that is handled by Azure. It also provides a good testing environment for us. We can simply run the code, test it before it's actually released to the production. I want to expand a bit on these testing applications. So this Azure Cloud Service, it actually gives us a staging environment for testing a new release without it affecting the existing release, which actually reduces the customer downtime. So we can run the application, test it, and anytime that's ready for production, all that's needed for us to do to move it to production is simply to swap the staging environment into the production environment, and the old production environment will now become the new staging environment where we can add more to it and then swap it back at a later point. So it kind of gives us a swappable environment for testing our applications. And not only that, it gives us health monitoring alerts. It helps us to monitor the health and availability of our application. There is a dashboard we can benefit from when we use Azure Cloud Services, and that shows the key statistics all in one place. And we can also set up real-time alerts to warn when a service availability or a certain metrics that we are concerned about degrades. As next thing in compute domain, let's talk about functions. Now, functions are serverless computing. Many times if you heard about Azure being serverless, a lot of time they are referencing, or the person who's talking to you is referencing to serverless computing or Azure Functions, which is a serverless computing service hosted on Microsoft Azure. The main motive of a function is to accelerate and simplify application development. Functions helps us to run code on demand without we need to pre-provision or manage any Azure infrastructure. So Azure Functions are script or a piece of code that gets run in response to an event that you want to handle. So in short, we can just write a code that you need for a problem at hand without actually worrying about the whole application or the infrastructure that will be running that code. And the best of all the best is when we use functions, we only pay for the time that our code runs. So what does functions provide, or what does Azure Functions provide? Azure Functions allow users to build applications using serverless simple functions with a programming language of our choice. So the current programming languages that are supported is C#, F#, Node.js, Java, and PHP. So here we really don't have to worry about provisioning or maintaining servers. If a code requires more resource, yes, Azure Functions handles or it provides the additional resources needed by the code. And the best part is we only pay for the amount of time the functions are running, not the resources, but the amount of time the function is running. As next thing, and moving to the new domain, let's talk about the container domain in Azure. Now the container domain or the container service, it allows us to quickly deploy a production ready Kubernetes or a Docker Swarm cluster. Now what's a container? A container is a standard unit of software that packages of code and all its dependencies so the applications run quickly and reliably from one computing environment to another. It could be testing to staging to development environment to staging to production, or from one production to another production, or on-premises to cloud, or one cloud to another cloud, vice versa. Now imagine we had an option not to worry about the VM and just focus on the application. Well, that's exactly what containers helps us achieve. So these container instances enable us to focus on applications and not worrying about managing VMs or not worrying about learning the new tools required to manage the VMs or even the deployment. And our applications that we create, they run in a container. And running in a container is what helps us to achieve all these, not being able to manage or not needing to manage the virtual machines. So these containers, they can be deployed into the cloud using a single command if you're using a command line interface, and a couple of button clicks if we are using the Azure portal. And these containers are kept lightweight, but they are equally secure as virtual machines. Let's talk about container service as next thing. The container service, or sometimes called as Azure Kubernetes Service, it helps us to manage the containers. Container is one thing, and a service that's used to manage the container is another thing. Now this Kubernetes service, or ACS, it helps us to manage the containers. So let's expand on this a bit. So this Azure Container Service, or ACS, it actually provides a way to simplify the creation, configuration, and management of a cluster of virtual machines that are pre-configured to run containerized applications on top of them. Deploying these containers might take like 15 to 20 minutes, or deploying the virtual machines that run containers in it might take 15 to 20 minutes. And once they are provisioned, we can actually manage them by using simple SSH tunnel into them. And this ACS, when it runs application, it runs applications from Docker images. What does that mean? Docker images makes sure that the applications the container runs are fully portable. Images are portable. And ACS also helps us to orchestrate the container environment. Not only that, it also helps us to ensure that these applications that we run in containers can be scaled to thousands or even tens of thousands of containers. So in a nutshell, managing an existing application into a container and running it using AKS or ACS is really easy, or that's what it is all about, to make the application management or migration easy. Now, managing the container-based architecture, and we discussed that containers could be tens or even tens of thousands of containers. So managing them is made simple using this container services. And even training of model using a large data set in a complex and resource intensive environment, this AKS helps us to simplify that environment. All right, as next thing in container domain, let's talk about container registry. We spoke about registry a little bit when we spoke about Docker images. So container registry is a single place where we can store our images, which are Docker images. When we use containers, it's Docker images that we use for our image purposes. So these container images are a central registry that can be used to ease container development by easing the storage and management of container images. So there we can store all kind of images like Docker Swarm, or the images used in Docker Swarm are in Kubernetes. Everything can be stored in container registry in Azure. Now, anytime we store a container image, it provides us an option for geo replication. What that means is that we can efficiently manage a single registry replicated across multiple regions. Now, these geo-replication, it actually enables us to manage global deployments, assuming we are having an environment that requires a global deployment. So it helps us to manage global deployments as one entity because we are geo-replicating. We would be updating, we would be editing one image, and that image gets replicated throughout the global replication centers we would have set up. And so just one editing would have actually edited the global images, and those global images would have provisioned the global application. So one edit, replication, and then provisioning of the applications global wide. And this replication also helps us network latency, because anytime an application needs to deploy, it does not have to rely on a single source which can be reached only through high latency network. Because we have global replications around the world, anytime the application wants to check back, it would check back the application which is in a very nearby location for the application itself. Global replication means that we are managing it as a single entity that's being replicated across the multiple regions in the globe. As next thing in our learning, let's talk about Azure databases. Now, these Azure databases are relational. In fact, they have many flavors in them. We're going to look at different flavors, SQL, NoSQL, cache type of database that Azure offers. So we're going to learn one at a time, or we're going to learn one by one. So this Azure SQL database is a relational database. In fact, it's a relational database as a service. It's managed by Azure. We don't get to do a lot of management in it. So it's a relational database as a service based on Microsoft SQL Server database engine. And this database is a high performance database. It is very reliable, and it's very secure as well. And this high reliability, high performance, and for this high security, we really don't have to do anything. It comes along with it, and it's managed by Azure. And there are two things that I definitely need to mention about Azure SQL database. That is, it's an intelligent service. Number one, it's fully managed by Azure, and it also has this one good thing, which is it has built-in intelligence that learns app patterns and adapts to maximize performance and reliability and data protection of the application. That's something that's not found in many of the other cloud providers that I'm aware of. So I thought I'll mention it. So it uses built-in intelligence to learn about the user's database patterns and helps improve performance and protection. And migration or importing data
is very easy when it comes to Azure SQL database. So it can be readily or immediately used for analytic reporting and intelligent applications in Azure. As next thing, let's talk about Azure CosmoDB. Now, Azure CosmoDB is a database service that is for NoSQL type, and it's created to provide low latency and an application that scales dynamically or that scales rapidly. Now, this Azure CosmoDB is a globally distributed service, and it's a multi-model database. This can be provisioned in a click of a button. That's all we got to do if we need to provision an Azure CosmoDB in the Azure. It helps with scaling the database. We can elastically and independently scale throughput and storage across this database and in any of the Azure geographic regions. It provides a good throughput, it provides good latency, it provides good availability, and it provides, or Azure promises, a comprehensive SLA that no other database can offer. That's the best part about CosmoDB. So this CosmoDB was built with global distribution in mind, and it's built with the horizontal scale in mind. And all this we can use by only paying for what we have used. And remember, the difference between Azure CosmoDB and the SQL database is that Azure CosmoDB supports NoSQL, whereas SQL doesn't. Alright, few other things about Azure CosmoDB is it allows users to use key value, graph, column, family, and document data. It also gives users a number of API options like SQL, JavaScript, MongoDB, and few others that you might want to check in the document at the time of reading. And the best part here is that all that we mentioned, we get to use only by paying for the amount of storage and throughput that are required. And the storage and the throughput can be elastically scaled based on the requirement of that R. Alright, let's talk about Redis Cache. Discussion about Azure database won't be complete without we talking about Redis Cache. Now, Redis Cache is a secure data cache. It's also sometimes called as messaging broker that provides high throughput and low latency access to data for the applications. Now, Redis Cache is based on a popular open source caching product, which is Redis, sometimes called as Redis Cache. Now, what's the use case? It's typically used to cache to improve the performance and scalability of a system that rely heavily on backend data stores. Now, performance when we use Redis Cache is improved by temporarily copying the frequently accessed data to a fast storage located very close to the application. Now, with Redis Cache, this fast storage is located in memory with Redis Cache instead of being loaded from the actual disk in the database itself. Now, this Redis Cache can also be used as an in-memory data structure store. Not only that, it can be used as a distributed non-relational database and a message broker. So there are a variety of use cases for this Redis Cache. And by using Redis Cache, the application performance is improved by taking advantage of the low latency and the high throughput performance that this Redis Cache engine provides. So to summarize, this Redis Cache, when we use Redis Cache, data is stored in the memory instead of the disk to ensure that there is high throughput and low latency when the application needs to read the data. It provides various levels of scaling without any downtime or interference. Now, this Redis Cache is actually backed by Redis server, and it supports string, hashes, linked list, and various other data structures.
Now let's talk about security and identity services. Now, identity management in specific is a process of authenticating first and then authorizing using security principles. Now, not only that, identity management involves controlling information about those principal identities. You might ask, now what's a principal identity? Now, identity or principal identity are services, applications, users, groups, and a lot more. The speciality about this identity management is that it not only helps authenticate and authorize principals in cloud, it also helps authenticate and authorize principals or resources on premises, especially when you run an hybrid cloud environment. So all these services and features that this identity management helps us to get additional level of validation, like
identity management can provide multi-factor authentication. It can provide access policies based on condition, a permit or deny based on condition. It can also monitor suspicious activity. And not only that, it can also report it. It can also help generate alerts for potential security issues, and in a way to mitigate it, can send us an alert so we can get involved and prevent a security accident from happening. So let's talk more about identity management. So some of the services under security and identity management are Azure Security Center. Now this Azure Security Center provides security management and threat protection across the workloads in both cloud and in the hybrid environment. It helps control user access and application control to stop any malicious activity if present. It helps us to find and fix vulnerabilities before they can be even exploited. It integrates very well with analytic methods that helps us to identify, or it gives us the intelligence to identify or detect attacks and prevent them before it can actually happen. And it also works seamlessly with hybrid environments. So you don't have to have one policy for on-premises and one policy for the cloud. It's now a unified service both for on-premises and the cloud. The next service in security and identity would be Key Vault. Now, a Key Vault is a service or a feature that helps safeguard the cryptographic keys and any other secrets used by the cloud applications and the services. In other words, this Azure Key Vault is a tool for securely storing and accessing the secrets of the environment, the secret keys. Now, a secret is anything that you really want to have a very tight control access, like the certificates, like the passwords, stuff like that. Now, if I tell you what Key Vault actually solves, that would actually explain what Key Vault is. Now, Key Vault is used in secrets management. It's helped in securely storing the tokens, the passwords, the certificates. It helps in key management. It really helps in creating and controlling the encryption keys that we would use to encrypt data. It helps in certificate management. Talking about certification management, it helps us to easily provision, manage, and deploy public and private SSL, TLS certificates in Azure, and a lot more. So in a nutshell, this Key Vault, it provides users the ability to provision new vaults and keys in just a matter of minutes. All that in a single command, or all that in a couple of button clicks. It also helps users to centrally manage their keys, secrets, and policies. Next in the list, let's talk about Azure Active Directory. Now, Azure Active Directory, it helps us to create intelligent-driven access policies to limit resource usage and manage user identities. What does that mean? Now, this Azure Active Directory is a cloud-based Active Directory and identity management service. Now, Azure Active Directory combines, it's actually a combination of the core directory services plus application access management plus identity protection. And one good thing about this Azure, in fact, there are a lot of good things, but especially when you're running hybrid environments, you might wonder, well, how this Azure Active Directory is going to behave. Now, this Azure Active Directory is built to work on on-premises and cloud environment as well. Not only that, it also works seamlessly with mobile applications as well. So in a nutshell, this Azure Active Directory, it acts as an central point of identity and access management for our cloud environment. It also provides good security solutions that protect against unauthorized access of our app and the data. Now that we've discussed about security and identity, let's talk about the management tools that Azure has to offer. Azure provides built-in management and account governance tools that helps administrators and developers, that helps them to keep their resources secure and very compliant. And again, it helps both in on-premises and in the cloud environment. And these management tools help us to monitor the infrastructure, monitor the applications. It also helps in provisioning and configuring resources. It also helps in updating apps. It helps in analyzing threats, taking backup of the resources, build disaster recoveries. It also helps in applying policies and conditions to automate our environment. We use Azure management tools, and it's also used in cost control methods. So this Azure management plays a wide role across the Azure services. And in the management tools, first comes the Azure Advisor. Now this Azure Advisor, it acts as a guide to educate us about Azure best practices. It throws recommendations that we can select on the basis of the category of service, and it also provides the impact it can have, or the impact that would happen in our environment if we follow the recommendations given. And recommendations are, first one is the recommendations are kind of templatized, and it throws the templatized recommendations. Not only that, it also provides customized recommendations on the basis of the configuration, on the basis of our usage patterns. And these recommendations are not hard. It's not like something that it recommends and then just leaves us hanging there. These recommendations provided are very easy to follow, very easy to implement and see results. You can think of Azure Advisor as a very personalized cloud consultant that helps you to follow best practices to optimize our deployments. It kind of analyzes our resources, our configurations, our usage, and then it recommends a solution for us that really helps in improving the cost effectiveness, improving the performance, improving high availability, and improving security in our Azure environment. So with this Azure Advisor, we can get a proactive, actionable, and personalized best practice recommendations. Now, you don't have to be an expert. Just follow the Azure Advisor and your environment is going to be good. It also helps in improve the performance, security, high availability of our environment. And also it helps in bringing down the overall Azure spend. And the best part is it's a free service that analyzes our Azure usage and provides recommendations, how we can optimize our Azure resource to reduce cost. And reduce cost at the same time boost the performance, helps in strengthening the security and improve the overall reliability of our environment. Next in the list would be Network Watcher. Now this Network Watcher helps users identify and gain insights in the overall network performance and the health of the overall environment. Now these Azure Watchers provides enough tools to monitor, to diagnose, to view the metrics, and to enable or disable logs, which means generate and collect the logs for resources in the Azure Virtual Network. So with Network Watcher, you can monitor and diagnose issues in networking without even logging into the virtual machines. With just the logs, which are real time, we can actually come to a conclusion what could be wrong in a certain resource, in a VM or in a database, by just looking at the logs. And not only that, it's used for analytic or to gain some intelligence of what's happening in our network. We can gain a lot of insight to the current network traffic pattern using the security group flow logs that this Network Watcher offers. It also helps in investigating VPN connectivity issues using detailed logs. Now, you might or might not know that VPN troubleshooting requires both parties, or it involves two parties. The person, the network administrator on this side and the network administrator on the other side. And they will have to check logs in their end, and we'll have to check logs in our end, stuff like that. But with the Network Watcher, it kind of takes it to the next level. The logs itself, we could easily identify which side is having the issue and suggest an appropriate fix. And the next in the list would be Microsoft Azure Portal. Now, this Microsoft Azure Portal, it provides a single unified console to perform various number of activities like building, not only building, managing and monitoring the web applications that we build. Now, this portal can be used to organize our environment, or the appearance of the environment, or the visual of the environment based on our work style. And using Azure Portal, users can control who gets to manage or access the resources, all from the Azure Portal. And this Azure portal gives a very good visibility on the spends that happen on each resource, right? And if we can customize it, we can also identify spends based on team, spends based on days, spends based on department, stuff like that. So it kind of gives us a good visual of where the money is spending or where is the bill consumed within the Azure environment. Next in the list would be Azure Resource Manager. Now, Azure Resource Manager enables us to manage the usage of the application resources. Now, we use Resource Manager to deploy, monitor, and manage solution resources as a group, as if it's one single entity. Now, the infrastructure of our application is typically made of various components, which includes virtual machine, storage, virtual network, web app, database servers, some other third-party services that we might use in our environment. And they are, by nature, separate services. But with Azure Resource Manager, we don't see them as different components or different entities. Instead, we see them as related services in a group that supports an application. Now we kind of get the relation between them instead of letting them spread. Azure Resource Manager identifies the relation between them and helps us to visually see them all as one or single entity. Not only that, Azure Resource Manager helps or it ensures that the resources that we provision are deployed at a constant rate along with the other application. It also helps users to visually see their resources and how they are connected, and that helps in managing the resources a lot better. Resource group also is used to control who can access the resources within the user's organization. Kind of gives you the fine-grained control over who gets to access and who does not get access. And the last one in the management tools would be automation. And this automation gives us the ability to automate, configure, and install upgrades across hybrid environments. It provides a cloud-based automation and configuration service. Not only that, this can be applied for non-Azure environments as well, which is on-premises. So some of the automation we could do is process automation, update management automation, configuration features automation, stuff like that. And this Azure automation provides complete control during the deployment, operation, and also during the decommissioning of the workloads and resources. With automation, we can actually automate time-consuming or mundane or any task that's error-prone because of human errors. Those things can be automated. So irrespective of how many times you run it, it's going to run the same way. And that really helps in reducing the overall time and also the overhead cost, because a lot of the things are automated, which means it's human error-free, which means the application is not going to break and keep running for a longer time. With automation, we can actually build a good inventory of operating system resources and configuration items all in one place with ease. And this really helps in tracking the changes and investigating the issue. Let's say something happened. Because we have automation, because it's logging the configuration changes, it's easy to track, easy to identify what has changed lately that has broken the environment, go back and fix it or kind of roll it back. That solves the problem. And that actually summarizes the Azure management tools or management services. Now let's talk about the networking tools or the networking services available in Azure. There are a variety of services, especially networking services, that Azure offers, and I'm sure it's going to be an interesting one. Let's begin our discussion with Content Delivery Network. Now, the Content Delivery Network, in short, CDN, it allows us to perform secure and a very reliable content delivery. Not only that, it also helps in accelerating the delivery time, or in other words, reducing the delivery time, also called as load times. It also helps in saving bandwidth and increases in responsiveness to the application. Let's expand on this. The Content Delivery Network is actually a distributed network of servers that can efficiently deliver web content to users. Now, CDNs we're going to use the word CDN here. CDNs store cached content on global edge servers, also called as POPs, point of presence locations, that are very close to the end users, so the latency is minimized. It's like taking a copy of the data or taking a multiple copy of the data and storing it in different parts of the world, and whoever is requesting it, the data gets delivered to them from a server which is very locally to them. So this CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching the content in a strategically placed location which is very near to them. So these content delivery networks, it really helps in handling. That's one advantage you get for content delivery network, that's we can handle spikes and heavy loads very efficiently. And we can also run analytic against the logs that gets generated in content delivery network, which helps in gaining good insight on the workflow and what would be the future business need for that application. And this, just like a lot of other services, this is on a pay as you go type. So you use the resource first and then you only pay for what you have used. The next one in networking would be ExpressRoute. Now ExpressRoute is actually a circuit or a link that provides a direct private connection to Azure. And because it's direct, it gives low latency link to Azure. It gives good speed and reliability for the Azure data transfer. It could be on-premises to Azure. So it gives very good speed. It gives increased reliability and low latency for that connection. Let's expand on this a bit. Now this ExpressRoute is an service that actually provides a private connection between Microsoft data center and infrastructure in our premises or in a different co-location facility that we might have. Now these ExpressRoutes do not go over the public internet. And because they don't go over the public internet, they offer a high security, reliability and speed and low latency compared to the connections which are in the internet. Because it's fast, because it's reliable, because it has low latency, it can be used as an extension of our existing data center. Users are not going to feel the difference whether they are accessing services from an on-premises or in the cloud environment, because latency is minimized as much as possible. Users are really not going to see the difference. And because it's a private line and not a public internet line, it can be used to build hybrid applications without compromising privacy or the performance. Now these virtual private cloud, these ExpressRoutes can be used for taking backups. If assume a backup going through the internet, that would be a nightmare. If you use ExpressRoute for backups, that's going to be fast. And imagine recovering a data through the internet, from the cloud, through the internet, to the on-premises in a time of disaster. That would be the worst nightmare. So these ExpressRoutes can be used not only to backup, but also to recover the data. Because it provides good speed, low latency, recovering the data is going to be a lot sooner. The next product or service we're going to discuss in networking is Azure DNS. Now Azure DNS allows us to host domain name in Azure. And these domain names come with an exceptional performance and availability. Now, Azure DNS is used to set up and manage DNS zones and records for our domain name in the cloud. Now, this Azure DNS is a service for DNS, just like the name says, and it provides name resolution by using Azure's infrastructure. And by using this domain, we can actually manage the DNS ourselves through the Azure portal with the same credential. Imagine having a DNS provider which does not even belong in our IT. Imagine that environment. We would have a separate portal to manage the DNS environment. Now those are gone. And now we can actually manage the DNS in the very same Azure portal where we use the rest of the other services. And this Azure DNS very much integrates with other DNS service providers. It uses a global network of name servers to provide fast response to DNS queries. And these domains are having additional availability compared to the other domain service providers availability promises. These are going to have more availability than the rest because most of the servers are maintained by Microsoft, and it helps resolve sooner. It helps resyncing. Let's say a server fails, it kind of helps resyncing with the rest of the servers. So all the Microsoft's environment, all the Microsoft's global network of name servers kind of ensures that our domain names are resolved properly, not only properly, but also are available most of the time. All right, next in the list in networking services is virtual network. I'm sure this is going to be very interesting, and I'm sure you're going to like it. So this networking or virtual networking in Azure, it actually allows us to set up our own private cloud in the public cloud. It gives us an isolated and highly secure environment for our application. Let's expand on this. So this Azure Virtual Network helps us to provision Azure virtual machines, and it helps us to securely communicate with other on-premises and internet networks. It also helps in controlling the traffic that flows through or flows in and out of this virtual network to other virtual networks and to the internet. Now this Azure virtual network, sometimes called as VNet, is actually a representation of our own network in the cloud. It's actually a logical isolation of the Azure cloud dedicated to our subscription. All our environments are provisioned in a VNet that is separate from another customer's VNets. That way we have that logical separation there. So this virtual network can also be used to provision VPNs in the cloud, so we can connect the cloud and the on-premises infrastructure and a lot more, especially in an environment where we have hybrid environment. Surely we will be using virtual network because that's going to require a VPN for secure data transfer in and out of the cloud and in and out of the on-premises environment. Alright, so it kind of gives us a boundary for all the resources. So all the traffic between the Azure resources, they kind of logically stay in between or logically stay within the Azure virtual network. And here we can design the network. It's given over to us. You can pick the IP, you can pick the routing, you can pick the subnet. A lot of freedom is given, or I would say a lot of control on how the network is designed. It's not like something that's already cooked and we only get to use it. No, we can actually build the network from the scratch. We can pick the IP address that we like. We can pick which subnet needs to communicate with the other subnet, stuff like that. And like I said, if you are using hybrid environment, you definitely would be requiring a virtual network because it helps connect the on-premises and the cloud in a secure fashion using VPN. The last product we're going to discuss in networking is a load balancer. This load balancer actually provides application a good availability and a good network performance. So how does it work? It actually works by load balancing the traffic to and from the virtual machine and the cloud resources. Not only that, it also load balances between cloud and cross-premises virtual networks. With Azure Load Balancer, we can actually scale our application and create high availability for our services, which means our application will be available most of the time. If any of the server goes dead, the server does not get traffic. What happens if the server gets traffic? User is going to experience downtime. What happens if the server does not get traffic? User won't experience any downtime. The connection is shifted to an healthy service, so the user experiences uptime all the time. So this load balancer supports inbound and outbound scenarios, and it provides low latency. It gives high throughput of the data transfer, and we can actually scale up the flow of the TCP and UDP connections from hundreds to thousands to even millions because we have a load balancer now in between the user and the application. So how does it operate? This load balancer actually receives the traffic and it load balances the traffic to the backend pool of instances connected to it according to the rule and the health probe that we set.
That's how it maintains high availability. So what does load balancer help? It helps in creation of high available scalable application in the cloud in minutes. It can be used to automatically scale the environment with the increasing application traffic. And one feature of load balancer is to check the health of the user's application instance, and it removes or it stops sending the request to the unhealthy instance and kind of shifts that connection to the healthy instance. That way a user or a connection does not get stuck with an instance that's not healthy. That's all that you need to know about the networking services. Now let's talk about the storage services or the storage domain in Azure. Now Azure Storage in general is a Microsoft managed service providing cloud storage, which basically is highly available, secure, durable, scalable, and redundant because it's all managed by Azure. We don't get to manage a lot of it. And these Azure storages are a group of storage services. They cater different needs. And the storage products include Azure Blobs, which is actually an object storage. It includes Azure Data Lake. It includes Azure Files. As you see, it includes Azure Queues. It includes Azure Tables and a lot more. But let's start our discussion with Azure Store Simple. Azure Store Simple is an hybrid cloud storage solution that actually lowers the cost of storage to nearly 60% of how much you would be actually spending without using it. So Azure Simple Storage or Store Simple is an integrated storage solution that manages the storage task between on-premises and the cloud storage. What I really like about Azure is that it's built around a hybrid environment in mind. There are a lot of other cloud providers that are there where running an hybrid environment is a big challenge. You know, it has some compatibility. You won't be able to find an hybrid or a on-premises and cloud solution for your need, stuff like that. But with Azure, especially when it comes to storage, a lot of the things that we're going to see, it clearly is designed with hybrid environment in mind. All right, so let's come back and talk about Store Simple. So Store Simple is an very efficient, cost-effective, and a very easily manageable SAN, storage area networking solution in the cloud. I thought I'll throw in this information. The reason why it got Store Simple is really because it uses Store Simple 8000 series devices which are used in Azure Data Center. And this Store Simple or Simple Storage, it comes along with storage tiering to manage the stored data across the various storage media. So the very current data is actually stored in on-premises on solid state drives, and data that is used less frequently is stored in HDDs or hard disk drives. And the data that requires archived or that needs to be archived, very old data, let's say less frequently used data, candidate for archive, they are actually pushed to the cloud. So you see how this storage tiering automatically happens in Store Simple. And another cool feature of Store Simple is that it enables us to create an on-demand and scheduled backups of data and then store the data locally or in the cloud. And these backups are actually taken in the form of incremental snapshot, which means that they can be created and restored quickly. It's not a complete backup, it's an incremental backup. And these cloud snapshots, they can be critically important when there is a disaster and when there is a disaster recovery scenario, because these snapshots can be called in and they can be put on storage systems and then they become the actual data. So recovering is faster if you have proper scheduled backups or if you have frequent backups. And this Storage Simple, it really helps in easing our backup mechanism, which means it kind of eases our disaster recovery steps or procedures as well. So this Store Simple, it can be used to automate data management, data migration, data movement, data tiering across the enterprise, both in cloud and on premises. It actually improves the compliance and accelerates the disaster recovery for our environment. And if there is one thing that's increasing every new day in our environment, that would be storage. And this Store Simple addresses that need, and we really don't have to pre-plan or think in deep for having a proper storage, because now we have a simple storage available in the cloud, and moreover it's on a pay-as-you-go type. So not much pre-planning on storage is needed. Yes, there will be a need, but not as much as I would without the cloud or without the simple storage.
And the next service under storage that we would like to discuss is the data lake store. This data lake store or storage, it's a cost-effective solution for big data analytics in specific. So let's expand this. So this data lake storage is an enterprise-wide repository for big data analytic workload. Now that's the major service that's dependent on this data lake store. And this data lake enables us to capture data of any size, of any type, and of any ingestion speed, and it kind of collects them in one single space or in one single place for operational efficiency. And for analytic purpose. Hadoop in Azure is very dependent on this data lake storage. And this data lake store is designed with performance for analytics in mind. So anytime you think of, or anytime you're using analytic in the cloud, or anytime you're using Hadoop in the cloud in Azure, we are definitely using, or we will be, to the most part, or the normal procedure, or the right storage to pick would be data lake store in Azure. It's designed with security in mind. So anytime we use Azure storage, we can be rest assured that we are using storage from within a data center which was built with security in mind. So this data store also uses Azure Blob storage behind the scenes for global scale, durability, and for performance. Let's talk about blob storage. Now, blob storage provides large amount of storage and scalability. Now, this blob storage is the object storage solution for Azure Cloud. Let's expand a bit on blob storage. Azure Blob Storage is Microsoft offering for object storage. Now, this blob storage is optimized for storing massive amount of unstructured data, which could be text or binary data. It's designed and it's optimized for rapid reads. If I explain to you on what scenarios we would be using blob storage, that might help you get a good understanding of what blob storage is. So it's designed, as of now it's being used in many IT environments to serve images or documents directly to the browser. It helps in storing files for distributed access. A lot of fetchers can fetch data from Azure Blob Storage. And it's currently helping users stream video and audio. It's currently being used for writing log files. It's currently being used to store data as backup and restore at a later point in times of disaster recovery. It also is used as an archiving storage in a lot of cloud IT environments. It's widely used in storing analytic data, not only storing, but also running analytic query against the data stored in it. So that's a wide use case for blob storage. Not only that, in addition to all that we mentioned, it also supports versioning. So anytime somebody updates an data, a new version gets created, which means at any point I can roll back as and when needed. And it provides a lot of flexibility on optimizing the user's storage need. It also supports tiering of the data. So based on need, when I actually explore, I would find a lot of options I can pick from that suits to my unique storage environment or unique storage need. And like I said, it stores unstructured data, and this unstructured data is available for customers through REST-based object storage environment. The next product and storage service would be queue storage. Now, queue storage provides durable queues for large volume cloud services. It's a very simple and a cost-effective, durable messaging queue for large workloads. Let's expand this queue storage for a moment. Now, this queue storage is a service for storing large amount of messages that can be accessed from anywhere in the world through HTTP and HTTPS calls. A single queue or a single queue message can be up to like 24 KB in size, and a single queue can contain millions of such 24 KB in size messages. And how much can it hold? It can hold up to the total capacity of the storage account itself. So that's kind of easy to translate. How much would it hold? And this Azure Queue Storage, it provides an messaging solution between applications and components in the cloud. What does it help? It helps in designing an application for scale.
It helps in decoupling the application. So, it's not very dependent, or sometimes it's not at all dependent on the other application, because now we have a queue in between which kind of translates, or which kind of connects, or which kind of decouples both the environment. Now we have a queue in between. Both the environment can scale up or scale down independently. The next in the storage service would be file storage. Let's talk about file storage. Now, these Azure files provide secure, simple, and managed cloud file shares. Now, with file share in the cloud, it actually extends the user server's on-premises performance and capacity. And a lot of familiar tools for the cloud file share management can be used along with the file storage that we're talking about. So let's expand a bit on file storage. Now, this Azure Files or Azure File Storage offers a fully managed file shares in the cloud that can be accessed via the SMB protocol, Server Message Block Protocol. Now, this Azure file shares can be mounted concurrently by cloud or in on-premises deployments. A lot of operating systems are compatible with it. Windows are compatible, Linux is compatible, Mac OS is compatible. In addition to all this being able to run on-premises and on the cloud, or being able to access from on-premises and on the cloud, it can also offer cache for caching the data and keeping it locally, so it's immediately available when needed. So that's some additional feature. I would say that's some advanced feature that it offers compared to the other file shares available in the market. Let's talk about table storage. Now, table storage is a NoSQL key value pair storage for quick deployments with large semi-structured data sets. The difference between one important thing to note with table storage is that it has a flexible data schema, and also it's highly available. Let's expand a bit on table storage. So anytime you want to pick a schema-less, a NoSQL type table storage is the one we'll end up picking. It provides an key pair attribute storage with a schema-less design. This table storage is very fast and very cost effective for many of the applications, and for the same amount of data, it's a lot cheaper when you compare it with the traditional SQL data or data storage. So some of the things that we can store in the table storage are, of course, they're going to be flexible data sheets, such as user data for web application, address books, device information, and other types of metadata for our service requirements. And it can have any number of tables up to the capacity limit of the storage account. Now, this is not possible with SQL. This is only possible with NoSQL, especially with table storage in Azure. Explanation of storage really concluded the length and breadth of the explanation this CEO was giving his IT personnel. But this IT personnel is not done with it yet. He still has a question even after this lengthy discussion, and his question was, well, there are a lot of other cloud providers available. What made you specifically choose Azure? I mean, from the kind of question that he asked, we can say that he is very curious, and he definitely had asked a very thoughtful question. So his CEO went on and started to explain about the other capabilities of Azure, or how it kind of outruns the rest of the cloud providers. So he again started his discussion, but from a different angle now. So he started to explain what are the capabilities, or how Azure is better than the competitors. So he started with explaining the platform as a service capabilities. And I'm going to tell you what the CEO told his IT person. So this platform as a service, or in platform as a service, the infrastructure management is completely taken care by Microsoft, allowing users to focus completely on the innovation. No more infrastructure management responsibilities. Go and focus on innovation. That's a fancy way of saying it. When we buy platform as a service, that's what we get. We can contribute our time on innovation and not just maintaining the infrastructure. And Azure especially is .NET friendly. Azure supports the .NET programming language, and it is built or designed, or it is optimized to work with old and new applications deployed using .NET programming framework. So if your application is .NET, most of the time you would end up picking Azure. I mean, if you try to compare, most of the time you would end up picking Azure as your cloud service provider. And the security offerings that Azure offers is it's designed based on the security development lifecycle, which is an industry-leading assurance process. When we buy services from Azure, it assures that the environment is designed based on security development lifecycle. And like I mentioned many times in the past, and I would like to mention it again, Azure has well thought about the hybrid environments, which a lot of other cloud providers have failed. So it's very easy to set up an hybrid environment, to migrate the data or not to migrate the data and still run a hybrid environment. They work seamlessly with Azure because Azure provides seamless connection across on-premises data centers and the public cloud. It also has a very gentle learning curve. If you look at the documentation, it's picture rich, and the documentations are neat and clear. It would encourage you to learn more. It would encourage you to think and imagine and try easily get a grasp of how services work. So it has a very gentle learning curve. Azure allows the utilization of technologies that several businesses have used for years. So there is a big history behind it. It has a very gentle learning curve. The certifications, the documentations, the stage-by-stage certification levels, it's all very gentle learning curve, which is generally missing in other cloud service providers. Now, this would really impress the CTOs or people working in finance and budgeting. If an organization is already using Microsoft software, they can definitely go and avail or be bold and ask for a discount that can reduce the overall Azure spending. In other words, overall pricing of the Azure. So that's what helped, or they are the information that helped the CEO pick Azure as his cloud service provider. And then the CEO goes on and talks about the different companies that are currently using Azure, and they are definitely using Azure for a reason, like Pixar, Boeing, Samsung, EasyJet, Xerox, BMW, 3M. They are major multinational, multi-billion companies. They rely, run, operate their IT in Azure. And this CEO has a thought that his IT person is still not very convinced unless and until he shows him a visual of how easy things are in Azure. So he goes on and explains about a practical application of Azure, which is what exactly I'm going to show you as well. All right, a quick project on building an Azure app using or building a .NET application in Azure Web App and making it connect to an SQL database will solidify all the knowledge that we have gained so far. So this is what we're going to do. I have an Azure account open, as you see, logged in, and everything is fresh here. Let me go to resource group. There's nothing in there. It's kind of fresh. All right, I'm logged in, and this is what we're going to do. So we're going to create an application like this, which is nothing but an to-do application, a to-do list application, which is going to run from the web app, get information from us, and save it in the database that's connected to it. So you can already see it's a two-tier application, web and DB. All right. So let me go back to my Azure account. The first thing is to create an resource group. Let's give it a meaningful name. Let's call it Azure Simplilearn. All right. And it's going to be a free trial. And the location, pick one that's nearest to you or wherever you want to launch your application. Now for this use case, I'm going to pick Central US and create. It's going to take a while to get created. There you go. It's created. It's called Azure Simplilearn. Now what do we need? We need an web app and a separate SQL database. Let's first get our web app running. So go to App Services and then click on Add. It's not the web app plus SQL that we want. We want web app alone for this example. So let's create an web app. Give it a quick name. Let's call it Azure Simplilearn. The subscription is free trial. And I'm going to use my existing resource group, a resource group that we created some time back. It's going to run out of Windows, and we're going to publish
the code all set, we can create it. All right, while this is running, let me create my database. Right, SQL database, create a database, give it a name. Let's call it Azure Simplilearn DB. Put it in our existing resource group that we created. It's going to be a blank database, right? And it's going to require some settings like the name of the server and the admin login, the password that goes along, and in which location this is going to be created. The server name is going to be Azure Simplilearn DB. That's the server name. And the admin login can be, what can be the admin login name? Let's see. So let's call it Simplilearn. That's my admin login name. And let me pick a password. Click on create. So what have we done so far? We have created an web app and we have created a database in the resource group that we have created. So if I go to resource group, it's going to take some time before things show up. So if I go to my resource group, I only have one resource group as of now, Azure Simplilearn, and there I have a bunch of resources being created. It's still being created. All right. In the meantime, I have my application right here that's running out of or that's in Visual Studio as of now, right? So once the infrastructure is set and ready in the Azure console, we're going to go back to Visual Studio, feed these inputs in the Visual Studio so the code knows what the database is, the credentials to log into the database, stuff like that. So we're going to feed those information in Visual Studio. By that, we're actually feeding it into the application, and then we're going to run it from there. Deploying these applications takes quite a while. We really got to be patient. Right, now we have all the resources that we need for the application to run. Here's my database, and here's my app service. There's one more thing we need to do, that is create an firewall exception rule. So one more thing needed is to create an firewall exception rule, right? So the application is going to run from my local desktop and it's going to connect to the database, right? So let's add an exception rule by simply adding the client IP. It's going to pick my IP, the IP of the laptop I'm using as of now, and it's going to create an exception to access the database. So that's done. Now we can go back to our Visual Studio. I already have a couple of apps running or a couple of configurations pushed from Visual Studio. I'm going to clean that up. If you're doing it for the first time, you may not need to do this. Alright, so let's start from the scratch. This is very similar to how you would be doing in your environment. Alright, so we're going to select an existing Azure app service. Now before that, I have logged in. As you can see, I have logged in with my credentials. So it's going to pull few things automatically from my Azure account. So in this case, I'm going to use an existing Azure app. So select existing and then click on publish. All right, if you recall, these are the very same resources that we created a while back. Right, we have clicked on save and it's running, kind of validating the code, and it's going to come up with an URL. Now initially the URL is not going to work because we haven't mapped the application to the database. So that would be the next thing. Alright, so the app has been published
and it's running from my web app as of now. It's going to throw an error. Like you see, it's throwing an error. That's because we haven't mapped the app and the DB together. So let's do that. All right, let's do that. So let's go to Server Explorer. This is where we're going to see our databases that we have created. Now let's quickly verify that. Go back to the resource group, right? Appropriate resource group, which is right here. And here I have my database, Azure Simplilearn database. Right, it has some issues connecting to my database. Give me a quick moment. Let's fix it. All right, so we'll have to map the database into this application. All right, so let's go to the Solution Explorer, click on Publish, and a page like this gets shown. And from here, we can go to Configure. Here is our web app, all right, with all its credentials. Let's validate the connection, number 1. All right, and then click on Next. This is my DB connection string, right, which the app is going to use to connect to my DB. Now, if you recall, our DB was Azure Simplilearn DB, and that's not being shown here. So let's fix that. Right, so let's fix that. Click on Configure, and here let's put our DB servers URL. Now before that, let's change this to SQL Server. All right, and then in here put the DB's URL. So go back to Azure. Here is my DB or server's name. Put that here. Right, the username to connect to the server, that's right here. Put that in, and the password to connect to the server, let's put that in. All right, it's trying to connect to our Azure portal or the Azure infrastructure, and here is my database. If you recall, it's Azure SLDB. That's the name of the database. Let's test the connection. Connection is good. Click on OK. So now it's showing up correctly, Azure Simplilearn DB. That's the name of the database that we created. Now it's configured. All right, let's modify the data connections. Right, let's map it to the appropriate database again. All right, so our name of the database is Azure Simplilearn DB, and then it's going to be SQL Server. That's the data source. The username is Simplilearn, and the password is what we have given in the beginning.
All right, let's validate the connection. It's good. Click OK. Now we're all set and ready to publish our application again. Now the application knows how to connect to the database. We have educated it with the correct connection strings, the DNS name, the username, and the password for the application to connect to the database. So Visual Studio is building this project, and once it is up and running, we'll be prompted with an URL to connect, and anytime we give inputs to the URL, that's going to receive the input and save it in the database. Alright, so here is my to-do list app, and I can start creating to-do list for myself. Alright, so I have the items already listed. I can create an entry, and these entries get stored in the database. I can create another entry, take the dog for a walk. That's gonna get stored. I can create another entry, book tickets for scientific exhibition, and that's going to receive and put that in the database. And that concludes our session. So through this session we saw how I can use Azure Services to create a web app and connect that to the DB instance, and how those two services which are decoupled by default, which are separate by default, how I can use the connection strings to make connection between the app server and the database and be able to create an working app. I strongly believe you enjoyed me walking you through this session.
So in this video, here's what we're going to talk about. First, we'll talk about what is cloud computing, what is Microsoft Azure, what are the services that Azure offers, and then we'll have a look at a use case where we'll be applying one of these services to get a particular job done. Now for the first question, what is cloud computing? So cloud computing actually provides a platform through which you can access resources. Now these resources include servers, storage, application security, and other ways you can transform your data or get some use out of it. Now at the same time, you can also store, manage, and process your data. Now anything related to cloud computing is made possible only with the help of the internet. Now along with these things, there are several other things that you can do with cloud computing. Now let's have a look at some of the ways cloud computing is making our lives better. Firstly, you have services for just about every requirement that you have. Then you get access to the newest and most innovative technologies in the market right now. Cloud computing provides cost-effective solutions with flexible pricing. Now most cloud service providers work in such a way that you only pay for the amount of time you use that particular resource. Then you have one of the most important selling points when it comes to cloud computing, which is that data and applications are accessible from any part of the world as long as you have access to the internet. And finally, you have increased protection for your data and applications. Now you should know that there are several cloud service providers in the market right now, be it Amazon Web Services, Adobe Creative Cloud, Google Cloud Platform, and so much more. Now among all these platforms, there's one that's growing really fast, and that is Microsoft Azure. Now let's ask the question, what is Microsoft Azure? Microsoft Azure is actually a cloud service platform that allows users to build, manage, scale, and deploy applications by giving them access to cloud services. Now these cloud services range from creating virtual machines to creating functions that run themselves without having to worry about hardware. Now all of this is made possible only through the internet. Now here are some things that you need to know about Azure. Firstly, it was launched on the 1st of February 2010. It has data centers in more than 42 regions across the world. They also say that 12 more data centers are in the making, which helps them say they're the only cloud service provider that covers these many regions. Next, Azure is preferred by 80% of the Fortune 500 companies, which means that the best of the best in the market only choose to work with Azure. And finally, Azure is the second largest cloud service provider in the market right now. Let's talk about Azure Services. As I told you, Azure provides services for a wide range of domains. Now let's have a look at some of these domains. There's AI and machine learning, compute, containers, database, identity, management tools, networking, security, storage, and so much more. Now let's have a look at some of the individual services within these domains. Firstly, you have Azure Virtual Machines. With Azure Virtual Machines, what you get is the opportunity to create Windows or Linux virtual machines. Now, all of this is possible in a matter of seconds with a large amount of customization. Now, let's have a look at some of its features. Firstly, you can choose from a wide variety of virtual machine options. Then you have a large amount of optimization available to you. For example, what size of operating system do you want? How much size do you want allocated to it? What version of the system is it? And so much more. Then it provides low cost and per minute billing. Now, Azure provides you per minute billing, which means that you're only charged for how much time you use the service. And finally, you have enhanced security and protection for your virtual machines. Next, we have Service Fabric. Now, with Service Fabric, you have a platform which enables you to create microservices. Now, this also makes the process of application lifecycle management a whole lot easier. As a direct result, you can create applications with a faster time to market. It supports Windows, Linux, on-premises, or other clouds, and it enables you to do a tremendous amount of scaling up depending on your requirement. And finally, we have functions. Now, with functions, you can build applications with the help of serverless computing. Here, the users only pay for the amount of resources that they've used. You can create applications in any language that you want, and the only thing you need to worry about is the code of the application. Everything other than that, that is the hardware requirements, are taken care of by Azure. Now, let's have a look at the networking services. Firstly, we have the Azure CDN, or the Content Delivery Network. With Azure CDN, what you get is the ability to deliver your content with reduced load times, fast responsiveness, and less bandwidth. Now, CDN can be integrated with several other Azure services so that the process can move at a faster rate. It can handle heavy loads and traffic spikes with ease. It also provides a robust security system. Now, with the content that's delivered, you can get advanced analytic data with which you can understand how customers are using your content. Next, we have ExpressRoute. With ExpressRoute, you can connect your on-premises network to Azure through a private network. Now, by default, this lowers latency. It increases the emphasis on reliability and speed, and it can be of great use when you have to transfer large amounts of data between networks. Now, another way this can be useful is if it's used to add compute or storage capacity to data centers. Next, we have Azure DNS. Domain Name Service, or Azure DNS, can be used to host your domains on Azure. This provides high availability and great performance. It provides fast responses to DNS queries by taking advantage of Microsoft's global network. It also provides high availability. Next, we have Virtual Network. Azure Virtual Network allows the Azure resources to communicate with each other or other on-premise networks via the internet, and all of this is kept extremely secure. Now, with this, users can create their own private network for communication. It provides users with an isolated and extremely secure environment for their applications to run. Now, all of the traffic stays entirely within the Azure network, and it also allows users to design their own networks. Next, we have Traffic Manager. Now, with Traffic Manager, you can route incoming traffic to improve your performance and availability. Now, one thing it provides is multiple failover options. So if a particular situation goes wrong, there's always an option to consider to salvage the situation. It helps reduce application runtime and enables the distribution of user traffic across multiple locations. It also helps the people who are using it to know where the customers connecting from across the world. Next, we have Load Balancer. With this, you are provided the ability to instantly scale applications at the same time providing high availability and improved network performance for users' applications. It can be integrated into virtual machines and cloud services. It provides highly reliable applications. It also allows users to secure and integrate security groups. Finally, we have Azure VPN Gateway. Now, this allows users to connect their on-premise networks to Azure using a site-to-site VPN. Now, this allows users to connect their virtual machine to anywhere in the world through a point-to-site VPN. And also, it's very easy to manage and is highly available. Now, let's talk about the storage services. First, we have Data Lake Storage. Now, with this, what you get is a scalable data storage with an emphasis on cost effectiveness and scalability. Now, it comes of maximum use when you've integrated with other services so that you can get analytics on how the data is being used. It is also integrated with other services like the Azure Blob Storage. Now, it is also optimized for big data analysis tools like Apache Spark and Hadoop. Next up, we have Blob Storage. Now, Blob Storage provides a storage capacity for data. Now, depending on how often a particular data is used, it is classified into different tiers. Now, all the data that is within the blob storage is unstructured data. Now, it has a way of ensuring that the data integrity is maintained every time a particular object is being changed or the data is being accessed. And it also helps improve app performance and reduces bandwidth consumption. Next, we have queue storage. Now, with this, you have a message queuing system for large workloads. This allows users to build flexible applications and separate functions. Not to mention, with this, you can be sure that your individual components will not fail. It also makes sure that your application is scalable. Queue storage provides queue monitoring, which helps ensure that the customer's demands are met. Then we have file storage. Now, with file storage, you can perform file sharing with the help of the SMB protocol or the server message block protocol. Now, this data is protected by SMB 3.0 and the HTTPS protocol. In this case, like we mentioned in functions, Azure takes care of all the hardware needs and the operating system deployments on its own. It also improves on-premises performance and other capabilities. Lastly, we have table storage. With table storage, you can deploy semi-structured datasets and an NoSQL key value store. Now, this is used for creating applications which have a flexible data schema. And also, considering how it has a very strong consistency model, it's mainly aimed for enterprises. Next, let's have a look at some web and mobile services. First, we have the Azure Search. Now, with Azure Search, you get a cloud search service which is powered by artificial intelligence. With this, you can develop web applications as well as mobile applications. Now, one big advantage is that you don't have to set up or manage your search indices. Azure takes care of that. And by extension, it increases your development speed. The artificial intelligence also will provide insights and structured information that you can use to improve the search and structured information. Next, we have logic apps. Now, with this, you can create integration solutions which can connect applications that are important to your business. Now, with this, you can visually create business processes and workflows. You can integrate SaaS or software as a service applications and enterprise applications. And more importantly, it allows you to unlock data within a firewall and securely connect to services. Next, we have web applications. Now, with web apps, you can create, deploy, and scale web applications according to business requirements. Now, it supports both Windows and Linux platforms, and it helps with continuous integration or deployment abilities. Another very important aspect of this is that the data can be deployed and hosted across multiple locations in the world. And finally, we have mobile apps. With mobile apps, you can create applications for iOS, Android, and Windows platforms. One advantage is that it automatically scales up and down based on your requirements. Now, in situations where you have network issues, offline data syncing ensures that your applications work anyway. And you can create cross-platform applications or native applications for iOS, Android, and Windows. Next, let's have a look at some container services. First, let's talk about ACS or Azure Container Services. It is also known as the Azure Kubernetes Services, as it's a fully managed Kubernetes container orchestration service. Now, what this means is that it eases the process of container integration and deployment. It also can be used with other resources from security like virtual networks, cryptographic keys, and so much more to ensure that your container is kept secure. Next, we have container instances. Now, this is similar to functions in a way, just that in this we're using containers without having to manage servers. Now, applications can be developed here without managing virtual machines or learning new tools. All that is Azure's problem to take care of. And it enables building applications without having to manage the infrastructure. That is, all you need to worry about is running the container. Next, let's have a look at some database services. First, we have the SQL database. Now, with SQL database, what you get is a relational cloud database service. Now, this means that it helps accelerate your app development and makes it easier for you to maintain your application. Now, SQL database is also used extensively in migrating workloads to the cloud, and hence saves time and cost. It also helps improve your performance by integrating machine learning and adaptive technologies into your database. Next, we have Azure Cosmos DB. Now, this is a globally distributed multi-model database service. Now, what this means is that with this, you can create applications which support NoSQL. It provides a high-grade security system, has high availability and low latency. Now, this is usually used in situations where you have a diverse and highly unpredictable workload. Now, let's have a look at some security and identity services. Firstly, we have the Azure Active Directory. Now, if you want to know more about Azure Active Directory, I suggest you click on the top right corner and watch our video on the Azure Active Directory. This is just an introduction. So with this, you can manage user identities and you can make sure the resources are kept safe with the help of access policies. Most of these are intelligence driven. Now, one of the main features is that you can have access to your applications from any location or device. It helps increase your efficiency and helps down cutting costs when it comes to having a help desk. It can also help improve security and can respond to advanced threats in real time. Next, you have Azure Active Directory B2C. It helps provide customer identity and access management in the cloud. Now, protecting customer identity is extremely important for an organization, and that's what Azure AD B2C does. Now, it also enables the application to be scaled to great amounts, even billions of customers. Next, we have the Azure Security Center. This is basically like a command post with which you get a complete view of the security across users on your on-premises and cloud workloads. So with this, you're given a threat protection method that adapts to situations and helps reduce exposing you to threats. It also has rapid threat response and makes the process of finding and fixing vulnerabilities a whole lot easier. Next up, let's talk about monitoring and management services. So first, let's have a look at Azure Advisor. Now, Azure Advisor is basically a guide for the best practices when it comes to Azure. Now, when you follow these, it improves performance, security, cost, and increases availability. Now, it also learns from how you use the services on your configuration and usage pattern, and the adjustments that it suggests can be implemented very quickly and easily. Next, we have Network Watcher. Now, with this, you can monitor, diagnose, and understand the working of your network. Now, you can monitor your network without actually having to log in to your virtual machine. Now, you can also use something known as network security flow logs to understand the traffic pattern, how much traffic is coming towards you, how much you're giving, and so much more. It also helps diagnose VPN problems that you might have with detailed logs. And finally, you have the Azure Resource Manager. Now, with this, you can ensure that the resources that you have are managed and deployed at a consistent rate. Now, this makes it extremely easy for you to manage and visualize your resources that are used in your applications or some other requirements, and you can control who can access your resources as well as perform actions on it. And now, let's have a look at how we can use one of these services to satisfy a particular requirement. So the friend asks that she needs one last bit of help. She wants her friend's help to host a website on Azure, and here's how we can do it. So now we're going to put one of these services into action. So this is the Azure dashboard. So from here, we are going to create a virtual machine within which we are going to create a website. A very simple HTML website nonetheless. So let's get started. So first what we're going to do is create a resource group. So what a resource group is actually a repository of all the resources like virtual machines or storage that you're going to use in your project. So in this we need a virtual machine, so let's get that created. So first we'll name it demo ECS and we'll create it. Now this will take a few seconds and that's it. So now that that's done, we go on add. So we're going to be using a Windows operating system, so we'll just search for virtual machine. We select this and create. Okay, so here we are going to set up, we're going to select the resource group, the one that we just created, a virtual machine name. Okay, this storage and name. Passwords, and then just breeze through the rest of it. We can reduce the size, we don't need it this big. And create. Now that the validation is done, the next step is to create. Now this will take a few minutes, so we'll wait. And as you can see here, the virtual machine has been created. We'll go to resource. So here all we need to do is connect and download the RDP file. Let's see if we run this file and see what happens. Now this error shows up in a whole lot of systems that I've used. So there's a very easy way to troubleshoot this problem. So here's what you need to do. Now, so these are the problems. As remote access to the server is not enabled, the remote computer is turned off, the remote computer is not available on the network. So what we're going to do is go to networking and add an inbound port rule. Now we're trying to access a computer remotely, right? So to remotely access the computer, we would need to add an inbound port rule. So that's what we're going to do right now. So we can keep the source as any, port range as any, and our destination port as 3389. If you've noticed there, we'd actually have used the 3389 as the inbound port. And then we change the name as 3389. And this rule is added. Now after this is done, all we need to do, you can see here that if you refresh the page, this would be here. A new rule has been added now. So we'll go to overview and try to connect again. Do the same thing again. And this time it worked. So here we'll input the name and our password. And that's it. Now we just press yes. And there you go. The system has started. Now your virtual machine is started. Now in a while, the server manager will pop up. So there's some things that we need to do so that we can host the website. So the first thing is to create an inbound port. So we'll turn off the virtual machine for now. Come back to that later. First we'll go to our resource group. Check the name of our resource. And then we'll look at all its resources here. So here we need to find the network security group and add an inbound security rule. Press add. We take any source port range, and then we add port 80, which is the one that we're going to use, and we'll put the name as port 80. We'll add the security rule. So it'll take a few seconds. And that's that. Now it's allowed. Now let's go back to our virtual machine. Here you go. And let's get it started. Log in again. And there you have it. It's on again. Now we'll go to Server Manager. So we need to add roles and features. So most of this we can just run through. We'll leave them at the default values. Same. And here we need to add a web server, which is the IIS. So we'll select this. We add the features. Next. So we can add the .NET 3.5 features as well. Next. And we'll install now. Now we'll wait for the installation to finish. And now the installation is done. So now what we're going to see is if the website can be reached. Now we'll go to the public address which is given here. So we've come back to our original system. Click. And you can see that the IIS page has been created. Now we need to work more to create the HTML page. Here's what we'll need to do to run our website. So right now what we're getting is this, the IIS page. Now let's make it our own HTML page, a very simple HTML page. From there on we can create the website. So we go back to the virtual machine and then we go to C drive. So the IIS is located in a location which is in C drive, init and www root. So if you click on this, actually what you'll get is the page I showed you earlier, which is this one. So now we'll go to the server manager, click on tools and find the IIS manager. So we click on this and sites. Now there's a default website. We can now add a new one. the site name, demo. We need a physical path. We'll put it inside the folder we just saw, which is right here, C drive, init pub, www root, within which we'll create a new folder for Simplilearn demo. We save it and port 80 and okay. Now this is assigned to another site, so we'll change that, but we'll wait for that. Okay. Now for this, we'll just change it. We'll click on this. So since both of them have the same port, we'll change that. Go here, edit binding. We'll change this to something else. Okay, and close. So now both are different, and now we can start our website. It's already started now. Now we'll start the website. Right click this, so manage website, and start. And that's it. Now we will go to the init pub, www root, and we have Simplilearn demo. So here we will create the HTML website, or the HTML, the document. So index.html. Okay. Open this. It's a very simple website now, so we keep it, save it. And so here, what we're going to do is save as an HTML file, but for all files. We close this. Now to make sure this is recognized as a .html file, we'll go to View, Options. Here we'll hide extensions for known file types. We'll just rename this. And there you have it. It's a .html file. Now let's go back to our original computer and run this page. And there you have it. Now this is just the initial version. More work has to be done on it, but your first step is already done.
We'll be talking about machine learning in Azure. Before we move on, let me tell you what Azure is. So Azure is Microsoft's public cloud computing platform. It provides you with various services like compute, analytics, networking, and storage. So you can pick from these services to develop and scale new applications or run existing applications in the public cloud. Okay, so once you log into your Azure portal and select machine learning as your service, you'll be redirected to this page. Now on the right hand side, you can see there's an option called My Workspace. So once you click on My Workspace, it will take you to a new window, which is Machine Learning Studio. But before that, let me give you a small idea of what My Workspace is. So any data that we get into our Machine Learning Studio, we analyze it, and that is presented under My Workspace. Now on the left hand side, you can see there are a few options under Machine Learning Studio page. So let me go through those options one. So the first option is projects. So project basically gives you a list of all the experiments that we have worked on. Then comes experiments. So experiments are all the programs that you work on to create a model. After that, it's web services. So since Azure is a cloud computing platform, we know that all the data needs to be uploaded over the cloud. By data, I mean all the experiments that we have needs to be uploaded over the cloud. So web services gives you a list of all the experiments that we have and is over the cloud so that you can access it from anywhere. Then comes notebooks. So notebooks are basically space where you can explore analytics, you can create your own code, you can visualize it, and at the last you can share it with your peers. Then is datasets. So the dataset gives you a list of all the datasets that you have in your Azure portal. Now when you click on sample, these are all the sample datasets that Azure has provided as to the users. Now comes train models. So while working in an experiment, you'll come to a point where you need to train your model. So this gives you a list of all the models that you have trained in your Azure program. Then at the last you have settings. So any changes that you make is done under settings. So now that we are done with this, let's go to the next half of our Azure tutorial. So on the left hand side, you can see there's an option called new. When you click on new, it will open a window. So this window gives you a list of all the templates that we have in our Azure Machine Learning Studio. Okay, so since we are working from the scratch, we'll be working on blank experiment. So once you click on blank experiment, a new window appears. Okay, so let me go through the components that we have here. So on the left hand side, you have the components. At the center, you have the canvas where your experiments will take place. And on the right hand side, you have properties. So today we'll be working on problem statement, which says that we need to find out the income of an individual whose data we don't have in a system. Now let's go on to the component part and find the best data set that can suit our problem statement. Okay, so we see that we have list of data set in our samples. So the very first data set is adult census income binary classification. So we'll select a data set and drag it over to the canvas. But before that, let me give a name to our experiment. So we'll give the name as income prediction. Now once you click on adult census income, you can see there is a circle. Press right click and 4 options appears in front of you. The first one is download, the second is visualize, third is generate access code, and the last one is notebook. Since we need to visualize the data set, we'll click on visualize. So once you click on visualize, a new window appears. On the left hand side, you can see there are 32,000 rows and 15 columns that we have in our data set. But before that, let me go through all the columns that we have here. So the first one is age, which tells you about the age of a person. Then is work class. So this gives you an idea whether he's a government employee, is he working in a private sector, or is he a self-employed. Then is FNL WGT, which is the sample weight of the field. Then is the education. So education is basically telling us about his highest degree. Whether is it bachelor's, is it high school grad, or is he a master's. Then comes education number. So this gives you an idea of the number of years he took to complete his education. Then is marital status. So this is telling about a person's, is he married or whether he has never married. Then is occupation. So occupation is actually important while finding out the income. So if a person is a manager, there are chances he will be earning more as compared to others. Then is relationship, whether he is a husband, is she a wife, or has he never married. Then comes sex, whether he's a male or the female. Then is capital gain, capital loss, hours per week. So this gives you an idea of number of hours a person is working in a week. Then is native country. So income varies from country to country. So getting to know about the country is also very important while predicting our model. And at the last, we have income. We see that the income column is divided into two halves, which is above 50 and below 50. So there are two distinct values in income group, and in cases like these, we make use of classification algorithm. Now let's go to the next part, which is where we will define the fields that we need to have for our prediction. So what we do here is we select the column. So on the search bar, when you type column under manipulation, you get a list of options. From that, you select column in dataset and drag it over to the canvas. Now connect your dataset with select column in dataset. Now under this, you can see there's a caution which says that value required. So you go under properties and select launch column selector. So once you select launch column selector, window appears. So this gives you a list of all the columns that we have in a data set. So the very first column that we have here is age. So age is actually important in understanding the income of a person. Then comes work class. So the background of a person, whether he's working in a government employee or is he a private employee, is also important for prediction of income. Then comes education. A person who has a master's degree has more chances of earning than a person who has a graduation degree. So education is also an important field while predicting our income. Then what comes next is occupation. After that you have country, and at the last we'll work on income. Now when you press next, you get back to the same window. So now that we know the fields that we're working on, our next step is to find the algorithm that best suits our model. Okay, so now that we know the fields that we have to work on, our next step is to find the best fit algorithm for our model. So what we do here is we look at the list of algorithms that we have. But before that, we know that our target value is divided into two classes. So the algorithm that we'll be working on is a classification algorithm. Now Azure provides few classification algorithm like logistic and decision tree, two-class boosted decision tree. So we'll be working on two-class boosted decision tree because this gives you a high accuracy rate. Now let me give you an idea of why two-class boosted decision tree is taken over all the other classification algorithm. So what happens in two-class boosted decision tree is for every node that we have here, the accuracy is calculated. And once the accuracy is above our required accuracy, then only it moves on to the next nodes. So this gives you a high, so the prediction value here becomes more and more towards a higher side, so that the overall model will give us a very high accuracy. Okay, so our next step here is to train the model. So on the search bar again, just type train, and under train, you can see there's an option called train model. So drag the train model over the canvas and connect the two class boosted decision tree with this. Now you can see that it says that it requires a value or a data, which is obvious because it does not have any data to work on. So our next step here is to split the data. So on the search bar, when you find split, it gives you an option called split data. When you drag the split data over a canvas and connect it with your column data, it asks you for the split percentage. So you split the data into training and testing. So 80% of data gets into the training model and 20% goes into the testing model. So what we do next is we connect 80% of training data with the train model. But you see there's a value required. This is because the model is not aware of the column it needs to train on. So what we do here is we go on launch column selector and select the column. So we need to work on income column. So when we select column and press enter, we see that the question mark is gone. Now our next step is to find the score of the model. So what score does is it gives you the prediction value of the model. Okay, so when you connect your train model with the score model, you again see a caution sign here. This is because it does not have idea of what it needs to test on. So you connect your testing data with your score model. So our last step here is to evaluate the model. So on the search bar, when you type evaluate, you get an option called evaluate model. You drag the model here on the canvas and connect it with the score model. So your model is now complete. Now our next step is to save the model and run it. Now once our program is executed, click on evaluate model. Once you click on evaluate model and press visualize, a window will appear. This shows you the performance of the model. You see that the accuracy is 79, which is considered to be good. Now let me go through all the other options. You see there is an option called positive label and negative label, which has been assigned values of above 50k and below 50k respectively. Now let me tell you what these values are. So this part is known as the confusion matrix. So of all the values above 50k, true positive give me value that are predicted correctly and false positive give me value that are not predicted correctly, which means that 6 out of all the value that we have in positive label, 667 have been predicted right. That is, they have their salary above 50k and 422 have been predicted wrong. Similarly, there out of all the people that we have, 840 have been predicted wrongly. That is, they have salary of above 50k but have been predicted below 50k, and 4091 have been predicted correctly. Now this is used to find the accuracy of the model. So what you do here is you sum the true positive with true negative and divide it by false positive, false negative, true positive and true negative, and then you multiply it by 100, and that's how you get your accuracy. Now let us go back and run this service over the net. So when you click on set a web service, you see predictive experiments. Click on predictive experiment. Now our next step is to connect a web service input, that is the entry point, with the score model. So what it does is, once the program is over the cloud, it directly connects to the score model and shows us the output. So you don't have to go through all the processes now because the machine is automatically learning. Now you save this and press run. This will execute the entire model. So once this is done, all that is left with you is to deploy web service. So once you click on deploy web service, it will take you to the dashboard. So you see an option called test. Once you click on test, it will take you to a window where it will ask you for values. So let's just say that I have a value of person age 35. Let's say he's working in a government. His education is bachelor's. Then his occupation is manager. His country is US. So once I press next, it will give me the predicted value, telling me that he will be earning 50k with a precision rate of 0.12. So this is how you make use of machine learning in Azure.
We are going to talk about the service Azure Active Directory. So firstly, let's ask the most important question. What is Azure Active Directory? Now, here we are in a situation where we have two colleagues having a conversation with each other. So one of them complains that he is finding a hard time managing multiple user logins at the same time. His friend suggests that he has a solution, that the company start using Azure Active Directory. He says that with Azure AD, they'll be able to handle multiple user logins without any issue. So just like the question in all our minds, the friend asks, how is Azure Active Directory going to help us? So to help you understand, let's think about a scenario. Now you're an employee working for an organization and you want to use a particular service, in this case SQL database. So you're assigned a set of username and password. Then you want to use another service, a machine learning service. Again, you're assigned a different username and password. And likewise for any number of services that you want to use. So for every service that you're going to choose, you need to be assigned a new username and password. But this becomes a huge issue for the administrator as they have to handle a large number of username and passwords. Now, if you think about a large organization where there's more than 1,000 people working, you can understand how much of a hassle it's going to be for the administrator. At the same time, it's also a really difficult thing for you to remember that many numbers of username and passwords. It's difficult on the user as well. And that's where Azure Active Directory helps. Now, here's a scenario where we're applying Azure Active Directory. Now, you're an employee, you want to use a particular service, and you're assigned a single username and password. And with this username and password, you can access all the services that you want. So there's only one set of username and passwords that you need to remember. You can use any of the services that you want as long as the administrator has given you access to it. So what is Azure Active Directory? Now, Azure Active Directory is a service that falls under the identity domain. It allows multiple users and is a cloud-based directory and identity management service. Now, here's an ideal scenario. You're joining an office newly. The admin helps you sign up to whatever services you want, and you can access these services anywhere over the cloud. So now let's talk about something different, Windows AD and Azure AD. Now, Windows AD was the previous version of Azure AD. So now we'll talk about why we needed to change from Windows Active Directory to Azure Active Directory. So what is Windows Active Directory? Now it's an OS directory service which allows you to work with multiple systems, multiple network resources in a unified manner. Now the biggest draw when it came to Windows AD was that it had many layers. Now different layers that did different bits of work. So now let's talk about each of these layers. The first layer is ADDS, or the Windows Active Directory Domain Services. Now each layer, as I said before, has a different role to perform. ADDS allows admin to manage information relating to user logins and other details like when they signed up, how much they're using and things like that. The next layer is ADLS, or the Azure Data Lake Storage Services. This layer is for allowing you to store any amounts of data of any type or size. Then you have the ADFS, or the Active Directory Federation Services, where you're given a single option for sign up with which you get access to all systems and applications. Then we have the fourth layer, the ADCS, or the Active Directory and Certification Services. This enables administrators to customize services and then be able to manage and issue public certificates. And the final layer is ADRMS, or the Active Directory Rights Management Service. And this is used for data protection. Now, here's where Azure Active Directory changed the whole game. This means that there's a large number of layers that administrators need to take care of. Now, how about there was a solution for this? And Azure AD is that solution. Azure Active Directory integrates all these 5 layers into 2. And these are the Windows Azure Active Directory, or the WAAD, where it combines all the problems when it comes to identification management, which is almost all 5 layers taken into one. And the Windows Azure Access Control Service enables the federation or the division of all these services of an organization. And by division, I mean assigning each of these services to these users. So that is taken care of by the Windows Azure Access Control Service. Hence, Azure Active Directory is able to simplify a lot of the problems that Windows Azure Active Directory had. For example, the application Office 365 uses Azure Active Directory to manage user identities. Here's how. Now, you're an employee who wants to access one of the Office 365 services, which could be Excel, PowerPoint, Microsoft Word, or something like that. So you go talk to the administrator and he gives you access to these services with the help of a single username and password. Now, as long as you have this username and password and the administrator has given you access to it, you can use any of these services. So who's the service audience? Who is using the Active Directory service? Now, there are 3 types of audience when it comes to Azure Active Directory. The first one is IT administrator, the second one application developers, and online customers. So the IT administrators, their main emphasis is to ensure that the sign-in takes place. They take care of all the sign-in procedures. They also solve issues when it comes to authentication. For example, to authenticate a particular user, the problem is solved by the IT administrators. Then you have application developers who use these services to develop applications. And with this, they have an easier time developing applications as all these resources are easily available. You have online customers who make use of services like Office 365 and other CRM services and have all their demands catered immediately. So now let's have a look at how we can use Azure Active Directory to provide access to a particular individual. So if you log into the Azure account, this is what you see, or you go into Active Directory, a list of all the people who are using or have been given permission to use resources from Azure. Okay, now we're going to create a profile. We need to set up his name, which is John, and second name, Jacob. Now for properties, we need to determine the source of authority, which is already the Active Directory, so that's fine. We can select a group or add them to a particular group if we feel like it. Now, if we add them to a particular group, it means that they have access to all the resources that everyone in the group has access to earlier. So we'll do that later. We'll select their directory role, or we can select it here if we need to. It could be user, administrator, or a limited administrator. And now we'll set up a password. We already got one, and we'll create. And that's it. We have created a user. Now we'll go to their profile. So what we can see here is that you have access to every bit of detail related to this account. So you have the name, your first name, the username, the object ID, job info, everything. You can even have other details like how often they've signed in, when did they sign up. You can check their password, you can reset the password, delete their account, and so much more. Now we can even add a directory role, which we saw earlier. And now let's add this person to the admin group. So, he gets access to all the services that those people have access to, and select. That's it, we've added them. Now the other things that you can see here, there are applications, licenses, devices. These are all restrictions you can add or remove, like which device you can use the system through or with and stuff like that. So that's it. And with that, we've created a user and given him access to certain services. We're going to talk about another important Azure service, Azure Data Factory. Now, why should you be interested in Data Factory? Now let's consider a scenario. So here we have two colleagues having a conversation with each other, and they say that the data that they're generating from their applications or products is increasing exponentially. Now, considering that this data is coming from a number of different products, it'll be a bit of a task to analyze and store all of this data. So he wonders how they're going to manage that. His friend suggests that they use Azure's Data Factory. Now, what does Azure's Data Factory actually do? First, it stores data with the help of the data lake storage. Now, any kind of data can be stored in the data lake storage. Then you can analyze the data, you can transform the data with the help of pipelines, and you can publish the organized data. You can visualize the data with third-party applications like Apache Spark or Hadoop as well. Now, what exactly is Data Factory? So now let's have a look at what exactly is Data Factory. Now, Data Factory falls under the identity domain of services in the Azure catalog and is a cloud-based integration service. Basically, what it does is it works on your data, it stores your data, it orchestrates and automates the movement or transformation of data. It works heavily on the data that you store. Now, let's see how it actually works or how the flow of its processes are. Firstly, we have the input data set, which is nothing but the data that you have within your data store, the one that you need processed. Then you pass this data through a pipeline. Now, what does a pipeline do? A pipeline basically performs an operation on the data that transforms it, which could be anything from just data movement or some data transformation. Now, data transformation is possible with the help of USQL, some stored procedures, or Hive. Now, after this is done, you get an output dataset. Now, this output dataset will contain data that is in a structured form, because it's already been transformed and made structured in the pipeline stage. Then it is given into linked services like Azure Data Lake, block storage, or SQL. Now, what it does is these store information that is very important when it comes to connecting to an external source. Now, this is, if you wanted an example, how in an SQL server you need to mention the source and destination of your data. Now, for example, consider an SQL server. So you need a connection string so that you can connect to an external device. You need to mention the source and the destination of your data. This is how the link services work. And finally, you need a gateway. Now, a gateway basically connects your on-premises data to the cloud. So you do need a client installed on your on-premises system so that you can connect to the Azure cloud. And finally, you have the cloud. Here what happens is your data can be analyzed or visualized with a number of different analytical softwares like Apache Spark, R, Hadoop, and so on. So all this time I've been mentioning that data lake is a very important part when it comes to Azure Data Factory's proper functioning. So now let's talk about what exactly is data lake. Now data lake is a data storage or a file system which is highly scalable and distributed. It is located in the cloud and works with multiple analytics frameworks, which is external frameworks like Hadoop, Apache, and so on. So now let's have a look at it. So first you have your output data set, which is data from the mobile, video, web, social media, so much more. It is sent into the Azure Data Lake store, and then it is provided to external frameworks like R, Apache, and Spark so that they can be worked on. Now, there are two main concepts when it comes to data lake storage. So one of them is storage and the other one is analytics. Now, storage is of unlimited size. It can be petabytes, terabytes, gigabytes, and so much more. It stores a wide variety of data. It could be unstructured or structured data, and it can store really large files. And another concept when it comes to data lake is analytics. Now, how it works. Now, here are two examples of how analytics works when it comes to data lake. Now, when it comes to analytics, you can monitor and diagnose real-time data. For example, data that you're getting from vehicles or buildings. These can be used to optimize how they work, respond to certain events, or generate alerts in case something goes wrong. Then you can also identify fraudulent transactions on your credit card, or you can identify the geographical position of your card. Perhaps monitor how many transactions have been taking place on that card, and so on. So now we're going to have a look at how we can use the Azure Data Factory to move data from an SQL database to a blob storage on the cloud. So here's what we're going to do. So first off, to make a database, what you're going to need is software known as SSMS. So you can find it on Google. You just need to Google it, SSMS. The first link you can take here, and there you have it. So you just need to click here and download the file. So I've already downloaded the file. So basically this is used to create a database which we'll be transferring to the blob storage. So this will take about, depending on your computer speed, pretty long or little to no time. I've already downloaded it. The process is very simple. Just directly go on saying yes, yes. And finally, once the installation is done, here's what we're going to do. We should go into the dashboard of Microsoft Azure. We need to create a data warehouse. So we'll go into all resources, create resource, go to database, and select SQL data warehouse. There we have it. Now, it's very important that you remember the names of the service of everything that you're going to write here, because each of these become very important later on. So I've already set up a possible set of names. YouTube, it's free trial. The resource is already created. A blank database. The server, we need to create a new one. So we'll name it as YouTube server. YouTube admin as the server admin login. The password as alright, the location does not matter. Okay, that's done. Now here the server is done, and here we need to change how much you want the lowest, how much computation you want, how much the workload, how important your workload is. So we'll put it at the lowest since we don't require much. We'll apply. The rest is normal and create. So now we're creating an SQL data warehouse. So we'll wait. So now the deployment is done. So we'll go to the notification and go to the resource. Here, now this is done. So we'll go to the SSMS, which I've already opened here, and then go here and copy this. Paste it here. SQL authentication, login, which details we have already stored here, which is admin, YouTube admin, and the password, which is also given there. Right. Go to options. We go to the database name, which is YouTube. Everything else is there. We need to change it to TCP/IP and connect. We sign in. We'll add the password. Again, we're going to sign in now. Right. So now that that's completed, you can see that this is what will pop up. So this is the name of the server we've given, as you saw earlier. You go to databases, and here you have the YouTube database that we just created. Right click this and add a new query. I already have a code for this program. It's a very simple program, so copying and pasting this. Now, if you need the code for this program, let us know in the comments below. It's very simple. What we're doing is creating a table called demo tab with first name Clark Kent and last name is Bruce Wayne, and the table that's created will have these 2 rows. So now we're going to execute this. And there you have it. 2 rows have been affected. So now let's have a look at our table. Execute this line, and there you go. The table's here. So now that this is done, we're going back into Azure, and we need to create a storage account. So that's where the blob storage is going to happen. So we're going to storage accounts and click on add. So here it's a free trial. Resource group is YouTube. Storage account name is Simply Store. That's all. Okay. US performance is standard. General purpose you can do locally, since we don't need it to be very reliable, at least for this one. Advanced is fine. View and create. That's done, and we create. Now we'll wait for the deployment to finish. And that's it. The deployment is done. So we'll go to the resource and go to blobs. So this is where the storage is happening. We need to create a blob. Simply blob, which does not exist. And okay, it has been created. Now for the next bit, we need to create the data factory now. So we go to all services, search for data factory. We press add. So here we'll free trial, use existing, which we have YouTube, ECS, and create. So now we've created a new data factory. Now we'll wait while it's being deployed. So now it's created. So we'll go here, and here we click on copy data, and this opens up. So we'll name it. Now description, run once now. Okay. Right, so we press next. So we need to connect to a data source. So what you need to do is select Azure SQL data warehouse. So one second, go to previous. Here we select Azure SQL data warehouse. Go here, search for source, Azure subscription, free trial, here YouTube server, and the database is YouTube. You also need to provide your username and password. I've saved it here. YouTube admin. Right. Okay, now we can select the table, which is demo tab. Next. And now for our destination. So where are we going to connect this to? We're going to Azure Blob Storage. Next. Destination. Azure subscription free trial. And Simply Store. Now we need to name our storage path. Next. All of this can be passed on. So here's what we're doing. We're copying whatever is inside this to the Azure Blob Storage. That's what's happening right now. All of that is set, and next. It's validating, and we'll wait now. It's registering connections, creating database, and in the end it's creating a pipeline. So you can monitor the pipeline from here if you feel like it. Now, here's what we're going to find. So here's a visual representation of what's happening. It's being copied into the blob storage. Now let's have a look if it's actually worked out. We go to our database. We'll go into storage accounts, Simply Store. Go to blobs. We've created a new one. And there you have it. So based on the container that you've named there, it's created a new one here. So actually I had earlier created the name called simply blob. But as you can see here, as long as you name a container, it will create a folder inside which you will find your particular thing that you copied. And that's it. You've copied data. Similarly, you can do a number of multiple operations on this container, on the pipeline you just created with the data factory. And that's that.
Today, we are going to learn about the Azure Virtual Machine. So, without further ado, let's get started. Before getting in depth, let me tell you what's in store for today. First, I'll be talking a little about Azure. Next, I'll start off by explaining the Azure Virtual Machine. Then, I'll be focusing on few benefits of Azure Virtual Machine. Moving forward, I'll be going in depth with the Azure Virtual Machine components. And finally, we will be looking into a demo on Azure Virtual Machine. All of us may have heard of Azure at one point of time, but what is Azure? Let me explain. Azure is a cloud service created by Microsoft for building, testing, and managing applications and many services through the Microsoft data centers. The Azure hosts web applications over the internet with the help of these data centers. Azure is very flexible. It gives an option to have the functionality as required. You can pay as you consume, switch to Azure, and accommodate the business fluctuations. There is no need to worry about the infrastructure all the time. Azure is very reliable and has 24/7 tech support. Azure offers pay-as-you-go pricing and hence it is very cost-effective. Staying online all the time ensures customers or users trust. Azure supports backup and disaster recovery tools. Now we know what Azure is and its key benefits. Let's now move on to Azure Virtual Machine. Before that, let's consider a scenario. Rachel had to host 10 virtual machines at once for a project. There was an issue when her computer RAM was not compatible with the instances. The computer RAM was only 8 GB and the instances that required were 10 GB. Then she says, I wish there is a service that's cost effective and also provides extra RAM memory. One of her colleagues heard this and he comes up with an idea. He says, can we use Azure Virtual Machine? It has a pay-as-you-go pricing and has disks for storage. You can pay for what you use and create any number of instances with high storage capacity. Also, if any technical difficulty arises, you can easily retrieve the files through the backup server. So now she's happy and she wants to know more about Azure Virtual Machine. Azure Virtual Machine is one of the wide range of services that Azure offers to create your instance. A virtual machine is a computer file, typically called an image, which behaves like an actual computer. It runs in a window, giving the user the same experience on a virtual machine as they have on the host operating system itself. Multiple virtual machines can run simultaneously on the same physical computer. Each virtual machine provides its own hardware, like CPUs, memories, and other devices. Azure Virtual Machine offers a high range of flexibility and it maintains the physical hardware that runs on it. Let me explain some of the benefits of Azure Virtual Machine. First, we have easy development and test. Azure Virtual Machine has a quick and easy way to configure the computer that is required to code and test an application. Next, agility and scale. Azure Virtual Machine is agile and the ability to clone and spin up multiple instances of the same virtual machine allows us to scale services and applications rapidly, efficiently, and very cost effectively. Azure Virtual Machine provides enhanced performance. Demands for applications can fluctuate, so you pay for the virtual machines you need and shut down the unnecessary ones to save the cost. Azure Virtual Machines provide extended data center and can be easily connected to an organization's network. It is easy to set up your redundant infrastructure on Azure, and Azure provides a full disaster recovery site at a fraction of the cost. Furthermore, let me explain Azure Virtual Machine components in details. Virtual Machine comes under the compute domain of Azure. It also offers various services like availability sets, snapshots, disks, images, and many other services like hosts. Virtual Machine can be clubbed with other services like disks, images, availability sets, hosts, and many more. So, the first component and the most important component is the operating system. The operating system creates connections to the remote desktop session host. There are many operating systems available like Ubuntu, Red Hat, Linux, Windows Server, CentOS. You can also set the operating disk size so that the memory is not wasted. The next component is disks. Azure Virtual Machines use attached virtual hard disks for storage. There are two types of virtual hard disks. First is an image. It is a template for creation of new Azure virtual machine. Then we have disks. It is a bootable virtual hard disk. All durable disks are backed up by page blobs in Azure storage. Therefore, the disks inherit the benefits of blob storage, high availability, durability, and many more. The disks are mounted as drives on the VM. The next component is virtual network. Many components operate the virtual machines in a scalable and secure manner. Virtual networks could include equipment such as separate network spaces for internet-facing and backend servers, load balancers, firewalls, and more. Many of these components are deployed into an Azure Virtual Network. Azure Virtual Network provides many features such as subnet, IP address, load balancer, and network security group. Another important component of Azure Virtual Machine is availability sets. If in case there's a slight chance there could be a failure in physical servers, then these come into picture. So in case of such failure, the Azure platform will migrate the failed virtual machine to a healthy host to reconstitute the VM. It is highly recommended to deploy at least 2 instances of the virtual machine, and virtual machines placed on an availability set perform identical set of functionalities. Now that we know what Azure Virtual Machine is, let's look into the demo. In this demo, first we are going to create a virtual machine, connect it, and then create a web server and modify the web server, and finally launch the web application. So let's go ahead into the demo now. So the first step is to log into Microsoft Azure with your credentials. Now let's click on virtual machines and create a new one. So I can put add, and you can use the subscription you want, either pay-as-you-go pricing or free tier. Resource group will create a new one, that is payroll 1. Okay. Virtual machine we can create, I'm going to use VM web 001, and then region I'll be using East US. Then image I'll be using Windows Server R2 data center. Size I'll be using B1MS. Select username root admin, and then password of your choice. And then I'm going to allow selected ports and choose RDP3389 and next. So OS test tab I'll be using standard HDD, and then next. So I can see a default virtual network and a default subnet and public IP as well as default. Then next. You can allow for auto shutdown, but again, it's entirely your choice. I'm going to select an extension to install, and I'm going to install Microsoft Anti-Malware. Create, okay. I'm going to create a few tags now. Let's go ahead with it. So I've created 5 tags. Now review plus create. Okay, so everything seems good. Let's create now. So the deployment is going to take a few minutes. Let's wait for it. Okay, so that's done. Now let's go to virtual machine and see our virtual machine. Okay, so it's been deployed. Now let's get into the virtual machine and copy the IP address. Then hit Windows plus R and open MSTSC and paste the IP address and connect. Let's use a different account. You have to use the administrator account that we created before with the same password. Click OK. Now the remote desktop session host opens. The next step is to click on Server Manager and add rules and features. Click on Next. Select role-based or feature-based installation and click on Next. Then select the virtual machine you've created and Next. And then we are going to select Web Server IIS. Next. Next. Okay, so it's already installed on my computer, but you have to install this. Then let's close this and open Internet Explorer. Let's type in HTTP localhost. Yeah, so now we can see the default browser opening. Let's minimize this and let's try it here. Here you have to just put the IP address. I think there's an issue. Okay, so let's add an inbound port. Networking, select networking and add inbound port. Let's move port 80 and add okay, so it's added. Now let's go and refresh it. Now we can see the default web browser opening. So the next step is to modify the web browser. Let's go ahead with that. Go back to your remote session host. Let's go to File Explorer. So certain folders are created in the C drive. Let's open that. It would be under inetpub. So this is where the default browser is coming from. Now let's make a new text document. Open that and put hello, welcome to this demo by Simplilearn. Save it, close it. Let's rename this as index.html. So this is a text document, so we need to change that. Okay, let's remove this. Okay, that's done. Now let's go back to our Internet Explorer and hit F5. Let's refresh this. Let's try now. Okay, so let's so it's done. Now let's go back to the previous browser and try. Let's refresh. Yeah, that's done.
Hi guys, a very warm welcome. So today's topic is Azure Virtual Network tutorial. Let's look into what's in it for you. So we would be covering why is Azure Virtual Network important, what is Azure Virtual Network is, benefits of using the Azure Virtual Network, components of Azure Virtual Network that includes the subnet, routing, network security group, why these components are required to be created in the virtual network, and how to launch an instance within the Azure VNet or the virtual network. And then we will be seeing one demo in which we'll create Azure Virtual Network subnets and network security groups. So first of all, let's look into why is Azure Virtual Network important. So why Azure Virtual Network is required? So somewhere far away at an office, a company was struggling with few challenges. The company got a bigger projects which lead to the following challenges. That includes poor network connectivity, time-consuming process in building network topologies, could not divert network traffic to its destination on time. So these were a couple of challenges the company was facing. So the employees thought that what could be the possible solution to these challenges? And then we require the Azure Virtual Network in that case. So first of all, let's understand what is Azure Virtual Network is. An Azure VNet or a virtual network represents your network or environment to run VMS and applications in the cloud. When it is created, the services and virtual machines within the network interact securely with each over the internet. So virtual network, you can consider it as a virtual cloud, which is basically kind of a cloud space virtually assigned to the users or to the organization, which they can dedicatedly use for their purpose. So for example, if you have to create some instances or virtual machines onto the Azure cloud, and you want to connect it with the on-prem servers, for example, then you might require the virtual network in that case. Let's assume that those instances that are created in the virtual network require the range of IP addresses that you want to allocate to them, and that is something you can customize using the Azure Virtual Network. How do you want that the traffic should be routed to your instances in the virtual network, how the firewall securities should be applied? Everything the end user can control in the virtual network. So it seems like that you are working in your own data center. Ideally, you would be working onto the Azure cloud using the virtual network. Now, what are the advantages of using the Azure Virtual Network? So a couple of them are, it provides an isolated environment for your application. So as I said that, it seems like that you are working in your on-prem environment. That means within your data center. But ideally, it is a virtual space that is allocated to you, which is a kind of an isolated environment that is specifically designed for your task and the activities. Generally, a subnet in a VNet can access the public internet by default. So we create a subnet inside the virtual network which can access the public internet. So there is a public network connectivity that is enabled in the virtual net, so that a subnet which will be created in the VNet can be accessed. Traffic can be easily filtered from different resources. So you can have some control lists defined, you can have some security groups created, and how do you want to allow the traffic onto the servers or the application? That is something which you can control. It is a highly secure network, and the security groups and the policies are basically implemented by the end user. So you can design how the security should be implemented. High network connectivity, so you have a higher bandwidth as compared to the normal internet connection you might be having in the data center. Compared to that, you use the Azure network only, which gives you the higher network connectivity. It builds sophisticated network topologies in a simple manner, and which is easily manageable. Troubleshooting issues that we would encounter. Now, what are the components of Azure Virtual Network? One of them is the subnets. Then you have routing. Then you have network security groups. Now, what do we mean by subnets? The subnet is one of the major or a prime important component in the virtual network. So what you have to do is, first, obviously you would be creating a virtual network. Inside that, you can create the subnets. Subnets, you can consider it a logical partitioning or virtual partitioning inside the virtual network. Subnet lets user segment the virtual network into one or more subnetworks. For example, let's assume that you're working in an organization, and in the organization there are different departments. For every department, there should be some set of IP addresses that you want to allocate to the machines that the employees are using. Or all the departments should be isolated. That means that they should have their own network IDs and the network addresses allocated to their machines. And in that case, what you would do is you would create the subnets and the subnet IDs that would be allocated to those departments. These subnetworks can be separated logically, and each subnet consists of a server. So what you do is, when you create a subnet, you can create a server or an instance inside that subnet, and how do you want to give an access to that instance depends on criteria or the requirement. Hence, a subnet can further be divided into two parts, one as the public subnet and the other one as the private subnet. These are the naming conventions of the subnet. Then how do you want to give the internet connectivity depends on how the public subnet should be interacting with the internet. And for the private subnet, as the name suggests, that the internet is blocked. So that means it is completely isolated in the virtual network. The private instances, though, if you want that any instance created in the private subnet should have the internet connectivity or an access, you can primarily go with the NAT gateways in that case, which is a network address translation or kind of a translator which converts the private to public and vice versa. And that would actually enable the internet connectivity to your subnets. Then in the public instances, they can directly access the instance. As the name suggests, public instances, that public subnets, that means they have the direct internet connectivity. Next component is routing, and the routing is primarily a routing rules, you can say, that are applied, and those are actually applied to the routers only. So since on the cloud we cannot have a direct router access, and hence using the routing as a component, we can define some routing rules which are directly applied to the router in the infrastructure. It delivers the data by choosing a suitable path from source to destination. For each subnet, Azure Virtual Network automatically routes traffic and creates a route table. When you create a virtual network, automatically a route table is created, and that basically is required to route the traffic, and that can be used by every subnet. That doesn't mean that you only have to create a single route table in the virtual network. You can have multiple route tables also created, which can be associated with different subnets as well. Then you have the network security groups. It is kind of a firewall that protects the virtual machine by limiting the network traffic. It restricts inbound and outbound network traffic depending upon the destination IP address port and the protocol. So it is basically the network security group sits on the instances and or virtual machines, and they basically define that how the traffic should be reaching to the ports onto the virtual machine. So how do you want to open up the ports, and for which IP addresses you want to open up the ports? That is something the end user or the administrator has to specify or design. So they act as a kind of a firewall rules only that protects the virtual machines. So how to launch an instance using Azure VNet? So first of all, you have to create a virtual network. So virtual network act as a container for subnets. So first thing is that you would be creating a virtual network. Then you would be creating subnets which are considered as a subset within the virtual network. So cloud instances included in the subnet. So first VNets are created, then the subnets are created, and then you configure the properties in the security group. Have a look at this in detail. Now with respect to the virtual network, what you need to do is you have to create a virtual network in the Azure cloud. Then you have to create subnets into each virtual network, which is kind of a subset of a virtual network. So you can create one as a public subnet, the other one as a private subnet, for example. Now you have to assign instances. So when you create an instance, you have to specify that what is the virtual network, for which virtual network you are creating an instance. Within that virtual network, you have to select that on which particular subnet the instance should be created. And then connect instance to a relevant network security group. So attach your network security group to the instances, and based on the properties or the rules that are defined in the network security group, that will be applied to the instances within the subnets. Finally, configure the properties in the network security and set the policies. As a result, you will be able to launch your instance on Azure within the virtual network. Now we will be seeing one demo that how we can create Azure Virtual Network subnets and the network security group. So just be there to watch our demo on the Azure Virtual Network. In today's session, I would be showing how you can create the virtual networks onto the Azure. And for that, you require the credentials on Microsoft Azure, and here you can see on my screen that I have already logged in into the Azure console. Now what you need to do is, in order to search virtual network, you can type and search in the dashboard, in the search bar, with respect to the virtual networks. And here you can find the virtual network and the gateways. So what you need to do is you just have to click on the virtual networks, and then it will give you the options to add the components inside the virtual networks. So let me first open up the virtual network. Right. Now, in theory, we discussed that the virtual network comprises of multiple components and subcomponents. So primarily is that first you have to create a virtual network. Then you have to assign the IPv4 CIDR block to the virtual network. And then you create the subnets inside the network, which is a subset of the virtual network. Along with that, you define the routing rules. And likewise, you create the instances inside the subnets that will be part of the virtual networks. So that's what we are going to do in this demo. So I would be adding up a new virtual network. So you can see here there are already two virtual networks that have been added. One is the demo VNet, which is by default. So when you created the Azure credentials, the demo virtual network was already created by the Azure so that it can provide you the default settings. And then the test one has been created by me, and that's the customized one, or you can say a non-default virtual network. So I'm going to add another VNet and would define the name to it. So let's wait for the details to appear. So here you have to define the virtual network to create. Obviously we will be going with the free trial only. And then you have to create a resource group. So what is a resource group? It is primarily a collection of resources that share the same lifecycle, permissions, and the policies. So if you have a resource group created, you can use it. Otherwise, you can create a new resource group. So I already have one. That is the demo one. I would be using that. In the instance details, you have to specify the name of the virtual network. So these are certain parameters that you have to go with while defining the name. So let's say I put something like test VNet as the virtual network that I want to create, and that is, you have to select a region where you want to get that created. So these are the available regions that you can select. I would go with US East US only, and then we have to define the IP addresses also. So in the IP addresses, the CIDR blocks are allocated to the virtual networks, and that becomes a fixed IP address for that VNet. So what you can do is you can specify a range of IP addresses. Now, whenever we talk about a virtual network and the IP addresses, we primarily focus on the private IPs only. So this is the private IP that we are actually talking about. So I can reserve some IP address CIDR for our VNet, and that is the range of 40.0.0.0/16 I'm going to reserve. So now we'll create one subnet, and we'll name that subnet. So as we discussed, that subnets are the subcomponents of the VNet. So here you can see we have already created one subnet with the name public subnet. So likewise, we can add another subnet also, and let's name it to something like demo subnet. Right, and the subnet should have the IP address range, and that IP address range should be part of the VNet only. In V18, so same subnet address range you would be defining in the subnet as well. So that will be 40.0.1. or we can select 2.0/24. The rest of the things would be default. We are not attaching any route table as of now. So just click on OK, and here you can see that the subnet is created. Now once the subnet is created, now we are going to create a virtual machine inside that subnet, and for that we'll go to the search bar, and here we'll type virtual machines. Now we'll create a virtual machine in the same VNet, that is the test VNet, and inside the demo subnet, so that our virtual machine gets the private IP address from the subnet that has been created in the VNet itself. So what you need to do is you have to open up the virtual machines, click on add, and here you should add a new virtual machine. So you should select the name of the virtual machine and the network details, where we would be defining the VNet as well as the subnet where the virtual machine should be created. So in the subscription, we'll go with the free tier, and in the resource group, we'll go with the demo that has already been created. We'll put a virtual machine name, something like test VM, and the rest of the things will be default. So we'll quickly skip the disk check also. Now in the networking, we would be selecting the test VNet as our virtual network, and in the subnet we would be selecting the demo subnet. So that is the recently one added in the test VNet, and we want that our virtual machine should be part of that subnet only. Now obviously, since we are creating a virtual machine, so it should be part of, it should have the public IP also assigned, since from the public network we need to access those virtual machines. So we'll keep it enabled, right? And the next would be the default settings that we are going to proceed with. So let's review all the configurations and then create your virtual machine. So here you can see that our virtual machine has been created, validation has been passed, and it takes a couple of minutes to get that updated. So let's wait for a few more minutes so that our virtual machine is ready. And primarily what we want to look into is that our virtual machine is created in a correct VNet, and it gets the private IP address from the subnet that has been part of the VNet which has been defined in the creation of a virtual machine. So let's wait for a couple of more minutes and we'll look into the status of the VNet. Now you can see here our test virtual machine has been created. Now what we wanted to look into is that our virtual machine is created in a correct subnet or not, and that is something which we can validate by checking the private IP address. So it got the private IP from the range of the IP address that we have specified in the subnet. Now in order to access this particular virtual machine, you have to use the public IP, since we have to access it from the internet. So from the private IP, this virtual machine will not be accessible. So that's the reason that when we created a virtual machine, we allocated the public IP address also for this instance. So that is with respect to the virtual network and the demonstration on it, and how we can create a VNet and the subcomponents of the VNet, how they are associated or interlinked with each other, and that actually creates a kind of an isolated environment on the public cloud, which gives you the understanding that you can work into just like an on-prem environment.
And with that, we have come to an end of this video on AWS and Azure full course. I hope it was informative and interesting. If you have any queries regarding the topics covered in this session, then please feel free to let us know in the comment section below, and our team of experts will be happy to resolve all your queries. Until next time, thank you, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.